And hello, everyone. This is Geekle, and we're getting started. I'm happy to greet everyone here at this our brilliant day, our Worldwide Software Architecture Summit 2023. This is a big day. This is one of my favorite events. I really love it because um, architects they design future, and I'm so happy this community is so powerful at Geekle. I'm so happy. Let's get it started, and just let me know in comments if you can hear me and see me well, and we will get to the opening ceremony. And by the way, please give us a string where you now. It always encourage our team to see from what country, what city, where you actually right now watching this stream and participate this event, because it's really important for us. Because Geekle it was designed as an international community for any country, of course, because we are online, right? And that's why we're really struggling to know where you are. And now I'm inviting here our team, our community member, our brilliant Anna. Anna, jump in, give us few words and your beautiful smile. Yay! Hi, how are
Hello,
you?
everyone. I'm fine, thank you. I think I'll start first. I am in Chennai, India. Yes, we have really all our team members all over the world, so I am like a proof for that. I'm really happy to be here. I'm really happy to see all speakers. I'm happy to see all uh, attendees here. I'm really grateful to program committee members and everyone who helped us to organize this amazing event. It's actually our fifth event that Geekle does for architecture community, and I'm really proud to say it because I hope we'll keep doing it. We'll keep making it better, and now we are even opening new direction. It's IE in software. Architect Summit. So yeah, please don't forget that we also have that direction as well. I'll tell later about that. Yeah, I think it was kind of long introduction. Sorry.
No, it was brilliant. As long as your smile is on your face. Okay, and thank you for joining us. I see a few hundred people are waiting for the first speaker, but first we need to say what we need to say, right? So, first of all, great thanks to all speakers that you contribute your time, your energy, your ideas, your soul actually to the community. You're giving back, and it will always come back to you with your networking, your personal brand, and like your insights, personal and everything. So thank you very much, and to the program committee people, you're awesome. I know how much you helped Anna together all this event, and we're happy to have your names on our website, and thank you very much. Thanks to every person who helped us with this event together. Thank to the community, and yeah, like many things. I don't know, kind of that. And Anna, tell us more about this event. How many speakers? I know it's more than 3,000 registrations here, and we would love to know about like all this idea of this event. Who will be speak? Like, you know what I mean?
Yeah, of course. So yeah, we have 2 days of this amazing event. And today we have a career day, and everyone can join us, can watch us now or later, because this stream will be recorded and it will be on YouTube. So yeah, if your question that usually everyone has, please, if you feel 1 minute that you're tired, don't worry, you can see it later or tomorrow or late today. So don't worry, you'll see it. So today we have career day. We have 4 blocks. We have 13 speakers. All of them are amazing. And please don't forget to share information about the event. You can tag speakers. You can tag insights. You can leave us comments. You can give us questions. Please be active. We really love when you are active. And tomorrow we also have the day for pro architects who really like know everything about architect, but still there is small place for a little bit more information. So yes, tomorrow I hope to give you that a little bit more information. Please Join us tomorrow for ProTrack as well. We'll have 15 amazing speakers who will share the information, their use cases, what they learned, and how to make your work easier, better, and faster.
Awesome. Thank you. So now we understand the all structure and everything.
And one more moment. So yeah, this event is more or less about a classic event and traditional event where we have blocks and we have Q&A session after the block. So each speaker firstly will present their speech presentation, what they prepared for us, and then after block is end, so we will have common Q&A session and all of them can answer for your question. So you can have a answer for question from different point of views, not only from one.
That's our format, yeah. And sometimes people say it's even like better to the most precious or interesting part of the event is when people come together and discuss ideas. So do we have any promotions, propositions, or something, Anna? What do you have? I know you discussed something with Nick.
We always have something. So during the event, we will keep showing you our amazing offers that we have. But first of all, the main one, that first 5 people who wants to buy a ticket for tomorrow can buy it only for $99. So we are trying to do it for you, and please check information down below. And yeah, only first 5 people can buy it just for $99. And during the day, we will show you other proposals that we have for all our other events. I really hope you will like them as well. So please follow, see, and or you can just check our website. We have so many other events. I'll spend another 10 minutes just to tell what we have for you. So yeah, please check our website and follow our updates that will be done.
And now I see people from India, from Pakistan. I see from all over the Europe. People just keep writing where you are now, what country, what city. We really need to know where you are. And to feel like we're doing something really useful and interesting for you. And now, Anna, what should we tell more about this conference? Or because I can't wait to invite here really interesting people who will start this conference and open with us.
Yeah, we'll have so much information about knowledge-driven architecture, about how to event-based testing, about how to make your app efficient, and so many other new features. But I think that the best way to tell what each speech is about is to introduce and to call to the stage our first moderator, who will explain and introduce each of the speakers, at least from the first block, and we will know what is there, what they cooked for us.
Let's rock it. Let's invite guys here.
Let's go. Hi, Otavia.
Guys up here. I don't know.
How is Brazil?
Good morning, good evening. Oh, I'm from Brazil, Portugal right now, so I'm kind of confused.
Okay.
That would be amazing because in this slot, we're going to talk about the principle of software architecture, the consulting of architects, the future, right? Because we'd love to see the future as technical guys in framework, in serverless, AWS, and so on. So it would be so exciting this day, tomorrow. So
yeah, so I think that we can give the stage to you. You're already so energetic and you're already ready to present.
No, come on, you can stay.
yeah, absolutely. Yeah, I understand it, man. But there is a question always. I've been asked for like 1 or 2 months now. Will AI replace? This question, right? Will AI replace us all? And people say no. AI will not replace us, but guys who uses AI, they will replace us. So you need to use AI, and I hope your talk will calm us down, and we're where everything's gonna be okay with us.
Yes, that's easy to answer. I mean, while the client has no idea what you say to AI, we are safe. because they don't have any idea about what they need to do. So you need to understand first and then convert
Absolutely.
that to software. That's why
It's
it's so
really
important
great answer.
to become an architect.
Yeah,
Cool.
absolutely.
I don't want to.
I spent all my evening, last evening, watching how those guys on YouTube code without any like coding. Yeah, like they fix something, but they build some projects and everything. I'm amazing. I really, wow. Okay. Anyway, yeah. I'm sorry for like
Don't
getting.
worry, Eddie. It was an amazing
Yeah,
discussion, but
it's
it's
yours. Just go.
uh, on my mind. It's much easier to create hello world with AI. The hard part is to impact the whole business with AI, especially because we have the human part to understand, to convert, and of course define the software architecture. So
Absolutely,
it's a
but
weird
I'll go to YouTube to find like that holy button, make money, and you have your stage, and let's go.
Yeah,
okay,
because
and
it's time to call the first speaker, and he's already waiting. Already took some of his time. So yeah,
okay.
let's start. And I wish everyone the amazing day. And please follow, subscribe, share. We love you.
Yes, please do it. Everything. The first speaker gonna talk about MVP with AWS Serverless, and the first question that I have on my mind is this person human or AI person or is a bot? But anyway, let's invite him to the stage. Lefteris, uh, the stage is yours.
Hello,
Hi,
everyone.
I say you
Hi,
Don't
personally, and I
be
leave you
human,
for your amazing
I'm
presentation.
human. I'm human.
Oh, you are human. Oh,
I
that's
am
nice to
human.
see.
Yeah.
But
Thank
probably
you
if
so
you
much
if you
for
wanna answer
welcoming
that.
this session. Thank you so much for organizing this event. It's an amazing event.
Yes, yes, it's amazing. So please share your screen so you can.
Of course.
So how about you? Do you think that AI can replace a good architect?
I don't think so.
That's a good one. So where can I follow you? So
Ca- Can
I
can
will
you see
give the
my
links.
screen, right? You can see my screen, right?
Yes, the stage is
Great.
yours.
Okay. So, hello everyone. Welcome to this session. Thank you for joining this wonderful summit by Geekle. My name is Lefteris. I'm a solutions architect at AWS. So in this session, I will take you through the exciting journey of how I built my startup MVP in less than 3 months, the architectural decisions I made, some challenges I had to overcome, and how I leveraged the AWS Serverless ecosystem to build a highly available, scalable, and robust system very quickly. So before we just start, just a bit of background about myself. I come from beautiful Greece, although this picture was taken when I was living and working in London. I have more than 15 years of professional experience. I have held numerous roles, including developer, mainly backend. I have also done front end. I've been lead engineer and architect as well. I have worked in diverse industries such as trading, gaming, maritime, and others. I'm specialized in Java and React, and I have led transformations of big monoliths to microservices. I have also been a blogger. I was writing Java articles for Java Code Geeks. And finally, I have been an AWS instructor for more than 4 years, and I have trained more than 200 people. Finally, what I'm going to talk about is how I launched my startup's platform. So before we start, I just want to make it clear what the key takeaways of this session will be. So first of all, you will not become a startup expert or come up with new ideas or learn how to build a startup from ground up from my session. So I'm sorry if these were your expectations, but I hope you will be motivated enough to build the platform for your startup and learn more about how to achieve that with the AWS Serverless services. So let me tell you some things about the story of how I co-founded the startup. So after having worked in all those diverse roles and industries where I gained significant experience, I thought it was the time to start thinking about building my own startup. So the most important of all was to find the idea that would bring some value to the users. So I got approached by a friend who wanted to build a marketing platform for Greece, a platform where local businesses of all kinds, such as restaurants, bars, gyms, fashion stores, and others, could get the exposure they wanted through an online platform, as this is not a very easy thing for a small business. And this platform would allow the users to get suggestions for local businesses based on ratings and personalized criteria. So I thought the idea was extremely interesting, and it could scale like to millions of users, not only in Greece, but also globally, which would mean like lots of technological challenges for me. So I agreed to join the startup as a co-founder and the technology leader. So although I had a lot of experience in software engineer, I got stuck when I wanted to find the best tools for my platform. So I did a lot of research, and I ended up in asking the same question over and over again. Like, is there a best tool for hosting? There are so many options out there. Like, you can host your platform data centers or in the cloud on AWS, on Azure, Google Cloud, etc. Is there the best tool for backend? Like, we have so many programming languages like Java, .NET, Python, etc. PHP is just a funny thing here. Like, so for databases, we have MySQL, PostgreSQL, so many databases like NoSQL databases, and for frontend, the same thing. So I guess the answer is no. We cannot find like the best tool for the job. So what I did was something that we usually do at Amazon. We work backwards. So what that means is that I had to think about the challenges and the problems I wanted to solve with my platform and architecture. And there I would try to find some answers and the appropriate services and tools for my platform. So I did that, I worked backwards, and what I did was to start thinking about the minimum requirements of the system with regards to technology I wanted to build. And the minimum requirements were, first, the agility. So I wanted my MVP to be developed as fast as I could. I wanted to deliver new features very fast. I wanted to fail fast as well. And I wanted to move from development to production in a matter of minutes without worrying about breaking anything. My second requirement was performance. So I wanted the platform to be highly available, scalable, and performant. I guess we all want that, right? So I set some upper limits about how many users I wanted to be logged in at the same time and load my website, so I could find the appropriate services that meet those limits. Third requirement was to keep the cost very low. This was super important for us as we were a startup, we had no money, and we had to use a pay-as-you-use consumption model and keep the development cost really, really low. And that meant like less than $100 per month. And just to make it clear, this was only for the MVP and not the production system. Last but not least, I wanted expert security on my platform, something that I couldn't really do with my own skills. Now, let's see what I wanted to build for my MVP. First, I wanted to build a public website where the users could search for local businesses, and they could also register to the platform so they could get like recommendations for the businesses. Then a blog where we would write internal articles, and those would show up on the public website and would be linked with the local businesses. And finally, an internal content management system to manage the local businesses and the blog as well. So based on those requirements, I had to filter out the data center option and mainly focus on a cloud provider that offered managed services. So I didn't have to worry about the administration of the servers and the availability and scalability of the system. Now, the most obvious option for me was, of course, AWS, due to my extensive experience with it, and of course, the awesomeness of the platform. So AWS and the AWS Serverless services could give me the agility, the performance, the cost, and the security I wanted for my platform. Now, let's see the core AWS Serverless services I used. And when I'm talking about serverless, I mean that I didn't have to manage any servers, and AWS was responsible for scaling up and down based on the demand and the traffic on my platform. So let's see what services I used there. So to create my APIs, I used Amazon API Gateway, which supports like many features such as versioning, blue-green deployments, rate limits, etc. I used AWS Lambda for the service layer, and I created a microservices architecture for the backend. Now, with AWS Lambda, you just upload and run your code, and it supports a variety of programming languages such as Java, Python, .NET, Node.js, etc. So I used Node.js for the backend, and I will explain later on why I went with Node.js. Now, for my database, I used Amazon DynamoDB, which is a NoSQL database with extremely impressive performance, and I didn't go with a relational database. Now, for the user authentication service, I used Amazon Cognito. I have a separate slide to explain why Amazon Cognito is a great service and has so many features. I used also CloudFront as the content delivery network to improve the performance and latency of my website. And we will see how this works in the following slide. Now, to save my website, to store my website, and also the images for my website, I used Amazon S3, which is a service with unlimited storage and scales, and it's a very highly available service. I used Amazon SQS for the event-driven architecture because I had a microservices architecture. And finally, I used Amazon SNS to send notifications to the users. Now, all those were created using infrastructure as a code with AWS CloudFormation and AWS Serverless Application Model or AWS SAM. Now, I told about CloudFront, so let's see what Amazon CloudFront is and why you should use it on your platform. So on this screenshot, we have all the regions of AWS where all the services and the data centers actually reside. So if your users are located in an area, for example, Greece, where a region might not exist, in order to get like the lowest latency for your application, then you should use the CloudFront edge locations that are shown on the bottom screenshot, which are additional locations, and you can either cache there your static data, such as images or your website data, for example, JavaScript or CSS files, or even call your APIs through the edge locations, and this network will go through the AWS backbone to the region where your services are located very, very quickly. Now, let's see the architectural diagram and flow for my platform, which is a 3-tier architecture with a microservices approach. So when the users load the website, they interact with 3 components. So the first interaction goes through the Amazon CloudFront, which retrieves the website from Amazon S3 and caches it for better performance and reduced latency. The same also happens for the images, which are saved in a different Amazon S3 bucket. Now, as I said, every user API goes through the edge locations with the edge optimized API gateway service, which leverages CloudFront and uses the AWS global backbone to reach to the regions where the actual services exist. Now, all the private APIs in API Gateway are authenticated using Amazon Cognito, which is integrated with Amazon SES and Amazon SNS to send emails and SMS respectively during user registration. Next, the API Gateway invokes different AWS Lambda functions where we have there the business layer in an event-driven microservices approach, which also uses Amazon SQS for the event-driven architecture. Finally, the AWS Lambda functions are integrated with Amazon DynamoDB, which is the main database for the architecture. So, as you can see, the architecture is fairly simple, but there are a lot of challenges in here. So, we will discuss some of them in the following slides. Now, let's go through all the 4 requirements that I have set for my platform and see what services and tools I used to accomplish those. So when I wanted to create my infrastructure, I did not do it manually through the AWS console, but I created YAML templates with AWS SAM and AWS CloudFormation. Now, AWS SAM is an open source framework for building serverless applications. It is an extension of AWS CloudFormation. By using a CloudFormation and SAM, you can easily move your infrastructure between different environments, for example, from development to staging to production in a matter of minutes. You can also move your whole infrastructure between different regions as well. And you can see on the right, this is a YAML template which has code, infrastructure as a code with AWS SAM. And in just a few lines of code, you can create a Lambda function, which is exposed through an API gateway and a DynamoDB table. And you can take this AWS SAM template and move it from development to production very easily. Now, AWS SAM also provides CLI commands to initialize a project, build it, run it locally, and deploy it. So I use those as much as possible, especially when I wanted to do local testing for my Lambda functions and API gateway. I used the SAM local command, which creates a Docker container and simulates the API gateway and Lambda functions under the hood. So next, I wanted to also do local testing for my DynamoDB as well. So the best options I found were either to use Docker image, where you can create a local DynamoDB image and connect with it using your AWS Lambda functions, or by using a jest library if you use Node.js for the backend, of course. And I went with the second option, which was also a great option for integration testing, because I used Node.js, as I said, for my backend. Now, moving on, let's see why Amazon Cognito is like an awesome service. So I spent only a couple of hours to set up a user authentication service, which does so many things that otherwise I would spend like many days to set all those up myself, and even how to use an external provider for SMS messages during user registration. So what you can do with Amazon Cognito, you can register using a username and a password with also custom attributes like name, etc. Or you can use a Google or Facebook registration. You can send SMS or emails for your confirmation of your users when they register. It creates JWA tokens for API authentication. So this supports OAuth, and it is well integrated with API Gateway. And Amazon Cognito, finally, it can scale like 2 million of users. Now, if you haven't heard about the serverless framework, it was the first framework developed for building applications on AWS Lambda, and it contains like more than 1,000 plugins. So one of the most powerful plugins is the serverless Next.js plugin, which allows you to build and deploy Next.js web applications with ease at the edge using the Lambda R-Edge feature. It supports many features, and some of the best ones are server-side rendering at the edge, dynamic page routing, image optimization, and localization. And finally, the very good feature, incremental static regeneration. And I have a separate slide for this one. So as you can see, I used for my front end React.js and the Next.js framework as well. So my first tip for you is the following. So write your infrastructure as a code before you start the development. I know it takes some time to write the templates and you want to go like straight to developing your project, but trust me, this will save you a lot of time in the future, especially when you want to move from development to production. So let's move on to the second requirement, the performance at scale. So this is a question we all have, right? So will my application perform at scale and be highly available all the time? So as I said, I had set some numbers with regards to how many users and requests I wanted my platform to handle per second and my expected availability of all the services. Now, the core AWS services that I used had more than enough upper limits. For example, API Gateway and Lambda support up to 10,000 requests per second. S3 has unlimited storage, and it is a highly available and scalable service. And the availability for all those services were more than enough for what I wanted for my MVP. So the second tip is go with the simplest service that meets your requirements. Like there are so many services you can choose from. Do not over-engineer. If you want to migrate to another service in the future, you can do it, and it won't be in the near future. So the next requirement was cost. And as you can see from this table, this is the cost breakdown for the core services I used during the development of my MVP. And AWS offers a free tier where you have free services for 12 months or always free. For example, API Gateway and Lambda offer 1 million requests per month. So that was more than enough for my platform. So I used those services and paid nothing. So isn't that great? Same for other services as well, like DynamoDB and CloudFront. The only thing that I had to use a bit more were the images I was uploading and downloading with Amazon S3. But that was only 45 cents per month. So the total amount I paid during the development of my MVP was 45 cents per month. How awesome is that? So the next tip is to take advantage of the AWS free tier, especially during the development of your platform. Now, moving on, let's go to my fourth and final requirement, which was security. Now, with regard to security, as I said, I had no experience. For example, how I could be protected from DDoS attacks, or how I could encrypt my data the best way, or monitor my services and API usage for my platform. So this unknown territory for me was covered by the AWS services. For example, AWS provides the AWS Shield service, which is a free service for DDoS protection. Or you can use the key management service to encrypt your data with an AWS provided key if you don't know how to create one, for example. Or you can use the AWS Certificate Manager to create and automatically renew the SSL certificates. So I used all those services for the security of my platform. So my fourth tip is to take advantage of the AWS built-in security services, for sure. Now, let's move on and see 4 architectural challenges I had to overcome during the development of my MVP. Now, the first challenge was that when a user uploaded an image on the website, I wanted that image to load very fast, regardless if the website was loaded on a browser from a laptop or a big monitor or a mobile, if this image was like a big one. So that means that the resolution of the image would be the appropriate one for its display. So in order to be able to serve all those devices and resolutions, I had to create multiple images with different resolutions every time an image was uploaded on my platform. So I ended up creating around 5 different resolutions for each image, and that was done through a Lambda function, which saved all those to Amazon S3. Now, in order not to have images that would be unused after some time, and to reduce the cost of Amazon S3, what I did was to delete the resized images and not the original ones after 3 months due to inactivity. And I did that because I had another flow, as you can see below, where when a user requested an image that was not found on Amazon S3, then a Lambda function at the edge, which is a Lambda function deployed at the CloudFront edge locations, would resize the image on the fly, it would save it on Amazon S3, and then the user will get the image back from S3. So with that architecture, I managed to increase the agility as I could add new resolutions on the fly rather than archiving the images and trying to restore them, reduce the storage cost, and also I was resilient to failures. Now, the other architectural challenge was the Lambda cold start. So what that is when a Lambda is invoked for the first time, it downloads the code from a repository, and then it starts an execution environment. So for the first time, the total duration is like the cold start plus the execution time, and then it is warmed up. So in order to improve this cold start, what you can do is like use a programming language which has a better cold start, such as Node.js or Python, or eliminate the cold start with Lambda provision concurrency with an extra cost, or use like a different, use a new feature called Lambda Snap Start, which is only used for Java. So, and that is why, as I told you, I used Node.js for my backend. Now, do you know that about 43% of the entire web is built on WordPress, which uses MySQL database for the database and PHP for the backend? So I used a headless CMS architecture with WordPress, which means that I created my own frontend with React.js, and I use WordPress for the backend, which has a very fantastic content editor. So I wanted to build something really fast for the blogs and be also highly available and scalable and performant. And as I said, I used DynamoDB for my data. So in order to move the data from this MySQL WordPress uses, I actually created a plugin which was like a Lambda function that was taking the data from the MySQL with a cron job and saving those to the DynamoDB table. And I also used a free plugin on WordPress, which was actually saving those images to Amazon S3. Now, as I said, this was the architecture, and it had like more complex architectures on it. And one was the incremental static regeneration. So I use the incremental static regeneration with Serverless Next.js, which is a feature where you can actually rebuild the entire site without having to redeploy the site again. So that means that every, for example, 1 minute, the pages would be rebuilt on the server, and that was actually using a Lambda function and Amazon SQS to tell the backend when to actually regenerate the page after some time. So before we finish, just to show you the timeline of the development for my MVP. So as you have already guessed, what I developed during those 3 months was not only the MVP, but a bit more, because I integrated many services all together. Finally, my startup, it is called TopTown, and as I said, it's a directory of local businesses with a very nice blog, and we have also won 10,000 credits from AWS to spend. Feel free to navigate on my website and send me your comments and thoughts. So thank you so much for joining this session. I hope you found it useful, and please connect with me on LinkedIn.
Oh, that was great. Thank you for your time. To the audience, remember that we're gonna have a Q&A sessions with all the speakers. And thank you, and see you in 1 hour. See you over there.
Thank you so much. See you.
But let's get things done, right? Hello, Adrian. How are you today?
Hey, I'm very well. How are you?
I'm fine.
Can I grab some of your energy? It's like almost 10 o'clock here, and we're about to fall asleep. You know, once, once you get over 40, it's just like
I'm full of energy because I finally will find out how to get things done in
you'll finally
architecture
find out how to
with
get
you.
things done. I know. The mystery will be revealed.
Yeah, like a magic. Woo!
There, something like that. Let's go. Let's go with that.
Okay, please share your screen. Okay, I can see you. And the stage is yours.
Awesome. Thank you very much. Well, great to be here. So I've got a whole bunch of content, so we'll rip into it. So I'm a consulting architect with Middleware New Zealand in Wellington, New Zealand. So I don't work for a particular company where we sell products and services. We just really sell consulting. Got some links there on my blog. That middle link there. The deck I'm presenting now is currently live, so feel free to have a look at that. So the agenda, we're going to talk about consulting architect. What is that? Planning and managing your work, doing the work, and communication and engagement. So consulting architect, what and why? So there's a lot of overlap, I feel, between consultancy and solution architecture. And if we have a look at the bit in the middle, we can get some good tips for ourselves. So what's a consultant? So typically, a consultant will be an outsider. They'll have a very specific skill set. They'll come in typically at short notice for a fixed term engagement, and the client's usually looking for high impact on some sort of an acute challenge. So normally with a consultant, you're not brought in just for run-of-the-mill stuff. You're usually brought in because the project's on fire. And as a result, as a consultant, you tend to be relatively goal-orientated. Brought in for a specific job, you're trying to nail that. In contrast, if you're a solution architect, typically say a solution architect with a particular company, you'll be a staff, like an insider. So you'll work at the company. You probably have a relatively generic skill set. You'll be there on an ongoing long-term engagement. And your job's really to address common challenges and to have a sustained impact. And you probably find that you might be, relatively speaking, more task-orientated rather than goal-orientated, but only in relative terms. And I'm not trying to diss the regular solution architect here compared to consultants. No, none is better than the other. They just kind of tuned for different types of work. So what I want to look at today is sort of the Goldilocks zone. Where's the overlap between what consultants do, what solution architects can do, and how we can bring some of those skills into our everyday work. Because when someone hires a consultant, they're really looking for that outside perspective, looking to get to the heart of the issue, and get things done. So from your perspective, if you want to adopt a consultant's way of working, you want to have that mindset of coming in, getting the job done, and getting out clean. A really key point for consultants, I think, and just being effective in general, is basic professional hygiene. We're not going to go into the basics of that. Just regular professional hygiene should be something you should be able to find on your own. So in planning this talk, I kind of look at all the different things that I do as a consultant and trying to figure out, what are the things that are important. And it's a little bit like being confronted with a beach full of stones, right? Where each stone represents an idea or a concept or a skill or something that you do. Some of those ideas are big, but some of them are quite small. And I like the idea that this gives me a chance to talk about some of the smaller or less known skills or things that people don't tend to talk about so often at a conference like this. So I had a look at these stones, and I tried to group them together into some sort of a theme, and I've come up with those 3 themes, which gives us how we're going to manage our work, how we're going to do the work, and how we're going to communicate it. So planning and managing your work. So I'm going to cover 3 things here: critical paths, problem selection, and keeping it real. Critical path. So in really simple terms, this is things that have to be done. If you don't done them, failure is guaranteed. It's not necessarily a linear or sequential thing, and you can have interdependencies there. So some examples that you might come across, in actually doing architectural work, the key one's probably around governance. So if you're coming in, particularly in a government department or somewhere like that, your job isn't just to come up with some ideas about what the architecture is going to be. You're going to have to get that architecture approved at some point. So typically one of the key things I'm looking for when I come into an engagement is, what do I need to do? Like, what problems do I need to solve? And how do I get that over the governance line so that the project can actually deliver, they've got the clearances they need, they can actually go live. So if you start with the governance, that's a good thing to look at. Key design and delivery dependencies, are all the building blocks that you need in place. IDAM, or identity access and management, that's a key one that's often in a state of flux. We'll go into organizations and they won't have IDAM, or they'll be in the middle of some big IDAM project, and the project I'm working on needs to interlock with that. So you've got dependencies there. You need to identify what all these things are. It gives you a good way of structuring your work. You want to keep an eye out for things that have a long lead time. So if there's something on your critical path that has a long lead time, you need to get onto that early. In terms of practicalities, do you need to write the critical path down? If you want to, I think the biggest thing is just not being in the mindset where you're thinking of it. You just want to keep the critical path in mind, and always be, checking in with yourself that you know where it is, that you know what you're doing, that you know that it's relevant. Because and so why am I telling you this? Because you can't afford to miss it. And having a critical path, even if your mind if it's just in your mind, it gives you something to come back to. Picking up on a point that Lefteris actually mentioned, working backwards. A really good tip is working backwards. So, so that governance approval that I talked about as an example, if you work back from the governance approval, what inputs are required, what socialization do you need, you figure out what the starting point is and what your critical path is. Okay, so problem selection. What problem should you prioritize? The hardest or the easiest, low-hanging fruit? Now, why do you want to think about this? Because you are going to get swamped with problems. Especially if you're working on a project that is on fire, you're going to get problems thrown at you left, right, and center. So you need to have an efficient way of picking when to deal with something. So there's a couple of ways of doing it. Hardest first. If you do the hardest thing first, then that kind of makes everything else as easy after that, right? You've crested the hill. You should be on the downward path. It also gives you the most flexibility and the greatest runway. So if the hardest task is also perhaps the biggest and the most complicated, it's probably going to take the most time, might take the most resources. So if you do that early, if you soak up more time than you're anticipating, you should still have time left over. If you leave it too late, you might not have the same number of options because you've just run out of time, or you run out of resources or something. And it's also really common to find particularly hard or thorny problems on the critical path. So if you go to crack a problem and you can't, and that's on the critical path, then you've got a problem that you need to resolve. On the other side, you've got the low-hanging fruit. So if you get the low-hanging fruit out of the way, that's kind of like clearing the deck. It allows you to then focus on the things that matter because you don't have all these other things that are trying to take your time. Apart from just getting the work done, if you do some of the low-hanging fruit, it helps get some points on the board. So sometimes if you're in a situation where the project's stalled and you need to try and build confidence within your team or build confidence with your stakeholders, if you can get some of that easier work done, get some runs on the board, start to make some forward progress, that can be helpful. It's also a really good way of testing the waters. So if you've got something you need to do, it's going to be the first time you've done it, you're not quite sure if it's going to work or not. If you can do a small test, something that perhaps will fail fast with a small blast radius, that's probably preferable to taking on something that's much bigger. Plans versus planning. So the active planning is useful. Plans less so. We think about Agile and the Agile Manifesto. They talk about responding to change over following a plan. The thing I find with plans is that that becomes the process that takes over. People are focused on maintaining a plan rather than just actually doing the planning, which is what counts. So if you're doing planning, that gives you a good way of seeing if something's even theoretically possible. It forces you to consider different. It forces you to consider your context and your objectives. What do you know? What do you not need to know? What do you not know? Think about your critical path, helps you consider priorities. There's all these things that you can do by forcing yourself to think through things and do some planning. Doesn't mean that you need to hold on to the plan. Keeping it real. Architects a bit of a reputation of being, in the ivory tower, heads in the clouds. Keeping it real. This is your chance to prove them wrong. So there's a bunch of techniques you can use here. You might have heard of SMART. It's a pretty generic, well, it's a pretty common sort of a practice, I guess. You'll find it mentioned on online quite a lot. It's really when you're talking about task or goal planning, is you want to make them SMART, so specific, measurable, achievable, relevant, and time-bound. What I find with architectural work and working with development teams is it's really good to be in the habit of always applying SMART to a lot of the things that you do, particularly relevance. So if we want to keep things real, we want to be relevant to the dev team. Relevance is sort of the number one thing you want to look at. So for everything that you do, is it absolutely necessary? Are you addressing the right problems? Is it clear how it will help the team deliver? Have you done enough? There's a risk of over-baking things. You want to do the right amount of work and get things to the right level. If you're going too far, then you're losing relevance. Achievable. Is it clear that what you're proposing can be done? Time-bound. Is the team getting what they need when they need it? And measurable. I mean, how do you know that the answer to all the above is yes? And that's really the trick. So the two techniques there is, well, one, you can do self-reflection. You do leave yourself open to bias there. The better way, of course, though, is to be engaged with your team. So have a really good relationship with your dev team, your team leads, stay in contact with them, attend meetings, stay in touch with what's going on, try and build up a rapport with them so they come to you with their problems or their thoughts and ideas, share your thoughts with them, share them early, be receptive to feedback, try and get a two-way dialogue going, get some collaboration going. If you show that you trust them, then they'll trust you. And there's more chance that, you'll keep it real. Doing the work. Okay. So I'm going to get a little bit theoretical here. So I've got this broad idea of brains, models, and biases. So it's a really important thing about being an architect is it's a leadership position, but it's a leadership position where you are a thought leader. So studies have shown that brains use two modes of solving problems. So one is heuristic, so it's based on intuition with implicit problem solving. The other one is analytical, deliberate rules-based explicit processing. We tend to default back to intuitive thinking, when we're forced, when we're confronted with uncertainty. And now there's a guy called Peter Rao who did some design thinking work back in 1987. He talks about heuristic reasoning, which I found quite interesting. Basically, what that boils down to is heuristic reasoning is basically a class of problem solving where it's unknown beforehand if a particular steps will yield a solution or not. And a lot of the time, that's what architecture is. You're coming into something, you don't quite know what you're up against. And I think it's important to keep that in mind because how you frame up a problem has a really major impact on the sort of solutions that you come up with. Law of the instrument is a bias that you might have heard of. To a hammer, everything looks like a nail. It's a cognitive bias that involves an over-reliance on a familiar tool. So if you've got a set of tools that you like and you're always using them, you do have to be conscious that there might be times when you use them when it's not actually the appropriate solution or the appropriate tool for the problem that you're faced with. So, technologies, patterns you've used in the past, places that you've worked, those are all biases that you bring with you, whether you know it or not. And this comes back to problem framing, right? So, just before I get onto the screen, I saw in the comments someone mentioned the Amazon Prime Video and this recent thing that they did about moving away from lambdas and so forth to a monolith and the cost saving that they had. And I think that's a great idea. Sorry, that's a great example of putting all the biases that we might have aside, because if you're going to develop something online these days, using a cloud platform, using something like AWS, it's a very common sort of popular solution these days. It's very convenient. It's got a lot of flexibility. There's a lot of really good reasons to use AWS and build things in that way. But there's a danger of just going along with that thinking and just being swept away and just sort of defaulting to using that and not taking a step back and thinking, what is the problem we're trying to solve? What are the qualities that we need to meet? You know, and not just, you know, not going in with it with a closed mindset or being closed in your thinking. So a couple of examples here. So on the left there, substance abuse, you know, drug abuse. Do you think that's a criminal problem, a social problem, or a health problem? Well, it's not. It's not either one of those, right? It's all three. The problem is that a lot of governments, I guess, or, you know, a lot of people default to treating it as a criminal problem. So, yeah, drugs are banned. That we can all understand the reason for that, but people tend to do that at the exclusion of the other dimensions. So people tend to forget about the social aspects. A while ago, there was a UN program in Laos where they had farmers who, you know, just regular farmers, you know, not criminals, and they were growing opium. And the reason they were growing opium is because it was the most profitable crop from them, because, you know, for them, because they need to make a living. And so there was a program there with the UN trying to get them to switch their crops from opium to coffee. And because that was a viable alternative for them, some of them have taken that up. So that's not really treating it as a criminal problem at all. That's treating it as more of a social problem. And, you know, and this happens in IT as well. A really common one is people will want to throw technology at problems which aren't actually technology problems, they're people problems. No amount of technology you throw at it is going to fix the problem. So, you know, it's something to be aware of. So models. So models is any sort of representation that describes a system and its processes. The reason I want to bring up models is because they're really useful. They're already proven and refined. They're conceived without your baggage and without the baggage of your project. So they're a really good, clean way of looking at a problem and trying to figure out where you stand. There's a whole bunch of different examples here. So, you know, the good old, you know, people, process, and tools, you know, just looking at a problem and thinking about it in terms of people, process, and tools. Like, oh, we forgot to think about the people, you know, stuff like that can be helpful. You know, RACI, the IDEO circles, there's a whole lot of stuff there, things that you can bring to a problem that you're trying to solve, you know, and, you know, consider it in a more structured way. Let's have a close look at views and perspectives. So Rosansky and Woods put out a book a while ago about system development, and they looked at views and perspectives. So I'll come back to that diagram, so don't freak out. So views, viewpoints, and perspectives, they're all terms that you might hear mentioned in architectural frameworks like TOGAF, where they have formal definitions. That's not quite what I'm talking about. This is sort of my simplified synthesis. So a view is a representation of the whole architecture from a specific point, such as the data or deployment, and views are all independent of each other. So you can have a conversation about just the data if you want to. A perspective is a cross-cutting concern that cuts across all of those, like security. So if we look back at the diagram, if you want to talk about security, you know, there's probably going to be application aspects to that. There's going to be data aspects to that, like, you know, is there personal information, different security classifications on the data that we need to worry about. The deployment, you know, do we put the database on the same server as the web front end, or do we keep them separate? How do we do the networking? So there's a bunch of views and perspectives which are pretty common for most of the work that I would do. These ones would be a good first start. You know, there are others, and there are other ones that are a bit more obscure that you can bring on if it's right for the kind of, you know, the solution that you're working on. And Octavio, I have to tell you, I've got no idea where I am for time, so you'll just have to shout out. I'm afraid I can't see the screen. Dealing with ambiguity. So I'm kind of dealing with this a wee bit with the engagement I have at the moment. So you get ambiguity in two different ways. Ambiguous directions, which are relatively easy to figure out. You just, you know, talk to people, you know, what the hell did you mean? The bigger problem is ambiguous problems, where you kind of get bogged down in this paralysis because you've got a problem that's so big and thorny and complicated in front of you, you don't really know how to push forward. Fortunately, there's some strategies. Now, there's 4 on the screen. For those of you who can count, there is a 5th one coming. So first of all, give yourself time and space to think. If you're faced with a really big, complicated problem, and it's really ambiguous, you don't know where to start, give yourself some time to think. Things that's multidimensional, there's lots to think about. You need to give yourself some time to process that before you can start making headway. Just attack the problem, brute force. It's a bit like starting a cold engine. That's actually quite a good technique if you've got writer's block. So if you've got writer's block, you don't know what to write, literally just start writing. What you write will be complete garbage, but if you can persevere, after about 20 minutes, you'll be in the groove, you'll start being productive. Divide and conquer. Take a big problem, divide it into smaller ones, and then focus on one problem in particular. Try and make some progress with that. See how you get on. Move on if you need to. On the flip side to that, consolidating stuff into themes. If you're confronted with a whole bunch of variables, a whole lot of stuff going on, look for patterns. Try and reduce the noise by consolidating things into patterns, themes that make sense. And once you've got those established, take a step back and see if you can find patterns and correlations between the themes, help you see the big picture. And the fifth one is the approach I've actually used for this talk, is just chipping away. It's like death by 1,000 cuts, but in reverse. Just putting in a small bit of effort, usually seems futile against a big problem. But if you keep chipping away at something, eventually you'll get to the point where you start making progress. So for this particular talk, I agreed to do this a couple of months ago, started thinking about the ideas of what I was going to do. Pretty much every day for the last couple of months, I've spent like 10 to 15, even 30 minutes or an hour every day just chipping away at it, writing more stuff in my notebook, looking for patterns, just trying to think out about what I was going to do. I've been ramping up the time slowly as we've been getting closer. So I've done a few hours today, but for the most part, I've just been chipping away over a long period of time. This is a really good approach that works with that idea of giving yourself space and time, because you can make a small increment, you can do a little bit of work, and then you can step back and you can think about it, while you're in the shower or whatever. It's really good, give you a sustainable pace. The thing you got to remember is, even if you're a consultant coming into a high pressure gig, it's usually a marathon, not a sprint. So it's really important to work in a way that's sustainable. Start early, expect course corrections. Final section, communication and engagement. So stakeholder mapping and talking to people that you don't know. So stakeholder mapping, again, a relatively common technique, not necessarily that familiar with architects, I think, certainly in the consulting space, depending on where you go, it can be quite common. Basically, there's different ways to do it, but the way that I understand is you basically have a grid like this, and you've got two axes, so influence and level of interest. And you basically put people onto this graph and trying to figure out where they sit. So if you think about, the business owner, chances are, hopefully they've got really high, a good amount of influence, and they've also got a lot of interest in your project, right? Maybe there's an infrastructure lead, like a team lead or a manager that you'll need to get approval from in governance. They might have a lot of influence, but they might not be very interested. So mapping all that out is useful. It'll help you figure out where you prioritize your efforts. People that are actively engaged, that's probably where you're going to spend, or probably where you're going to want to spend the majority of your focus. People that have low influence and low interest, you need to keep an eye on them, but they're probably not necessarily worth investing a lot of time in. So governance members, so all are influential, but not all are interested. So if you think about someone who is in their team, that might be a good way of influencing them. You got a governance member there, they've got a lot of influence. You need to influence them, but they're not that interested. If you've got someone on side who's perhaps not influential in the great scheme of things, but they're a good influencer of that person, and if they're really interested in your project, that's a great person to lobby and get on board to help influence that other person. The other good thing about stakeholder maps is, if you've got a really complicated project, you've got a lot of people involved, especially if you're coordinating with other people on your team, it can be a really good exercise. Going back to that idea of planning instead of plans, this sort of planning would be just getting an understanding of, well, who do we think, who's who in the zoo? Who do we think we need to influence? Who's all the contacts that in your network? Get it all down, get a common view so that everyone knows, who's around. Talking to people a final section. So there's an interesting example with enterprise architects. So enterprise architecture has this problem where they're often put into IT. So they're seen as an IT function by the business. So the business engagement with them tends to decrease because they think they're interested in technology. Because the business interest in the enterprise architecture decreases, they find they start focusing more on technology, and so you get this bit of a cycle set up, bit of a vicious cycle, kind of due to the fact of where they sit. The advantage for a solution architect is you're working on a particular project. You've usually got business customers there working with you already, so you don't have quite that problem. But you do still need to be aware of isolation, being a barrier to understanding and relevance. It takes a village. You need to get to know people. They need to know that you're there. Imposter syndrome, lack of confidence, that's a big thing that will stop you going and talking to someone that you don't know. It's really good to confront that. Get out of your comfort zone and get talking to people. So first approach to that is just do it. Just make the leap. I've done this a bunch of times where I've just walked up to someone who's sort of big and scary, just start up a conversation. I don't remember it ever going wrong. It can be nerve-wracking, sure, but you got to remember that they will want to meet you when they know who you are. They'll want to know who the architect is. They'll want to know what you think. You probably know stuff that they will want to know. Just start simple. Just say hi. Face-to-face meetings as soon as you can is always good. And for those who've seen on Netflix, there's that curious case of Carlos Ghosn. They've got his his speechwriter talking, and he had this great line about, when you go in to see the CEO, you want to show total respect but zero fear. It's quite a good technique to remember. So talking to busy people. So this is sort of the last tip I've got for you. So quite often, there's two types of busy people, right? There are people who are effective, and because they're effective, they tend to attract a lot of work. Chances are those are people that you will need to lobby, that you will need to get on side. So you need to pay attention to that. And there's also people who are busy just because they're ineffective, they don't know how to delegate. So this approach will work with both of them. So reach out early. You want to be succinct in what you're asking for, and you do not want to put them under any pressure to respond. There's this line you might have heard, a lack of planning on your part does not constitute an emergency on my part. If you come across as being needy or urgent, that's a bit of a warning sign to people who are effective, because they'll see you as a bit of a liability. You don't want to get that impression. So after you've reached out to them with your very well-written, really clear, succinct ask, give them some time. If they don't respond, do it again. And feel free to do that as many times as you think you need to. If maybe you've sent them a couple of emails, maybe consider doing a pop by their desk and talking to them. It's important to mix up how you communicate with people. Don't just rely on email, which is part of the whole reason about talking to people. You want to talk to people. Just relying on emails, will only get you so far. The payoff is that if you show common courtesy and respect to them, that's usually reciprocated. At some point, they'll realize that you've been waiting and they need to get back to you, and eventually they will get back to you. And because you've been patient, I tend to find that I get a much fairer hearing. You build a much more productive relationship that will last the long term. So really good approach, but it does rely on you being patient, professional all the time, and it requires a long lead time. So if you think you need to do it, you do need to start early. That's about it. So just wrap up, don't forget the critical path. Have strategies for how you select problems. Bear in mind how your brain works and your biases, they're always with you. You need to make sure that you're consciously aware of them. You're not going to defeat them, but you do need to be aware of them. Leverage models where you can. There's a bunch of really good work out there that will help you frame up problems, think about things in different ways that you might not have thought of, give you some good structure. Be smart, keep things relevant. Different strategies for dealing with ambiguity, keep those in mind. Most of all, be confident in yourself. Don't be afraid to go and meet people. It's the workplace, not a date. Rejection is not going to be painful. Oh, and last of all, there's a link to my presentation and a couple of other previous talks I've given, which might give you some models for how you can do architecture. And that's me.
Okay, Adrian, please don't forget, you're going to have a QA after the Eli session. So Adrian, see you over there in a couple minutes. And let's to get after get the things done, let's test these things, right? So Eli, join us.
Hi everyone,
What
how
you
are
do?
you?
So I'm fine. How about you? Let's talk
Mm,
about one thing that we usually hate to talk. Tests.
Right. Well, I think test automation has become a very long way since the days of hating to test. I think everybody understands it's part of what we do. Doesn't matter
Yes.
on which level of the R&D process you're on. But yeah, so this is a passion of mine, specifically the architecture of it and how we look at it from a higher point of view, not definitely or necessarily going into the details of it.
That makes sense. But why not let the user test for us? For us.
Um, well, in today's age, where there are many replacements for whatever product you're trying to put out, the users are not a resource most of the time you can use for testing, because what will happen is they very fast will declare your product to be non-viable, not usable, and they will move on to the competition. And in
Whoa.
today's age with social media, and you got Twitter and Facebook and LinkedIn, whatever, your company can very fast find itself in a very problematic situation where your reputation is basically gone. So you don't want to do that.
Yes. So the stage is yours. Please share your screen so I can put
Yeah,
here.
let me see just how I'm doing that. All right, so I'm going to do a present of my.
I have the power to share
Yeah.
screen. So
All right, so I'm going to share my screen, and we're going to go right into it.
I can use my Jedi Force.
Yeah,
Like
if you could do that, that would be great, actually, because I'm not. All right, let me know when you got on.
so that is the present, the 40th button below you, and
Yeah.
then you can check the options. So extra camera, video file, share screen.
Let's go with the entire screen for now. Keep it
Okay.
simple. Okay, so I'm gonna go with this, and all
Let's
right.
use
So
my
we know we
power.
see coded versus codeless. I'm not seeing myself, so just get along with it. All right, so we're going to talk today about coded versus codeless solution. We're going to create our automation framework and start our automation process. We're talking about test automation. Now, I'm going to be talking about specifically my experience from the test automation field. We're going to talk about that in a minute. But the points I'm coming here across are going to be very familiar with anyone trying to implement new technology into their workspace. So a little bit about myself. You can call me Eli or Ellie. Doesn't matter. I answer to both. I've been doing test automation framework development for almost 20 years now, which makes me feel very old saying it. Um, I like to focus on quality-centric development processes. Going into companies, I've done consultings for most size of companies. I'm based in Israel. Today, I'm working as a tech lead for automation in a company called Payoneer.
Eli, we're here waiting for you. Okay, right now I guess we had a connection issue, but it happened when you do things online, right? So, um,
On, yep.
okay, you are back.
All right. So we're going to talk about a little bit of travel into the past, kind of see what's happening, what happened to brought us to today, and how we move on forward. So we'll take a little walk down memory lane, talk about ancient history. Our ancient history is basically very old tools We're talking about early 2090s, that kind of area. And we did have automation tools. There were very few of those, and there are each of them was very big, very heavy, very highly priced. They used to give each tool a very wide coverage of technologies. For example, it would automate desktop applications and web applications and databases, and it would automate API calls and all different kinds of technologies, even some very, very old technologies that we don't really see a lot of today. And they would usually be delivered for the enterprise level, very big companies that could pay for these products. We're talking about thousands of dollars per seat license. And the sale approach is codeless. What do you mean codeless? Codeless means I'm coming to you and I'm telling you, listen, this product, you can record manual testers work on your application that will create a script or an automated process that you could replay and use as a test. So if we're looking at the organization roles of what type of people we have at that point in the testing world, so we're looking at the manual tester. This person comes in to work. He knows the application. He's very business oriented. He writes test cases. He perform the manual testing actually using the application as a user and set the results, reporting, etc. On the other hand, we have what I'd like to call the automator. So differently from what we know today, the automator knows how to use the existing automation tools. Again, I'm not going to say name of tools specifically. I got into trouble for that in the past, so I'm not going to name actual tools. But he knows how to use these enterprise tools, these slow and heavy tools, to take the tests the manual tester creates and automate them so they could run automatically and rerun and get the results we were looking for. Trend-wise, what we'll see is that a lot of automation people realize that the tools as they are out of the box are not exactly what they need or not nearly enough. So they started creating code, quasi-frameworky code inside these tools using extensions that the tools itself provide or APIs the tools provide, but we're not going outside of the tools, the existing tools. We also starting to see in these years a shift to web-based technologies. Okay, so if we had 10 companies in different type of business areas, each of them would use different technologies, right? Some would use different coding languages, others use different databases. Some would go with desktop applications, some would go with web applications, some would use mainframes, all different kinds of technologies. And we're so slowly starting to see on those years that there's a consolidation of technologies moving towards web-based techs. So we're getting closer on the timeline. So we're not exactly where we are today, but we are talking about the last, let's say, 10, 15 years. So kind of, we're starting to see web technology stacks being dominant in the industry of R&D and development, of code development. So we're seeing solidification of tech stacks. It doesn't matter what's lying underneath, but eventually on the front user, usually the application is going to be web-based. It's going to have almost the same kind of elements on the screen. We're seeing everything we're seeing today, maybe before the React Angular Vue era. Basic HTML with basic CSS, very, very standardized. And we can see that consolidation not only between organizations, but within the organization itself. That means that technology stack is starting to come together and be more minimal, let's say. If before that a company could have one group developing in Java, another developing in .NET, another developing in MySQL, and then on NoSQL. We're starting to see everybody using the same technologies. So that makes things easier for us on the automation front, how to work with this technology. We don't need the huge coverage that tools would offer us before. That basically what tools overkill mean, right? So we had a tool, very heavy, very pricey, that can sustain or work against multiple types of technologies. But we find that we don't need that very extensive support. So what we're trying to look for and what we're starting to see is new tools starting to pop up. The tools are very technology specific. Usually they are lighter because they don't need to support a lot of technologies. They're less restrictive. They're cheaper by far, some of them even free. But instead of being this big UI or a GUI application that I can use to automate, I'm starting to get code-based stuff. Okay, so we're talking about code-based libraries and very, very minimal tools that require me to engage with them on the code-based level to increase their functionality and kind of tailor them to my own need. Due to that, we're starting to see roles change in the industry. So instead of having what we used to see, like the manual tester and then the automator who knows the tool specifically that they use, we're going to see a bit more of a tech-savvy approach on both levels. Manual testers generally stay the same in the idea of what they do. They're going to work, they write test cases, they analyze, of course, the application, very business-oriented, but not just. They're starting to dig deeper into what goes behind the screen, what database we use, what APIs we're looking for, what they act like, etc. The automators that up until this point only had to know the tools that they're using and take that and use it, now have a broader aspect of knowledge that they have to control. They have to know. They need to know code. They need to know coding skills in the way of best practices, libraries they can use, maybe multiple libraries they need to use if they're looking for a specific library for automate web application, another library to do REST calls or database queries, etc. So they have to kind of broaden their horizon and realize that the work is not only using a single tool that gives you all of these little kind of toolbox to use, but you have to build your own toolbox and you have to have the knowledge to take care of everything on your end. That brings us to today. So today we're looking at a whole different kind of industry scape. If up until not long ago, automation projects would be looked at by the organization as something that's nice to have or not as very technological project. So now we're looking at automation projects as something that is full on technology project, code project, some cases, better cases, even an internal tool, an internal product that we need to use and maintain, but that's for different talk. So we're looking at automation project. We need to see easy to use frameworks that we write ourselves, full on software projects, like I said before. We're going to start seeing dedicated teams develop to those, to the infrastructure development of these products. So we're starting to see kind of a, let's say, division between the test projects and the framework projects. Additionally, we're going to see multi-tech stack support. So that means that within a single project, I'll be able to support multi-technologies. I want to do databases, I want to do web, I want to do mobile maybe, and so on and so forth. But it's not as general as the other tools that we saw at the start. Why? Because right now I'm developing the automation framework in the project according to my own organizational need, right? So if my company does not do any kind of mobile testing, there's no need for me to develop that functionality in my framework, right? And the main keyword is coded. We're now seeing a lot more of the coded kind of expertise and the coded approach. Looking at organizational roles, so we're seeing testers. So up until this point, we kind of said manual testers. The manual thing is kind of going out the window now. There's the whole shift left thing. What we're seeing is testers. One of the skills of the testers is automation, right? So the idea is for them to use internally used frameworks to construct and author their own automated tests. And these tests does not have to be the same as manual tests they are performing in the rest of the time, right? Sometimes they don't even do that at all. Depend on the company, of course, and the product. And you have the automation engineers or framework engineers. These people, very, very similar to any backend development team. They very high skill of coding, usually in very complex type of internal product, like I said. So basically developers for any intents and purposes. Now the trends we're seeing today starting to feel kind of like going back in a way. Why is that? So we said automation efforts started to consider like a full software project. That means they take a lot of time and a lot of money and a lot of resources from the company. Automation are similar to software developers, like I said, both in roles and in cost. And due to that, we're starting to see companies that now offer tools, often used by AI technologies, emerging AI technologies, that tells you, listen, I'm going to take the entire role of the automation framework engineer, and I'm going to give you a product which gives you a set of tools in which your testers can take those tools and create your automation efforts. And that way you pay us instead of kind of having your own dedicated team for framework development and doing that in-house. And this is where we're at today, and this is the point of the talk that we're talking about today. So the big question is very similar to any other kind of organization that facing this is, do I build it in-house or do I buy it? And if anything else, if you're going to take anything from my talk today, is this slide, right? So build versus buy, the idea is not to look on today's expenses or what I'm taking out of my pocket today and what's the pros and cons today, but looking at the long-term impact, right? So I'm going to say this again. The answer for build versus buy needs to rely on realizing the long-term impact of your course of action. So what I'm going to do is I'm going to quickly run over the pros and cons for each of these kind of decisions. I'm not going to tell you what to do, obviously different from organization to organization. And this is kind of like giving you a set of tools to work through or a set of questions to work through when you're facing that dilemma. And you can face that dilemma on all kinds of organizations. Big ones that want to start fresh on their automation or general development process. Companies that are growing and need to readjust their processes will face these questions. And of course, young startups that are trying to build up from scratch and want to do it the right way will definitely face these questions. So we're going to start with codeless solutions. Right? Codeless solutions, again, you're going to go to a company, you're going to take to a vendor that creates a tool that gives you a toolbox to do what you need to do. In our case, test automation. So the pros, we're going to start with availability. So if you asked me before, do I want one of these record and playback tools that gives me the toolbox to do my job? I would say, not really. Why? Because they worked on a very limited percentage or very small percentage of the cases, again, in my experience. So I would say not to go that route. Today, however, technology have advanced both with the consolidation into a specific technology stack, but also with the emergence of AI, tools become a lot better, a lot smarter. And if in the past they didn't work, today, most of the time they do. Again, most of the time, not always, but nothing's perfect. That's fine. So there are good tools out there. If you want to evaluate one, you have to really carefully plan your POC. Again, subject for a different talk. But the POC is a crucial stage you have to do. The next thing, hit the ground running. So this is one of the key sell points for these tools. Instead of saying, okay, I want to build my own house, my own toolbox in house, this will take me about anywhere from 3 to 6 months to just start running, to start get going, writing tests. Going with this kind of tools usually means you can start creating your tests today, right? So you get a completed tested framework and you get straight to authoring your tests with no hindrance from the get-go. The next pro is the fact that these tools are usually managed, right? So we're talking about cloud-based tools. You log in using your Google account, your company account, whatever. There's no hardware, there are no computers in the office. There's no maintenance. You can do it from the browser. No need for any kind of strong hardware to run these. You can just like any other cloud service we know today, it's managed. We don't have to worry about it. Okay, so we just pay that vendor. That's all. We don't have to start hosting our own machines. We could if we wanted to usually, but there's no need. Feature set and integrations. So again, these tools, their business is to sell that product. That means they have to make that products compatible with most of the industry they're selling it to, right? So we're looking at a tool that gives us about 80% of the features we might require moving forward as their client. So we're looking at all the popular and basic features that we already want to implement, as if we're looking at it as a automation kind of set of tools. And lastly, and this is a big one, anyone who tried to create any type of product internally knows that sometimes you get stuck. Sometimes something doesn't work. You don't exactly know why. And especially if it's an internal product, you don't always get the help you need from the organization you're in. And using these kind of tools means you're not alone. You get tech support, you can call them, you can write them, you can whatever, get in contact with them in whatever way, and they're usually there to help or at least put you on the right path. So that's a big one. And the key here is when it works, it just works. So that's great, right? But what happens when it doesn't work? When it doesn't work, you have to realize that what you've done is given control of your internal product to someone else. All right. You're completely dependent on the vendor and the manufacturer of that tool. And here comes the cons. And they all usually kind of revolve around that concept of handing out control, right? So if we're talking about a bug or an issue you faced, you can't do much about it. If it's an actual bug in the vendor application, in the tool you're using, there's not really much you can do about it. Sometimes you can do like a workaround, use their tech support, but usually you're pretty much stuck. And the only thing you can do is wait for a fix, right? You have to talk to them, to the company, to the vendor, and you have to wait for them to kind of let you know, okay, we got it. It's an actual bug. We're going to fix it on the next deployment, the next 6 months, next year, or maybe never. Workflow. This is critical. Each R&D has different kind of way to work. Okay. Of course, it's dictated sometimes from the tools, sometimes from the industry. If we're looking at industries like medical industries, there's a lot of kind of regulations that goes on into the workflows, a lot of different workflows. And what we don't want is being forced into a specific workflow that may not work for us because we have agreed to go with a certain tool. Okay, most of these tools aim to the most basic of workflows because they want to have the best kind of fit to most companies, and the workflows are very set in stone. Some companies, some vendors allow for customization, but usually it's not all that much. From experience, I can tell you I've seen something like that when I worked in a hardware company and using a tool that was very much constructed in mind for a company that develops websites. So a lot of stuff didn't work for us, right? So this is something that you need to keep in mind. Will this tool constrict my workflows and make me work a lot harder to get the same results? The third thing is the missing features. Kind of throws back into the bug and issues. It's very similar. If we're missing a feature, we are restricted to what we have in the tool, or we can ask the company to develop it or develop our own. But if we're developing our own, why not develop our own entirely, right? An example could be I took a tool that works great for web testing, and now my company wants to start to do mobile testing, and now I'm stuck. I need another tool or another integration or maybe a whole different kind of tool entirely. Pricing. If we remember, we talked about looking at the long game, right? Long-term impact. Pricing is one of these things. And this is a very sore point for people who got to that point. What does it look like? It looks like this. I've implemented a tool that takes about X amount of money for each run of the test I'm doing. And I'm building my entire automation effort on that tool. At some point, the CFO can come to me and tell me, listen, we don't have enough money to run all the tests today or this month. So you're going to have to pick and choose what you run. Or worst case scenarios, we're stopping the payment for said company, and what happens now? And this brings us into the ownership. When we use tools like this, most often than not, we do not own the tests. We do not own the materials. We do not own the data. Okay? That means that if said company decides to close down, sell their service, stop the service, my entire automation effort is gone, and I have to start from scratch. Okay? So this is very important to keep in mind. All right, let's talk about the coded solutions. Again, I'm reminding you, coded solutions is the fact that I'm writing my own tool kind of in-house or in my own framework. So time to use is a big one because, again, it takes me time to analyze my business, realize what I need, what features I need, developing the whole thing. We're talking about, again, approximately 3 to 6 months until I can start writing and running my first stable tests. Okay, it takes time, like any other coded project. Okay, so instead of hit the ground running, like I said, start running tests today, this is going to take some time. Maintenance, so stability, bugs, issues, DevOps, hardware, communications, all that stuff is something I have to take care of. Since it's not hosted or cloud-based, it's not managed, this is on me to kind of do the whole, okay, what I'm doing with this, how I'm handling it. If there are bugs, I need to fix it. If there are stability issues, I need to fix it. I need to grow in capacity. That means more money. That means more management of my hardware and so on. Okay, so that's on me. Resource heavy. Resource heavy comes in two kind of paths. Hardware, which, I need more machines from AWS, for example, so that costs more money. I need my communications to go faster, whatever, mobile devices if I need those, and so on. But also HR. Why HR? Because today, getting someone who not only doesn't write the test, it's not a tester, but it's a full-on developer, automation developer, to write that framework, to create that framework, that costs a lot of money. Dev standards, it's kind of a sore point, especially in my local industry in Israel. So what we see is that not a whole lot of companies give the resources required for that kind of project. So we're looking at low quality recruits. We're looking at low development standards, cutting corners, all that kind of stuff, which throws us back to the maintenance of it, right? Because cutting corners means more bugs, more issues, more stability issues, so on. And the last one is no help. No help means that if I'm stuck, I'm stuck. I have no tech support, right? I have no one to call. I have no one to kind of grab and try and see if they can help me. It's all on me. Okay. Now, all these cons are no different from developing a product of the company, any kind of service or anything the company is selling, my organization. So that's the same if I want to develop any kind of microservice or desktop application or automation infra. So nothing worth doing is easy. And this is something I personally live by. And when you put the effort and you get something that works, there's no better feeling. So let's talking about the pros for the coded solutions, which is my favorite part. So we talked about issues. But when we have issues, because it's my solution, I get to fix them. I'm not stuck by that. I get to set the priority. And if I have something that is critical to my organization, I'm going to fix it today. I don't have to wait for someone to tell me, oh, yeah, we're going to do it in like later sprints or whatever. Features. We don't have to have a full set of all the features in the world, just what my organization needs. So I'm deciding which features are required in the future, what's needed right now. I put on my roadmap. So this is just general planning of any kind of software product, right? Workflow flexibility. We talked about the rigidness of workflows that from a product I'm buying. And this is a huge one because this way I can tailor my automation framework to the way my company, my R&D works, right? So that means ease of use. This means people don't have to get used to new workflows in their day-to-day, and it just works. Okay, it feels very integral to the R&D and company I work for anyway. Reporting and ownership, I put these together even though they're kind of separate, but the idea is that because I have full ownership of everything, that means the product, the test, the data, the results, I can do whatever I want with it. I can have analysis flexibility.
Eli,
Yep.
the presentation is amazing. However, unfortunately, the time is over. So I'll give you 1 minute to wrap up.
Yep,
So
we're actually at the
start
end, so that's kind of it. And okay, so pricing, just math I did, is usually very lower than the managed tools out there. So what we learned today, the conclusion is we're talking about codeless versus coded, and codeless is easier to sell to executive. We're talking about fast authoring, but we're losing the control. And this is what we have to remember. There is a heavy financial burden in the long run, and we have some dangers, especially if the company or the vendor is being closed down or lack of funding, etc. The roles are kind of staying the same. And talking about the future, we have to kind of take into consideration the whole rise of AI, and we're going to see a lot more codeless probably out there. We just have to really make the right decisions toward my organizations, and that is it. Okay, so I'm done.
Okay.
Fabio? Yep.
Yes. So thank you. It was an amazing presentation. Let's start our Q&A. And Eli, you are already here. Let's invite Adrian to come on the stage.
Hey,
And
thank you.
just one stuff to say. Lefteris. Hopefully you say the name correctly.
Yeah, it's correct. It's Lefteris.
Lefteris. Okay. Thank you guys. Amazing. So if you have any question, that's the moment that you can put your question right now because we do have three amazing experts in software architecture to help you and to provide us information. And let's start with the question. Okay, it's a hot topic. It's impossible to don't start with that, right? I guess we suppose that everybody will do the question for you. Amazon Prime post a video, actually the blog post around cost reduction when they moved to microservice or monolith, Microsoft to monolith. So what are your opinion about it?
Yeah, I was expecting this one for sure. So architecture patterns are subjective and depend on the use case, right? So there is no one size fits all here. And as I said, no service or architecture pattern is the best for every use case. So an architecture doesn't need to be final, let's say, and it can evolve as your needs change. So the prime video architecture today, right now, is comprised of hundreds of teams running hundreds of microservices. And many are running serverless services, actually. Now, this blog is based only on one team's experience, consolidating an application from microservices to a monolithic architecture based on the evolving use case, right? But the team initially built their architecture on a microservice architecture because their use case was to process large videos at an infrequent rate, let's say, with the step function service. But the primary use case changed, so they had to evolve. And then the team wanted to support real-time analysis of live videos, where they had large numbers of smaller video files. So they re-architectured their platform, and they moved from a monolith to microservices architecture, and they could have used the serverless features as well. So serverless does not only work with microservices. You can use a serverless solution using, for example, Fargate, which is our serverless container service, with a monolithic architecture.
Okay, thank you. Let's go to next question. Adrian, can you recommend a must-read book for developer that wants to migrate to solution architect?
Not really. There's a real dearth of material for doing software architecture or solution architecture. So there's a few books like Martin Fowler's book on enterprise patterns. So that's a really good introduction into patterns that you can use at a solution architecture level. One of the books I got given was from a friend was around doing patterns with C#, looking at solid. So if you haven't heard of the solid patterns, those are good patterns to get into. But in terms of like the wider stuff, in terms of what skill, soft skills and the thing, there's really nothing. So that's kind of what I'm blogging about. So yeah, I just don't really have a good answer, I'm afraid. It's really just a matter of looking around the net and seeing what you can find. And I'm sorry I don't have a better answer, but yeah, there's really not a lot out there.
Okay, yeah. I mean, I guess that's the issue with software architecture, right? I mean, there is no a single book that can help you. So you need to have like a collection. And at least for me, it's a mix of books, reference, practice, and the main one, mistakes. I mean, we need to do mistakes to learn eventually. It's sad
Yeah,
to say that. Nobody wants to say that, but for me, it's real.
I mean, there's a bit of a shameless plug. I'm trying to write a book about doing solution architecture, and I'd say, oh, read my book, but I don't have that yet. So I'm just sort of trying to build up content as I go. When I do a Geekle presentation, usually I'll focus on a particular topic, try and figure out how to do that really well. All right, that will result in some materials that I can give out and some blog posts that go on the blog. So those last 2 articles that I had on my slide deck would be 2 of those. So I'm just trying to build it up piecemeal, but yeah, that's as close as I can get.
Okay, no rush. Eli, sounds that software product company is better to developer on framework because if you choose Codeless and in 2-3 years stuck with implementation of that framework, uh, it will cost a lot of to switch your existing tests to your own framework. What do you
Okay,
think about
so
it?
this is a good point, but it's not always true. The thing is, well, personally, I always prefer to build my own, right? But that's personal preferences. But it's not always a good case. See, a lot of companies, they don't have the business center of them is not coding, all right? And they don't always want to spend time building a whole new R&D development team or development teams dedicated to writing code and creating that specialty within their company. In that case, they might want to go on to getting a tool like the one we talked about. However, it does require thinking ahead and kind of planning ahead, saying, okay, we might want to have that kind of tools, but create an exit point in which it will be technologically easy to migrate, or even get tools that are kind of halfway between completely managed and something that is partially in-house.
Oops, I was in mute. Sorry.
All right, so I hope
Technology.
that answers your
I'm
question.
famous for doing that.
I hate technology. Hopefully, we have you guys here to help me to unmute my microphone. Right now, I have a question for all of you. How do you manage continuous delivery?
That's a very good question. I don't think
I usually
I
do
can.
Uber Eats. I mean, they can deliver food for me continuously as much I have money.
I
But
don't think
anyway,
I can give a single answer to that. It depends on the company and their business and their culture, at least for me.
So I could have a crack at one part of this while you guys do some more thinking. So one of the things that I observe when a project is stood up is how it's funded. So the big problem that government departments in New Zealand have is there's no big pot of money sitting there for them to go and do big infrastructure projects or to put in new, API front doors and all that sort of stuff. So all the enterprise architects and the domain architects, they come up with these great ideas, but they've got no budget to implement them. On the other side, you've got businesses, projects that will start up to do particular business things, but they've just got a limited scope. And so the enterprise architects try and pile their new features like, oh, here, we need a new IDAM platform. Can you please build it? But of course, the projects don't have the scope to build that. So there's that real conflict. So that's when you got, a lot of the work that's project based. What I'm starting to see a lot more now of though is product teams. So they'll try and do a project and then have some sort of a team remain, get that stood up as a product and have that as an ongoing concern. But certainly in the New Zealand market, that's still a relatively new thing. People are still trying to figure out how to fund it. So when you're talking about how to manage continuous delivery, I think follow the money. Where's the money coming from? How is something being funded? That's probably going to have an impact on. That's the foundation for all the work, really. You're just on mute again, Octavio.
thank you. See, I'm so happy because I have 3 experts to help me on that. Let's talk about Go. Go lambdas have even shorter could start duration. Why not using them?
Yeah, that's a good question actually. Now, with some benchmarks that we have done, Node.js, Python, and Go are like in a similar manner, let's say, the cold starts. So depending on which programming language you know, I would suggest that you use those three languages. And nowadays, we have also this new feature for Java, which is called Snapstart. So you can also try out Java as well. Because I had experience on JavaScript a lot and Java, and I didn't know Go at all, so I had to move fast, as I said, and deploy my MVP very, very quickly. So I used Node.js for that. And because on the AWS console, you can try out Lambda function with Node.js using a built-in editor. That was very fast for my experiments as well. But of course, if you know Go, yes, please go with it. It's super fast and it's great in Lambdas.
I mean, that's one of the great thing about serverless technologies. You don't have to pick one language and stick with it, right? You can mix and match.
Yeah.
Yes, Adrian is correct.
Yes, let it go. As I guess right now it's a frozen philosophy, right? But anyway, let's go to the next question with Adrian. How do you select which each is the hardest, easiest problem to start with? Whoa.
So looking at the risk profile is a good place to start. So I guess you're trying to figure out, you got a bunch of problems, how to figure out the relative size of them. Yeah. So I mean, the risk profile is something I look at. Yeah, that's something that has a long lead time. Those tend to be bigger problems, stuff to do with infrastructure, stuff where you need approvals. Anything that involves other people is often usually a hard problem because, you need to get other people convinced that you're doing the right thing, right? Normally the technology problems are usually relatively small. The bigger problems are more usually sequencing ones or coming up with new patterns. Breaking new ground is a common area where you get hard problems. So, oh, hey, you're doing this new project and you need customers to log in. Oh, we've got a new IDAM platform we want you to use. You'll be the first project to use it. I mean, there's a raft of problems that are going to come out of that will be hard because it's new. It's new for all the people who are doing it. So, yeah, if people are involved, it's probably a harder problem.
Can I pick you off that question? Because
please do.
So you talked about the concept of kind of the risk profile of a problem or a situation, but these things can change as the project moves along, right? So how do you handle a changing risk profile in regards to the cost of context switching and switching from one issue to another?
Context switching with risk. So normally when you're looking at risk, you're looking at the likelihood and the impact. So if the likelihood of something is high but the impact is low, the risks might be sort of manageable. Yeah. If the impact is monumental but the likelihood is low, then yeah, you could ignore it, but you're kind of playing with fire there, so you just need to be careful. It's all about picking which problems you want to deal with and how you want to deal with them, right? So like Lefteris was saying, so there's no one right solution, and it's a bit like the same with risks. It's all about picking the problems that you want to take on. Like when you're going to buy a house or picking a flat, no flat or house is perfect. There's always problems with all of them, and so really it's all about picking which problems you want to take on. The same with risk. In terms of the context switching, I'm not quite sure how to factor that into dealing with risk. Did you want to elaborate on that?
So I'm just remember a situation in a project. I try to keep it as vague as possible to not kind of indicate anything. But basically, there is a risk rising in a certain issue, and then the cost of switching to handle that situation, the risky situation, affects time-based risk on another project or another task I'm on. So the switching to that new risky situation is a risk on itself, basically.
Yeah, absolutely. So it's the interesting thing, I think, when you think about the difference between a design and an architecture. For me, the difference between the two is that an architecture is designed to change.
Yeah.
You know, when you design the Spitfire, it's a great plane, but it's the one design. If you want to make changes to it, you pretty much have to design a new plane. Architectures are architected to encompass change. So when you're making early decisions or big decisions, you're ready to think through the implications. You know, what are the likelihood that something might change? You know, what's the likelihood that the vendor's going to go out of business? You know, if it's low likelihood, then you can go all in and build a big stack on them. If they do go out of business, though, you're going to have to deal with that. So it's just about weighing the likelihood and the impacts.
All right,
It's about
cool,
as good
cool.
as you can do. Oh, you're welcome.
Okay. One question to everybody. It's a tough question. So, how do you think AI will impact automation frameworks?
Okay, so we're already starting to see this, and I think we're starting to see this impact of AI in all aspects of our work. And what I'm seeing is today, like I said, a lot of these kind of codeless tools are now more reliant on AI. If I can give a very small example, if we're talking about UI automation, so AI is there to kind of fix the problem on the go, stuff like that. So I think AI will definitely be integrated and they will be there to assist us, but we'll have to know not to give them full reins of what's happening. And the reason is that at least today, okay, so AI can do a lot of cool stuff, but it doesn't have intention, and it can replace a human just yet, and it can tell you. It can check, but it can't test. That's kind of the idea. So I can give it a set of scenarios, and it can get through them and maybe analyze the data that is created throughout testing and give us interesting insights. That's very cool, and I've seen it happening. But I won't let it. I won't rely too much on the whole fixing the test as it goes along, because then it might fix the faults, and where test should have failed, suddenly it's not failing because the AI figured out the mistake and kind of worked around it. Okay, so I think it's going to happen. We're going to have to integrate it, but we need to know where. We need to play to its strength, and we need to be careful not to release the reins too much and let it do too much of the work to create false positives or the other way around.
Can I ask you a question on that, Eli? Do you have a sense of particular test-related work where AI is well suited and areas where it's not?
So
I broke Eli.
Yeah.
I wish we had AI now to answer.
It was the Eli. It wasn't a AI system presenter.
He's crashed.
Yeah. Okay.
He's probably giving a really good answer.
He will. He answering right now. The sense of the life. And nobody can hear that.
Damn.
It was so deep that even the internet's not able to hold that. Okay, we have the Eli clone here. So welcome, Eli Boots.
yeah. Okay, so again, sorry about that. So like I said, a bad example would be the whole AI fixing itself, the test kind of thing, because what we're seeing is, say a button has been moved on the screen that should have failed the test, but the AI realized that it moved and kind of works through it. So that's a problem for me, right? For us as a testers. But it would be great to have it analyzed, say user action data, realize which features are more important. If we talked about risk analysis and risk profile, that could be great assets to have an AI going through like the data, and there is a massive amount of data, and working through it and realizing behavior models and where our business could kind of align with those to generate more engagement with the users and the clients, etc.
Okay, we are the time unfortunately, we need to go. But it was amazing discussion, amazing presentation. I'm glad to be here. Probably next year, I'll be replaced to a better host like AI that's not able to forget to unmute themselves. But
I don't know
anyway,
if it'll give you energy though, Octavio.
Yeah.
yeah, who knows? Maybe with uh, happiness bot, you can use like a plugin extension to happiness inside the bot.
Or maybe it will be an in-person event, right?
Yeah.
Yeah.
Yeah. But
I'm
anyway,
happy to come to Greece.
oh yes. Thank you, Adrian. Thank you, Eli. Thank you, Lefteris.
Thank you very much.
And
Have
see
a
you
great
around.
conference.
See you.
And
See you all. Bye.
10 minutes break. So time to you drink some water, eat some food, and return to us. Bye.
Do you hear me?
Hey team, sorry for that. I was using a different microphone. I was saying no, I'm happy to be here, and I'm here. We have Darren, that is our next speaker. Really, I hope that the 10 minutes you had was enough to get some refresh, and let's start. Darren, welcome to the conference. Are you ready? I think so. I'm going to add your presentation to the screen, and the stage is yours. No, you can.
Thank you. Hello, good morning, everyone. And thank you to joining me in building better software with attribute-driven design by Worldwide Software Architects Summit. Today, I would like to discuss a crucial aspect of software development that play a significant role in ensuring the success and the quality of software system. The topic will be exploring attribute-driven design. In the field of software development, it is not enough to focus solely on a functional requirement to build robust and effective software system. We also consider the various quality attributes that shape the system performance, reliability, security, and maintainability, and other. That's where software attribute design come into play. So, a little presentation about me. I am Darren Boutros. I am solution architect at Capgemini. And if you want to join me on LinkedIn for further question, here my LinkedIn. So, what we'll discuss? Why attribute-driven design is necessary in software development. What is the definition of attribute-driven design, and it is significant in the process in design as a design process. What are the steps involved in attribute-driven design methodology for software development? So, why we need attribute-driven design? If we take different domain, for example, the domain of cockpit system for aircraft, ADD is a vital role in addressing crucial quality attributes that contribute to the safety and efficiency of the flight operation. Some key attributes may include human-machine interface. ADD help us in designing cockpit system with attributes like intuitive user interface, ergonomic control, and effectively information displaying, ensuring pilot can operate the aircraft effectively and safely. Also, the cockpit must be reliable with attributes like fault tolerance, redundancy, and self-diagnostic, enabling pilot to trust the system accuracy and performance. Another domain could be delivering using a drone. Here also ADD has a crucial to address important quality attribute, such enabling us to design a drone that attribute like stability, maneuverability, and agility, ensuring smooth and precise flight operation. By considering attributes such payload capacity and endurance, ADD help us in designing a drone that can carry and deliver payload efficiently. The drone must also operate reliability and safely. ADD allow us to address attributes like redundancy, fault tolerance, and fail-safe mechanism that minimize the risk of failure and the accident. Another domain also in the domain of autonomous driving, ADD become essential by facilitating the design of autonomous driving system with attributes such as sensor fusion, ensuring accurate detecting and interruption of the environment. It allows us to address attributes related to decision-making algorithm, trajectory planning, and behavior prediction, ensuring safe and intelligent navigation in complex traffic scenario. So now what is the definition of good design? If I take a quote of Antoine de Saint-Exupéry, a designer knows he has achieved the perfection not when there is nothing left to add, but when there is nothing left to take away. A lot of time we are designing and adding new features and a new quality attribute, but sometimes we forget that we need to write the minimum necessary to deliver our software. And ADD help us to do the good design. So what is ADD? ADD is a semantic step-by-step method for designing the software architecture of software intuitive system, developed by the Software Engineering Institute. ADD provides an approach to define software architecture by basing the design process on the architecture quality attribute requirement. This methodology follows a recursive process that decomposes the system or the element by applying architecture tactics and patterns that satisfy its driving quality attribute requirement. By prioritizing and incorporating this attribute into the design, ADD ensures that the resulting software system meets the desired quality code. The role of ADD in the software design process is to guide architect and developer in making informed design decisions. It helps them understand and address the trade-off between various attributes, as well as prioritizing them based on the importance to the stakeholder. ADD provides a framework for systematically analyze scenario, identifying critical attribute and creation design guideline, and evaluating the system compliance with this attribute. The version 2 of ADD was released in November 2006, followed by version 3 in April 2015. This update reflects the continuous improvement in evolution of the methodology to address the changing need and challenge of the software development in every evolving technology. Now we will speak about ADD step. In the top, in the red color, we identify the driver that influence the design of the software architect. This driver can include both functional and quality attribute requirement, stakeholder needs, and business goal, technology constraint, and any other factor of the factors that shape the architecture design. The ADD process is in blue color, follow a systematic and iterative approach to design the software architect. Finally, the output of ADD process is in green, is well defined and is a software architecture well designed and documented. Now I will go in detail in every key or process. The designing objective directly impact what and how we design. For example, if the objective is to design for value. The focus will be on creating solutions that maximize the perceived value for the end user or the customer. On the other hand, if the objective is to design for cost, the emphasis will be optimizing the resource and minimizing the expense and finding the cost-effective solution. The second driver, it is very important. It is the functional requirement outlines that specify the function and the capability that the system must provide to meet state and implied needs to stakeholders. They describe what the software should do and when, use it under specific condition. Functional requirement can be captured using different code technology, such as use cases or user story. For example, as a user, I want to be able to buy and sell securities through the system so that I can manage my investment effectively. This functional requirement clearly states the specific function that the system should provide. They capture the desired behavior and the action that the software should support to fulfill the need and expectation of the stakeholder. The requirements serve as a basis for designing and developing the software system to ensure that we meet the functional expectation of its user. The third driver is the quality attribute scenario. The quality attributes are measurable and testable properties for the system that indicate how well the system satisfies the need beyond its basic functional requirement. They represent non-functional characteristics of the system and play a crucial role in determining its overall quality and success. Those quality attributes could be the availability, the performance, and also, for example, the security that the system able to protect user against unauthorized access, data branches, and other attacks of security. Also, it is very important for responsible system, the energy sufficiency. So we need to optimize energy consumption and minimize resource usage, contributing to the environment substantially. Those are the last part of the last two steps of the drivers are our constraint and concern. The constraints are decisions take about the system design. They must be taken into account when creating the final design of the system. This constraint can be originated from various sources, including the customer, the development organization, and the overall project requirement. They may be technical or organization nature and typically impose limitation on available design alternative. For example, the system shall integrate with legacy application. In this case, the constraint specifies that the system under design must have the capability to seamlessly integrate with existing legacy application. This constraint may arise from the customer requirement to leverage and prospective investment in legacy system, or from developing organization need to ensure the compatibility and the interoperability with the existing software. The last driver are concerns. The concerns in software design refers to specific area or aspect that require design decision, even if they are not explicitly stated as a goal or requirement. This concern address important consideration in the design and help to ensure that the system overall effectively and reliability. An example of concern deployment and updating. The concern involve making decisions related to the deployment and updating process of the software system, including considerations such as packaging, installation, configuration, and management, and others. Now we finish all the driver. We will go through the step of ADD. The first step of ADD, it's reviewing the input. To review the input, this step involves gaining the clarity of the overall designing problem that need to be addressed. It is important to address the context and the purpose of the design effort before making any decision. During this step, several objectives can be achieved. Reviewing the input that help us in clarity defining the design problem and the objective, determining the purpose of the designing route, and understanding the existing context if there any existing system or architecture in place. It is important to note it in this step, there is no any decision design is taken during this step. The next step is step 2, establish iteration goal and selecting the input to be considered in the iterative. In this step, we determine the order of addressing sub-problem and focusing on identifying specific problem or goal to address in the current iteration. For example, let's consider an example about domain of e-commerce. The iteration goal would be to improve the performance of the project, such search functionality in e-commerce website. By selecting input, in this example, we include user requirement related to the product search, performance metric, customer feedback, and other. These input are essential for addressing the and identifying goal of improving search performance. To determine the order of addressing the sub-problem, the utility tree technique can be employed. For instance, in the e-commerce example, the utility tree can be assess the impact of different design elements on both the business goal and architect goals. It's help in prioritizing the sub-problem and have most significant input in improving search performance and aligning with the overall objective of the system. In the step 3, we choose one or more element of to decompose. Let's explore how different approach can be applied and how we can order it in this step 3. There are top-down approach. For example, in e-commerce, the top-down approach would involve initially identifying the overall goal, such improving search performance. Then the design team will select the input and break down the problem into sub-problem related to the search algorithmic optimization, database indexing, caching mechanism, and search and search and engine integration. Another approach can be bottom-up approach. In bottom-up approach would involve analyzing the existing algorithm and the database structure, identifying the components that make a problem and solve this problem. Also, we can use an approach mixed between top-down and bottom-up. In certain situations, it may necessary to reserve the order between step 2 and 3, based in priorities. For example, in a greenfield development scenario, we specify elements that the system need immediate attention or carry higher technical risk. Step 3 can be addressed first by selecting particular element and considering the associated driver. The design team can then establish the iteration goal in step 2 and select the input accordingly. In step 4, involves selecting design decision, and this step can particularly challenging. Here, an explication how it can be challenging and how existing solutions such a designed complex reference architecture, deployment pattern, and architecture design tactic and extremely developing can be addressed. The existing solution and avoiding, we should use the existing solution and avoiding reinvention. Also, another mechanism, it is using proven solution and expertise. By using a proven solution, the design team can benefit from the expertise of those who have already solved similar problem. Designer may not be necessarily be expert in every sub problem they encounter, but by leveraging existing solution, they can tap into the knowledge and the experience of experts who have successfully addressed those challenges before. This helps to ensure quality and the effectiveness of the design decision and made during the ADD process. Also, by considering existing solution, designer can save time, leverage expertise, and ensure the effectiveness of their design decision. The ADD process encouraged the use of a proven decision and concept and resource, while allowing for creativity and customize them as a meet the unique need of software being developed. In step 5, involve initiation architecture element, allocating responsibility and defining interface. This step establish a concrete structure for the software architect. It clarify how the software element map to each other, how communication occur among the element, the dependency between elements, and how the quality attribute requirements are addressed. This is step the foundation for the subsequent step of ADD, which involve refining the design and evaluating it effectively, it meeting the desired goal and requirement of the system. In step 6, it's to sketch, view, and record design decision. Here we instigate the design, the concept, and refine the architecture. It comes to create sketches or diagram that represent different view of the architecture, such as high-level system view, model view, and deployment view, and other. The sketches serve as initial documentation for the architect. The visual representation of the architect facilitates the discussion, enable better understanding of the design decision, and help identify a potential issue or area that require further attention. The sketch serves as a starting point for discussing and providing a shared understanding of software design. Involve also recording the design decision made during the ADD process. In the step 7, evolve verifying the allocation of software functional requirement and quality attribute requirement and design constraint to the child element of the decomposition. Here an explanation how can we achieve it by allocation requirement. In this step, we focus on ensuring all the functional requirement, quality attribute, and design constraint designed to the parent element have been appropriately allocated to one or more child element in the decomposition, or also identifying the quality attribute requirement for the individual child element may need to be refined as necessary. This refinement is driven by the need to ensure that such a child element can meet the specified quality attribute, and it may evolve further analysis evolution or adjustment for the requirement alignment and the capability of the architecture characteristic of the individual element. Also, in this step, we don't take any decision. We can repeat all the steps from 6 to 2 as necessary. At the final iteration, we get our software architecture design. And if we start a new step of architecting software, we can start from the beginning using step 1. To summarize, attribute-driven prioritize the quality attribute requirement in software architecture design, going beyond basic functionality. ADD ensures that the software system meets stakeholder need by following a systematically method and considering specific domain requirement. By incorporating ADD, teams make informed design decisions, promote reusability, enhance communication, and create robust architecture that address functional and quality attribute requirement. And if you want to go for further read, there is Software Architecture in Practices, a book, Attribute-Driven Design on the Internet, version 2, also Rethinking Driver and Decision, and for Agility project, we have Enabling Agility through Architecture, published 2010. And thank you.
Okay. Thank you for the great talk, Darren. A really interesting topic about attribute-driven design. So let's see you in a few minutes in our Q&A session. Let me add our next speaker. So let's see. I don't see Darren, if you're ready. Give me a sec. Or Emmanuel. There you go. I can see you. Hey, Emmanuel, how are you?
Hi, how you doing?
All good, all good. How is everything there?
Sunny. It's quite nice.
That's great. That's great. Yeah, well, we are all over the world in different time zones. So yeah, I think is that's the great thing about this type of conferences. No, so a lot
Yeah.
of energy. So I believe that you're ready. So if you can share your screen, so I can add to the stage.
Okay, I will do that real quick.
Trust in a trustless world. That's interesting.
Yeah,
Let's.
can you see it now?
Yeah,
Okay.
I can. I can. So you're there, so you can start whenever you want.
Okay, great. Hi, guys. Today we'll be exploring the exciting world of decentralized applications, also known as DApps. But our discussion will be focused mostly on promoting trust, security, user empowerment through design and development, while also delving into some aspects of decentralized technologies. Quick introduction. My name is Emmanuel Agwasim, and I'm a software engineer at Booking.com. Quite passionate about developing solutions that can help people make people's lives more efficient. Fun fact: I build solutions for myself and see how they can scale to other people, and I'm pretty busy designing and building stuff that I have no ability to market. So, yeah, if someone is out to do that, reach out to me later. Okay, let's dive in. Today's agenda, uh, we're going to talk about the apps, decentralization, distributed ledger, transitioning from central to decentralized architectures. That's what you need to consider while doing that. Some key components of the apps. We're going to concentrate a bit on privacy and all of that, and then real world use cases. So, I'll assume most of us already know that the following the 2008 global financial crisis, the world's first digital cryptocurrency, Bitcoin, was proposed, and this was the first platform to allow peer-to-peer transactions take place, eliminating the need of intermediary financial institutions. And this gave us a sneak peek into the trustless future and the future running on decentralized applications. But before we dive into the criteria for success with the app, I think we should go over what blockchain technology is. Um, So a blockchain is basically a way of keeping records that is decentralized, meaning that it's not controlled by one single person, but an organization. Sorry, one single person or an organization, but instead it's controlled by multiple different computers all over the world, working together to verify and store this information. Uh, Next slide. So when we are talking about building decentralized applications, there are three things that most of the successful decentralized applications have in common. That's the big successful ones. They're open source, meaning that all changes are decided by the public, not a central entity. It is decentralized. That's pretty self-explanatory, and is incentivized, meaning that the people that participate in your network or your application, they get some kind of incentives in the form of crypto tokens for using or securing that application. Uh, from this definition, I mean, you can already tell that Bitcoin already satisfied those cases, but it was not. It did not. It just gave us like a sneak peek into what was possible. Ethereum is actually now the platform that pushed what Bitcoin really was a bit further. It took the idea of a decentralized app a step further by creating programs called programs that can run on on a decentralized platform. So while Bitcoin was sort of like a closed decentralized application, Ethereum became like an open decentralized application in the sense that you can not only transfer value through the network, but it also creates a platform for you to run other kinds of decentralized applications on and also transfer value and do all a bunch of other things. Now, Ethereum has its own cryptocurrency called Ether. Ether is what you use to pay for transactions on the network, and is also used as an incentive for people to verify and store information on the blockchain too. Yeah, So we'll move on to what to consider when migrating from a centralized to decentralized application. So there are three main factors that one needs to consider that might come as a shocker to Web2 developers or centralized application developers. And that's the one, the scalability of a blockchain. It's running on different computers, and all the different computers have to work together to verify, either using different consensus mechanisms. We'll touch that later. And it turns out that the more users use the application during like really peak period, it does not quite scale very well. Although there are different technologies that are working towards fixing that. And then we have latency. Blockchains can get very slow, and transaction times due to the consensus algorithm or the consensus method that's being used in that blockchain, especially during peak periods. And then we have the interoperability. That's you have currently have different blockchains that are working and offering and providing value to different users. Now, there's a need for these blockchains to interact, and because the technologies are not always very similar, that can cause a problem. Although there are also technologies that are working to solve this, but it's just the point that these are like the three things that you need to consider when you're trying to maybe migrate your application from a centralized application to a decentralized application. Now, these are the key components of decentralized apps. Of decentralized app, we already talked about the consensus mechanism. The consensus mechanism, that's basically how the players on the blockchain decide on what data to store or how to store that data, how they come to an agreement. Because remember, these are like computers that are living all over the place, and they don't necessarily communicate themselves personally, and there's a lot of anonymity going on. So the consensus mechanism is the way that we decide on how we're going to store data or process work on that particular blockchain. And we have very two main popular ones. That's the proof of work and the proof of stake. Ethereum is currently running on proof of stake, while Bitcoin is running on proof of work. You can look those up for further reading. Then we have delegated proof of stake for like more modern blockchains like Phantom, where you can delegate your tokens to a different stake provider, and yeah, all of that. But we're not going to get right into that. And yeah, so the next factor is smart contracts. So smart contracts are scripts that we run on the blockchain, on the platform provided by that blockchain to create our own decentralized application. They offer the crucial trustless transactions on the DApp, and they can be. I know of two main programming languages right now for running script, and I believe that's Rust and Solidity. Solidity being the most popular because it was made popular by Ethereum's own blockchain. And then, of course, we have decentralized storage because we need to store things. And we have blockchains like Filecoin that offer such services. So you can store a particular file in multiple computers, and this offers anonymity, it offers proper scalability and durability for each file that we're uploading. So if a node is down, you know your files are still available. So those three factors, uh, those are the main components of a decentralized app. Now let's go to we'll talk about privacy a bit. Now, it is very important that when designing a decentralized application, you privacy of the user must be in the forefront of your mind. Meaning you're not asking for data you don't need, you're not publishing data that you don't need, and you can also leverage some well-known um, algorithms like zero proof of stake, zero knowledge proof rather, and secure multi-party computation to ensure that there is proper anonymity between the users that are using your decentralized application. And this can help maintain privacy and also compile with regulations like the GDPR and the CCPA.
I have a reminder for Joe.
Excuse me. So, delve into like some real world case studies. Like I already showed from the second slide, I like to build applications a lot. So, in 2021, I had an idea while on a run to build an app to basically reward you for being active during the day. So, the more calories you burn, the more steps you burn, you can convert them into a crypto token. and actually sell that token for cash eventually on the blockchain, as well as buy digital applications in app. Unfortunately, the project was sunsetted a couple of months ago because lack of proper business. But I just wanted to touch on some real issues that I ran into while developing the app. And the first one was basically creating an internal address for each user on the app. So while we had our own blockchain address for the main app that holds all of the tokens represented in the app, we needed to give each individual user a way to be able to send the crypto token that they've bought on an exchange into the app so they can make in-app purchases. Now, the first solution that immediately comes to mind is, okay, let's create a wallet for every single user so that they can send from the external wallet to their in-app wallet. This will mean managing the user's private key and public key, or even giving it to them. And when a transfer happens, we might need to run a job to go through all the wallets to collect all the different tokens and finally send them to the Calorie internal address. That would have been very expensive to do because you need to pay gas cost for every transfer that you do on the blockchain. And also it would pose a lot of, it would be cumbersome to have to manage everybody's public and private key or give it to them in terms of, okay, what happens if if their wallet is compromised and want to change their internal address? That becomes like a whole nightmare. And I was the only one working on the project in terms of development at the time. So I had to find a simpler way to get this done without breaking the bank. So we're going to talk about my solution a bit, but before then, I just wanted to give you guys like a skeleton of what an ERC20 token, what the function looks like. So this is an interface, and we're going to be talking mostly about the transfer and the transfer function here. So that was where most of the modification came. So after doing some research, I came up with a solution to do some kind of address forwarding, whereby I have a mapping of auto forward addresses, basically. So what happens is I create I generate addresses for each individual on the app. I create like a private and private key for each individual on the app, and then I map their public address to the internal Calorie blockchain address. So whenever they do a transfer to their public address, in that same transaction, it's automatically forwarded to the internal Calorie blockchain address. But then I still get the notification that the transfer had occurred on their in-app public address that was generated for them. So it's like killing two birds with one stone. So I knew that, yes, it's this user that did that transfer, and the tokens are automatically in the in-app Calorie blockchain address. So what really came to the saving grace was this function. I'm not still sure how to pronounce it. It's been a while on it. It's the EC recovery function. So what this does is it basically extracts the public address from a signed message. And 1 second. It's a built-in cryptographic function we use to recover addresses on EVM blockchains. Blockchains that are compatible with Ethereum virtual machine. And we first get the hash, and then this V, R, and S. The V is the chain ID. The R and S are two components of the signature obtained from the signing process. So we pass all of this, including the signed message, into the ER recovery to get a forwarding address. So using this, I only have to set up the forwarding once, maybe at the point of creation, which can be cumbersome, but we did it at the point of when the user actually wants to do an internal transfer. So at the point when they want to do an internal transfer, so they generate the address for the first time. If that's not been generated, this saved us a lot of money during that. So we signed you can notice this. So we signed the message, and this is the Java function now that calls the smart contract. There was a bridge between our Java API and the smart contract, where we generate the key pairs, and we get the signed message and hash it, and then we sign it. The signature data is gotten at this point, and yeah, this is all gas limit and all of that. And then for the transaction, we set up the forwarding address using the VRS function. So we pass the signer address, the inbound address, that's where the tokens are supposed to be forwarded to. And then we get the V and the R and the S and call it. So at this point in time, we have gotten from a transaction receipt the new, what's it called? The signer's address. And that is saved from the forward address model. So we now have the forward address for each user in the app without having to create individual wallets for them that can be managed. And this is easy because if we want to invalidate an address, we just need to run this function again for that particular user to generate a new forwarding address for them. And they don't have to know anything about the public or the private key. We also, using this, created a service for the users where they can, if they by mistake sent a token that does not belong to us, I had a process for them to be able to recover their token using the private key that was generated for this address forwarding. So yeah, that saved a bit of money and funds for us, really. Yeah. So now when we call the transfer process, it goes through the various checks and does the before token transfer checks too. It checks the balance of the seller and then gets the sender and the recipients of where we're transferring the token to. Now, we do, inside of a small while loop, we keep emitting the transfer event to the blockchain that will transfer from one address to another while we are getting the auto forwarded to for that particular incoming address. So for the users in our app, because this contract is running for everyone on the blockchain, but specifically for the users in our app, when we query their address forwarded to, the calorie internal address comes up, and then the forwarding happens that of the tokens directly to the internal address. But we still get to emit the event of the address that we assigned to them that the transfer has occurred in that address, and that way we can automatically assign them value on from our backend Java API. And that was how we solved that issue. So eventually this became what the structure was. So instead of having wallets, we just had a forward address for each users. Another case that I worked on, that was last year actually, this was Sacco. I was going to participate in an early token purchase for a new project, and I was asked to send the phantom tokens or FTM tokens to the user's address so I can get my pre-seed token. It required a lot of trust because I had to trust that the individual would actually send me the ERC20 tokens after I sent him the FTM tokens. And I'd never met this individual before. So that inspired me to build Sacco, which is a platform for transferring or decentralized swapping of tokens without having to go through an automatic market maker, just between two individual users. Now, this is the initial problem. I have asset A and he has asset B, and I want to give him asset A, he wants to give me asset B. Ideally, we use a middleman, which is what we do with banks right now, where we deposit our money and then the banks loan it out to someone else. The bank is playing the middleman, or you can have a physical person that has both wallets, receive both tokens, and then swap out the tokens to the other two users. But that still requires a lot of trust. So what Sacco does is it replaces this middleman with a smart contract that has a deadline. So the smart contract has been programmed to receive a particular token in an address and an amount and wait for this period of time to be swapped out. So I deposit my FTM into the smart contract and give it a deadline for where the transfer has to happen. So after I deposit, I cannot withdraw my tokens if that deadline has not been met. And the user can go and withdraw my tokens only after depositing his own tokens into the smart contract before the deadline is reached. So after the deadline, I can withdraw. If the user has done the swap, I can now withdraw the user's tokens. If the user has not done the swap, I can now withdraw my own tokens. So this eliminates entirely the need for trust. Excuse me. Now, while developing Sacco, I because I used a factory design pattern where the factory, whenever you create a swap contract, it's an individual instance of the Cycrobatter contract itself. So I can have, for every single swap that's going on, we have different contracts running on the blockchain. Now, I needed a way to be able to say, okay, if there's some kind of bug has been identified or some hack has been discovered that I by mistake overlooked, I need a way to pause the entire contract. So when designing your application, this is something that you also need to like put in mind, a way to maybe pause the entire contract and so that you can evaluate any kind of hack or any kind of situation that's going on, unforeseen circumstances basically, and treat it before resuming the contract. So because they were all being created by the Cycrobatter factory, I added a pause function on the factory itself that its child batter can call. So we have the check pause, it instantiates the factory. This is running inside the child instance now, and check if the factory is paused. So if the factory is paused, nothing can work. So this is a function to transfer tokens for ETH. It's one token for another basically. And it also has to check the pause function to make sure that there is the entire platform is running smoothly and there's no issues before it actually goes through with any kind of transfer. This pause function does not affect the withdrawal of your token from the contract. So if you deposit your token into a contract and the entire thing is paused, you can still withdraw the tokens you deposited, but no swap can occur. This actually saved a platform called Gist Finance some time ago, where there was an issue with the DAI. The DAI is a kind of crypto token that is pegged to $1. It lost its peg for some reason, so a lot of people were taking advantage of it because a lot of smart contracts were hard coding the value of DAI to be $1 as opposed to getting the current value using an oracle like Chainlink. So they were able to pause the entire smart contract and upgraded it to use the Chainlink price feeds instead of the hard coded $1, and that saved them millions of dollars. So a way to always halt your contract is also something to consider while developing your DApps. Another thing that that really came in handy was centralized logging. So we needed to know when a trade had occurred so that we can send notifications to the users, or when a trade is completed, so we can also send notifications to the users. But then the notification output function was running on our Java API service, not on the blockchain. So the service needed a way to listen to the different batters to see when these events happen. However, I just told you that we're creating a new batter instance for every single transaction, every single swap that's for every single batter that needs to go on the platform. So what I did instead was to put the notifications on the factory itself. So whenever a batter wants to emit, wants to emit an event, it has to call its factory, that's its creator, to actually tell it, okay, I have done this, so you can emit the event. So that way, we only get to listen. As you can see, this is it calling the factory and notifying the factory of the event. So we only get to listen to the factory's contract on our Java API service. So that's making all the logging go through the factory, give us a single point of audience, or rather a single point to listen to while waiting for events on different batters. And the address of the individual batter has been passed on the event, obviously, to identify which batter is actually responsible for that event. So yeah, this is just a mock-up of the different batter calling their factory, and the Java API service listening only to the factory to publish these events. Now, these are some successful decentralized applications that have properly leveraged the use of blockchain. So we have Gist Finance. It's a popular one that runs on the Phantom blockchain that I actually use quite a lot. So if you are not willing to sell off your assets, but you need some money, you can deposit your assets on Gist Finance without any KYC or anything, and withdraw some stable tokens from there. And then you can get the cash and pay back whenever you want. Now they have an incentive for these deposits. They pay you in Gist token for having deposits there and even for borrowing. So you're incentivized to also to deposit and to borrow. We have VChain, which uses blockchain to improve transparency and traceability in the supply chain management. I haven't quite delved into that a lot. And there's a collectible game where you get cats and you breed them and try to make them as rare as possible to improve their value. It's a whole game and a whole platform. It's used by millions of users called CryptoKitties, and it's running on the Ethereum blockchain. Yeah, that's all I have to present today with regards to this. Thank you very much.
Okay, thank you, Emmanuel. Thank you for this great talk. So let's go ahead. We should start our Q&A session. Please, Darren, if you can turn on your camera so I can add you. There you go. Okay. So thank you. Really nice talks and very interesting topics, both of you. We have some questions already and waiting for more. I believe that our community is sending all the questions right now. So let's start with you, Darren. There is a first question here. So it's about attribute-driven design. Sounds a lot like another approach. I read about architecture, characteristic-driven design. Are those the same in your opinion? Have you heard of architecture characteristics?
Unfortunately, no, I didn't hear about characteristic-driven design, but there are other methodology that are near approach, such as URP and other methodology. Finally, before I discover this methodology, when I when I was a student at the university, I started to organize the way I am thinking about. After that, this methodology helped me to improve the way that I am thinking. So I am sure that there are other methodology that help us to design better software.
Got it. Okay. Great. So now, Emmanuel, we have a question for you. So with the buzzword of AI, would decentralized applications be able to maintain their relevance in the long run?
Yes, those are two completely separate kinds of technologies. Eventually, they would complement each other in the future, but the buzz of AI does not necessarily affect the progress of blockchain development. AI is a machine doing stuff for us, while blockchain development is having decentralization in all the different factors or the different applications we use. So the apps they will definitely remain relevant, and they're still in their infancy, in my opinion. There's a blockchain called Phantom that is currently working on abstraction of accounts, where you don't have to click verify for each transaction you do, but they can just be a pool of tokens, and then they automatically withdraw to simulate some kind of Web2 experience while using your Web3 protocol. So when that goes live, you will be able to see people building with AI a lot of more decentralized apps that are backed and running off of AI. So I believe they would complement each other and not kill each other in terms of relevance.
Okay. So it's more at the level of being a complement or helping on some of the processes, no? Because
Yeah.
we know that AI is really evolving a lot,
Yeah.
and there
Yes.
is a lot of Okay. Another question for Darren. How is ADD different from DDD? Of course, this is a good question.
DDD, domain-driven development, it's more about the domain. So if you noticed in the slide step, sorry if I check my slide, step 5, initiating architectural element and the pattern. So ADD, we can use it come and DDD, we can use it as pattern for design our domain and functionality, but it does not take in consideration the key driver. So ADD, it's for me, it's bigger. It's the whole concept about my characteristic, non-functional requirement, and my concern. So for me, I use DDD inside ADD.
Okay. Interesting point. So there's another question here. Let me see this one. So what architecture tactics catalog do you use or recommend to use during the architecture development?
There is a lot design pattern, a tactics for the different non-functional requirement as availability and other. There are a lot of tactics. They are you can find them in the book that I recommended, Software Architecture in Practice, and for every non-functional requirement, there is specific tactics and specific trees to follow to need your decision. And if you want, I can find you a link to send it after that to help you, because it's very large topics.
Yeah, that's great. Yes, share that with us in the main chat. Okay, Emmanuel, how we can make use of cloud services, like all the ones that we know to deploy these kind of decentralized applications.
Okay. That's actually a very good question because, yeah, leveraging old technology to promote new technology is always a good question. Now, there are two main ways to utilize cloud services when you're working with DApps. So, one could be either you're creating some kind of node for blockchain that can be deployed on cloud services, like maybe Matic or Phantom. You can use cloud services to deploy a node and also verify data. And then you can have your own copy of the DApp running on maybe AWS or Google Cloud. Or if you're building your own DApps, you can host your front end assets on the regular cloud services. That's your front end interfaces can be hosted on those cloud services. Your domain name can point to them. And then what I do is I have, because I work with a lot of Java backend, and I host the Java backends on Google Cloud, and they are continuously listening on the blockchain to handle events and notifications. So it's like a complement, they complement themselves. So you can have your APIs running on these cloud services. You can also have your front end assets hosted by these cloud services while they're connecting directly to the blockchain.
Okay, understood. So in that case, then the decentralized applications are acting more as the backend of all these other services that are in the cloud.
Yes, they can be running as the backend for your front end services that are hosted on the cloud, or they can be running as the main backend, and you can also have backend services hosted on the cloud that is reading data from them. Like take for example, when I built the Calorie app, because it's a mobile application, I did not connect it directly to the blockchain. I connected it to my Java API, and then whatever blockchain it wants to do, whatever blockchain activity it wants to do, the Java API does it on behalf of the individuals on the app. So the Java API is responsible for communicating with blockchain for, if you want to send your tokens that you've earned out of the app into an external wallet, the Java blockchain knows how much token has been assigned to you in the central token, in the central wallet, and it's responsible for migrating that money or token from the central wallet to whatever address you want to send it to. So yeah, it depends on what problems you're trying to solve.
Good. Thank you for that. Let's go for another question here. So, Darren, how long does it typically take to follow the ADD method for architectural design to produce a finished architecture?
It's depend on practicing. Sometimes we start designing without taking the the good goal in objective. So may sometimes the result may be not correct. So to avoid this part, if you start to practicing using ADD, for me it's more easier and less time when designing every system, and it is depend not the it is depend on the complexity of your system. For me, in a simple word, sometimes okay, I am able to do design in one day, and some topics that I don't know, I need to have more expertise and finding a person with expertise to help me. So it will take me more time to understand the problem and to help him. But the way that we are starting to do ADD, it's more like DDD development step by step. So every time you train to do it in correct way, you will be it will be more easier to do it.
Okay. Okay, and well, I have a follow-up question there from myself. So when we are talking about these attributes and like, for example, performance or all of them, do you have any, based on the experience, any uh, advice on how to really start? Because it's a very different approach, of designing, doing the design of a system. So, what is first, or what is most important, the most important attribute to start with?
It's difficult to say. For me, the most important is the availability for me, because if my system is not available, so it will be complex to tell that I have a system. After that, if the user said performance and he need to wait 5 or 10 minutes to get his response, so he will not use my system. Also, a lot of company sacrifice the security. So I am not able to tell what is the most important. It's based in every scenario. For example, I am not able to create auto driving car without safety. So, but I am able to tell, yes, my car will not be so speed 20 kilometer per hour, not Formula One. So it's depend on the system that we are architecting.
Yeah, that's a really good answer, Darren. Let me go to the next question for you, Emmanuel. Do you build trust in decentralized apps, considering all the hacks that happen in smart contracts?
Uh, okay. Again, the topic was about not needing trust. So, if you can avoid trust as much as possible, avoid it. Go for factual, verifiable proof that you can actually use it. And one of those proofs could be the smart contract audits. Make sure that the platform is being audited by a very reputable smart contract auditor, and they've given it like a proper pass mark. Those informations are usually available to everyone. And secondly, the team, try to work with decentralized apps that the team behind it have been doxed. So you know the individuals that actually built it. There are a lot of financial gains to be made from non-doxed applications. But if you want to stay on the safe side, always go after doxed teams. That's the teams that are doxed. Or even if they're not doxed, then the main blockchain owners that are doxed would have maybe they verified that, okay, this decentralized app, even if the users want to stay anonymous, is actually safe to use, and we're in collaboration with them. So there should be some form of accountability in terms of how the app is being generated. And the code base is also on GitHub most of the time. So you should go after dApps that have open source code base so that you can read and also find out if there are loopholes in the contracts, things that can be exploited before you use them. So yeah, just use very popular ones that have been properly audited and they have actual human beings behind them, and you'll be safe.
Great, great. So, well, Uh, uh, so in both of your talks, I think we learn a lot, guys. I really appreciate all the time that you put here for us, and uh, I think all the people had a great opportunity to learn a lot. No, so we don't have any other questions in our queue, so I will let you maybe say some words to finish your participation here, and then we will continue with a small break and then our next speaker. So Darren, maybe you first.
Thank you for software Worldwide Software Summit a lot, and that make me so happy to participate in this meeting. And if you have any question, don't hesitate to ask me, and I will do some more deep dive about characteristic-driven design. I noticed that is launched 2021, so I will check and maybe I am able to answer better. Thank you, everyone.
Thank you, Darren. Emmanuel?
Yeah, I really appreciate this conference. I think it's good. Knowledge sharing is always appreciated and encouraged. And if anyone wants to reach out to me, maybe you want to read some boring code or anything, or need like link to my project on GitHub, I'll be very happy to share. Just send me a message on LinkedIn. Appreciate you guys.
Awesome. Awesome. Thank you very much, both of you, and see you later. Bye bye. Okay, community, we are ready for our next round of speakers. The Our next speaker actually is ready here, so I will add him here to the stage. Hey,
Hi Hugo, how are you?
all good, all good. How are you?
I'm amazing, doing great. I just
That's
want to like
great.
thank the whole team like Geekle and like the whole team to basically provide me this opportunity to basically speak over the topic that I love the most, and that is Web3. And it's completely my pleasure. And I'll try to basically explain all the terms in a very precise manner so that people will get to understand what I basically wants to deliver to them.
Awesome, awesome. Yeah, Web3 is well, is a nice, really nice topic, and also wondering to or looking forward to hear your explanations. So I'm going to add your presentation to the stage,
Yeah,
and if you're ready, I think we can start.
yeah, okay. Sure.
There you go. Go ahead,
Yeah,
please. Thank
yeah. Hey everyone, it's Karthik this side. I am a developer who is basically building into Web3, and also I'm an open source advocate. Basically, I contribute to open source projects. In those projects where my skills can add values to, I always try to communicate with people, network with awesome developers, and try to share my skills and also learn from them as well. And in this session, I will basically try to explain you all in a quick manner, how basically Web3 is trying to bring revolution in the world of tech, and how it's basically important for all of us to make a switch from Web 2 to Web 3, because as we all know that as the time goes, technology evolves, and we should always adapt. So without any further delay, let's dive straight into it. So yeah, Web3. So without before going deeper into Web3, I think like I should tell you what were the earlier architectures of webs, and not architecture, basically the earlier phases of web. So we were having two webs, Web 1 and Web 2. Web 1 was the initial phase, and basically the, I would say, the first foundation of the World Wide Web. And Web 1 was having too many issues, because it was having it firstly it was only static, and so people do not have any interaction with it. So let's basically try to understand it in a more deeper way. So yeah, Web 1. So as I already told you, it was the first web, and it basically came into existence to late 80s, and it lasted till 90s. So Web 1 was basically a web over which documents were connected with each other, and creates a whole network, and all those documents were connected using hyperlinks. The whole web consists of static content, and what I mean by static content is no content can be altered, and like the user were not having the authority to basically make some changes to the content. They can only read that content, and that's the only reason basically I put an I in this presentation. That's basically reflecting that okay, user were only able to read the content, only to consume that content, and cannot basically were not basically able to write any content and create some engagement. Okay, so it was a static web and limited accessibility, as I already told you, because people were only a few authorities were able to produce that content, deliver that content over the web, and the users which were basically intended to use that web were basically only allowed to consume that content, and basically yeah, that's pretty much it. So there were some issues due to which the concept of web 2 was introduced. What were the limitations? So the first, the web was static, so it was only limited to a few RAM of context. Second was limited accessibility to user, due to which the user interaction was too low, and also there was a very low personalization for users. And whenever we are basically talking about users to use something and to basically work over something, so I guess that user must have some sort of ownership and some sort of access self personalization to due to by having which they can basically build a nice engagement, and also they will basically love to use that particular application or any services. Also, just because only a few authorities were able, or I would say were having permission to upload the content, so there was only a limited data over that web, and hence I basically the last point is limited multimedia. So it was completely about web 1. The web 1 was not that much scalable, and it was scalable, but it was not having the features that it should provide, and hence we basically switched to web 2, and a new web basically came into existence, and that was web 2. We are currently using web 2 right now, and also the platform we are using right now, that is StreamYard. Okay, so this platform is also running using the web 2, basically this web 2. So web 2 was an improvised version of web 1, and also it basically provided some facilities which were too appreciable, and which are still appreciable as well. So web 2 basically switched the concept of static web into a dynamic web, uh, where people are allowed to basically produce the content, engage with that content, and also I would say the main benefit of web 2 was basically that it provided users to engage with other users and other applications throughout the web in a more efficient manner and a precise way. But just like each and every technology has its own pros and consequences, so web 2 also came with some flaws and some cons. Those were like privacy concerns, just because in web 2 there is complete centralization, like few authorities basically provides you all the services, and users don't own anything, users owns nothing. Okay, so only a few authorities I would give you an example because I don't want to be a bit specific, but yeah, you are having the idea. So these authorities basically provide you a service in a very nice way, which must be appreciable, uh, which must be appreciated. But the thing is that just because there is a centralization and the user owns nothing, so users not having I would say the control over their own data sets. And just because users are able to basically produce the data by basically using social media platforms, using platforms like YouTube, Instagram, and other platforms, also like blogging platforms like Hashnode, Medium, and rest of the blogging platforms. So web 2 basically made us able to produce the content, also to engage with that content, and also just because each and everyone is producing the content, the data that it generates is too massive, and hence to basically deal with that data, authorities are having massive data data centers which handles massive data. So these were like some benefits where we got some scalability, and we got some I would say the robust version of a web, and also we are using it right now, and we've been using web 2 for long. And just because the only reason it's it is sustaining is just because it's having some it provides awesome functionalities and features. But apart from those pros, it also have some consequences that I already told you, that each technology come with consequences. So these cons are privacy concerns, centralization, no ownership, because users do not own anything. They are basically just not having that authority, and the data basically that they generates, they are not having the I would say the ownership of that data. Okay, and if an attacker basically try to manipulate the network and basically try to steal some information through the network, the attacker can do it. Okay, and then dependency. So why I wrote dependency, basically the only reason for writing dependency over there is because just because of the centralization and your reliance over some authorities, you are dependent over those authorities. Just suppose the owner of that authority, that particular authority, just suppose that owner don't want to basically provide you some, I would say, uh, don't yeah just suppose that owner is no longer willing to provide you the services. So that owner basically, or that authority can basically stop providing those services, and users which were basically using that service will no longer be able to get benefit from those services, as I would say the organization that's supposed to basically provide the services are no longer providing it. So by like due to this, all the users in this network are basically dependent over that particular organization or authority. So these are some flaws, the major flaws, mainly privacy concerns. So after looking all these pros and cons of the earlier webs like web 1, web 2, and we are using web 2 right now as well, a new concept of web 3 was established, and that was this web 3. So what is web 3, and how it basically different from how it basically differs from the earlier webs? So we can say that web 3 is an improvised version of web 2, because web 3 isn't the developing phase. It is not being developed completely yet, but some amazing features that it provides, and it comes with lots of features, out of which a few of them are decentralization, trustless agreements, and user ownership. There are some other features as well, some other benefits as well, but the major features that in my perspective that I think, and that basically really fascinated me to start learning these stuffs, basically to basically dive into the this technology, that is web3 and blockchain. Those features were decentralization, user ownership, and trustless agreements. So what I mean by decentralization and how it is different from the earlier web 2. So using this concept of decentralization, in web 3 we basically eliminate the single authority, the single organization that we had in web 2, and we eliminate this authority, and instead of this we do not put anything. We just basically connects the computers and the machines of local users with each and everyone in a peer-to-peer network. By doing so by doing so we are not having a single authority. By doing so we are having all the users connected with each other. So in this network only users are basically, those are the people who are providing the services, and also who are basically consuming the services as well. Apart from decentralization, trustless agreements. So trustless agreements are basically able because of smart contracts, which are basically written in languages like solidity or viper. I personally use solidity because firstly I would say both languages are super and too powerful, but I personally use solidity because I found that language a bit more easier, and I would say too resonating with the JavaScript. And as I already told you that I was into a full stack development earlier, so I've used JavaScript a lot, and hence to basically learn Solidity was an easy choice for me. And it is one of the best languages that I've learned so far, and I can say it clearly. So trustless agreements, Web3 provides trustless agreements, and the reason, I would say the key technology that helps to providing this and basically making this able is basically smart contracts. After that, user ownership. So as we already know, and I already told you that in web3 we are not having any centralization. So, and we are the only one who are basically working in the network, in a peer-to-peer network. So the user having complete ownership of their data assets, their digital identity, and they have their own keys, public key and a private key. Private key that must be kept to private, otherwise some I would say privacy issues will take place and concerns will take place. And also the major drawback of the of by like of web 3 is that if someone get to know about your private key, and like that person is basically having your private key. Yeah. So, yeah, if that person is basically having the access of your private key, then they can basically have the access of all your data you are having on blockchain. So private key must be kept to private and should not be shared with anyone. But if the user are able to basically hold their private key in a very confidential manner, then there's no problem with that, and hence it provides basically turns out to a feature. Now diving deeper into web3, like some other concepts. So these are some underlying technologies. These are not exactly all the technologies that I basically mentioned over here. These are only a few technologies like blockchain. So Web3 highly uses blockchain. Decentralized storage, for it, Web3 uses IPFS, which basically stands for Interplanetary File System. Then cryptography, I guess you must have heard about cryptography, like what is it? And then smart contracts. Apart from these four things and these four paradigm, there are some other stuffs as well. Okay, but these four are major. So let me explain you like in a very short, like in a very quick, like what exactly these are. So blockchain is basically appear to be a network of all the people who are basically into a network, and instead of like having a single domain, they basically share the network using their own system and their own pieces. Blockchain technology resonates with distributed ledger and uses distributed ledgers to basically make these concepts and brought them into reality. For basically storing the data, we use IPFS or decentralized storage, in which a copy of the data that we generate in Web3 is stored into each and every node of that particular blockchain, or I would say in that particular network. So the benefit of it is we can consider that just suppose in earlier web where we only have a single database or a single server, just suppose just suppose that server get crashed by basically overcrowding, and just suppose like too many people started basically coming to that or basically started using that service, and the server reached out basically crossed that limit of basically handling the crowd, and that server crashes. And just suppose unfortunately it loses the data. So the data that's been stored in that server, or like confidential data, and uh, I would say like um, very personal, like private data of users, that data will no longer be in a state to get retrieved, because the server we were having, right, like we were having in that particular network is no longer available because that server crashes. So this peer-to-peer network and basically IPFS, the concept of decentralized storage, make us basically able to basically store a copy of each and every data into the nodes, or whenever I say node, I basically mean the computer of individual who are basically in that network. So a copy of the data, just suppose I am generating some data, so that data will be stored in each and every computer which is present in the network. And as long as just suppose as long as a single computer is running, my data is safe. And now a question may arise that okay, you are saying that your data, or like people, the data of people is stored into like each and every node. So that person basically who is having my data into their machine, that person can access my data. No, it's not like that, because only those people can access your data who are having a private key. And that's why I already told you that the private key must be kept to private and should not be shared with anyone. After that, like the key technology is cryptography, where we use like algorithms and hash function to make this basically to shift all these infrastructure into a more mathematical terms, and basically to basically I should say like Cryptography is basically.
One second. I'm so sorry to interrupt you. We just got few comments and with request a little bit to slow down your speech because you're very passionate and you're telling it very fast. And if you can just a little bit slow down, you'll be fine, if you don't mind.
Yeah, sure. Okay. So should I continue?
Yes, please. Yes, please, you can continue.
Yeah. So these were the underlying technologies like blockchain, decentralized storage, cryptography, and smart contracts. Now, what are smart contracts? So basically, smart contracts are a piece of code that is basically written in either Solidity or Viper language, and these like set of code is deployed over blockchain. Smart contracts basically give rise to trustless agreements where people do not have to trust anyone in the chain and in the network, because smart contracts will work according, like in a way they are like coded or designed in a way where like in a way to basically work according to them. So smart contracts basically give rise to trustless agreements, and also these are very helpful. Now, here are some examples of some EVM compatible chains like Ethereum Classic, Polygon, Optimism, Binance, and XDAI. Polygon is basically a layer 2 blockchain, and what basically layer 2 blockchain is, so you can basically understand it like layer 2 blockchains are used as a scaling solution for layer 1 blockchain. So it is basically a network of so many blockchains over which like a blockchain built over another blockchain. So the base blockchain is known as like a layer 0 blockchain. Over that layer 1 blockchain are built, that is like for example Bitcoin and Ethereum. And over using that particular architecture and that framework, we basically build more blockchains over layer 1 blockchains. So these are like if we talk about EVM, so EVM stands for Ethereum Virtual Machine. So over EVM, some blockchains are built which are like Polygon, Optimism, Binance, and XDAI. These are basically some examples of blockchain. Now let me tell you the like impact of Web3 over industries. So Web3 has already making good impact over technologies like and industries like finance, healthcare, gaming, digital identity, and supply chain. So in finance, like we are having a decentralized autonomous organization, DAO, the concept of DAO, basically which are self-governed and governed by people who are using that, who are basically a part of that network. So we are having like cryptocurrencies and other means of like other me I would say other form of money to basically which we can use to basically exchange values. Also in healthcare, we can use Web3 to basically Web3 could provide secure and decentralized storage, and in specifically for healthcare, and sharing of medical records, improving like patient privacy and data security, which will basically ultimately enable better data analysis of healthcare research. Also we can use Web3 in gaming. So in gaming, Web3 will like enable the creation of decentralized gaming platform where people around the world can interact with each other in a decentralized network, and no single authority will be governing the that particular network, and which will basically provide the ownership of people who are into that network. Then the digital identity. So it will basically what I mean by digital identity is that people are having complete authority of their own assets. No one can basically do any data breaching or any other stuff until unless they are having a private key. So private key is very important, as you can like understand. And also supply chain. So Web3 have increased like transparency, traceability in supply chains, which basically ultimately improving efficiency, reducing fraud, and ensuring ethical practices. After this, I am having like some potentials of Web3 that basically worth considering this technology to develop it more and basically adopt it. So first is efficiency. So Web3 provides faster transactions, automated process, and interoperability. What I mean by interoperability is that as I already told you earlier, that there are some chains like blockchains, layer 0, layer 1, and layer 2. So Web3 basically provides and creates some sort of interoperability, so that each and every chain can basically communicate with the rest of the networks in a basically, I would say, and basically can establish interconnectivity with each other. After that, we have transparency. So because of smart contracts, each and everything is immutable. If basically something happened over a blockchain, you cannot basically alter it, and nothing can be altered. Also, just because there is no single authority, so everything is accessible to public. So the second point is public accessibility. Then traceability. Each and everything that happens in like Web3 has its own I would say the own record along with timestamps and dates, like which thing happened on which certain date, and when it happened. So everything is traceable. Like, just suppose if I make a transaction, and if I made so many transactions today only, so anyone can basically check that, okay, this guy basically made some transaction on this date, like on 16th of May, and hence there is complete transparency to all the users who are into this network. Then the third major potential is democratization. By this I means that Web3 is completely decentralized, due to which people are not reliant on any single domain or any single organization, I should say. It is community driven. So what I mean by saying community driven is because we are the only one who is basically running these stuffs and these whole networks. And also Web3 is like accessible to all. Anyone can join it. Now let us come to some challenges and limitations. So the major challenges that comes with Web3 are scalability, user experience and adoption, and interoperability. So scalability is a major issue because just blockchains have their own competency to basically execute a transaction per second. And for example, if I give you an example, so for example, Ethereum. So Ethereum has about like a its own competency to execute transaction uh, at the rate of like 40 to 50 transaction per second. So that won't make that is not good basically, because there's a lot of people who are using blockchain and who are basically into this network. And also there's a lot of number of transactions that take place within a second. So if we basically try to correlate basically cope up the rate of 40 transactions per second to basically number of transactions that are too massive, so it won't make any sense. So to scale that level, so there are some scalability issues over which some other companies are already working, like Polygon and other rest of the companies. Then some other issues and the other challenge is user experience and adoption. So I consider this as a challenge because not all people are familiar with Web3 and how it works. So just because each and everything that happens into blockchain or that happens into Web3, it happens in the form of a transaction. And for that, basically, if you want basically want to be a part of a network, you have to basically create your own crypto wallet and you will be basically using that wallet to spend some money as a gas fee. So as I already told you, that each and everything happens in a form of a transaction, and for that transaction to basically execute that transaction, you have to pay a small amount of gas fee. So not all people are familiar with it, and to basically make them familiar and basically I would say yeah, to basically make them familiar and to make them to adopt and switch to this network, this is a challenge of Web3. And the third one is interoperability. So as I already told you that there are a lot of chains connecting a network. So sometimes it gets subtle to basically establish the connectivity of different chains with each other. So these are some major issues, but I would say that some solutions are already built over these limitations and challenges, and these solutions are, so let us talk about scaling solutions. So for scaling solutions, we are having layer 2 solutions. So as I already told you that layer 2 blockchains are those blockchains that are built over layer 1 blockchain. The intention of basically creating these blockchains is basically to distribute the load that is being over like a layer 1 blockchain, to distribute that load over these blockchains so that the base blockchain can work more efficiently. Some examples of layer 2 blockchain I have already given you. The like if we basically consider Ethereum as a layer 1 blockchain, then the layer 2 blockchains will be which are being used for scaling Ethereum are Polygon, Optimism, Binance, and other stuffs and other blockchains that are basically built over the top of Ethereum as a layer 2 scaling solution. The next solution, or the next scaling solution, will be sharding. So what is sharding? So unlike sharding is like basically splitting up a normal blockchain into different shards. It basically acts like a layer 2 solution, but not exactly like a layer 2 solution, because uh, not like a layer 2 blockchain, because in layer 2 blockchain we basically create a whole blockchain, and over the base blockchain, like the layer 0 blockchain or layer 1 blockchain. But unlike that, in sharding we are not creating any blockchain. We are basically like distributing a single blockchain into pieces, so that the load can be distributed over other pieces. After that, we have some other scaling solution as well, like ZK rollups, consensus mechanism, and optimizations. So let me basically explain these in quick. So ZK rollups. So why we have ZK rollups, and what is the basically reason of having ZK rollups? So as I already told you that each and every blockchain has their own competency to basically execute transaction on a specific rate. For Ethereum, it is around 40 to 50. I don't know exactly, but it is, yeah, the range lies between 40 to 50 transactions per second. But just because there's a lot of transaction happening into that blockchain, into the Ethereum blockchain. So just suppose we are on a single second we are having 1,000 transactions, but our blockchain, that is Ethereum, is only able to execute uh, 40 transactions in a second, but we are having 1,000 transactions, so it won't make any sense, and it won't basically scale the whole blockchain. So basically, help this blockchain to execute more number of transactions within a second, we are having rollups, or more specifically we can call them ZK rollups. So in ZK rollups, the concept is basically to combine those transactions which are sharing some common interest together into a single bunch, and then sending it to the blockchain as a single transaction. So just suppose we are having 1,000 transactions, and the Ethereum is only able to basically process or execute 40 transactions per second. So out of those 1,000 transactions that we are having right now, in a second, or on a particular instant, we will basically, what we can do is, using ZK rollups, we will combine 100 transaction into a single transaction. So we basically summed up 100 transaction into a single piece of data, or a transaction individually, and now we are having 10 individual transactions, and each and every piece of data or transaction consists of 100 different transactions as well. And now we won't give those 1,000 transactions to the chain. We will only give these 10 transactions to the chain. And just because Ethereum can execute 40 transactions per second, so it can easily execute 10 transactions. That is a different thing, that each and every transaction is having 100 individual transactions as well. So this is a basically concept of ZK rollups. After that, we are having consensus mechanism. Consensus mechanism is basically also a scaling solution, and then optimization. So what I mean by optimization is, basically upgrading the chain according to time, so that it can work more efficiently and more nicely. So after that, here's the conclusion. Web3, as I already told you, that Web3 is a next generation technology that basically aims to provide a decentralized network, in which like people can network with each other in a decentralized manner, in a peer-to-peer network, and in a more secure manner. It basically leverages blockchain, decentralized networks, and cryptographic technologies to create more user-centric and equitable internet. And in my perspective, I would say like Web3 has the potential to revolutionize several industries, including finance, healthcare, logistics, and more, that I've already mentioned in the earlier slides. And while there are some challenges that I already addressed, so the thing is that with each and every technology, there are some pros and there are some cons. So, but just because we are having some cons, we can't basically drop this technology. We should basically work over the cons to basically try to minimize those and to make more profit out of it. Now, yeah, you can basically find me here. You can read my blogs over these technologies, and also you can connect me using mail, LinkedIn, and other stuffs. And yeah, that's pretty much it. Thank you.
Thank you, Karki. Yeah, this topic is relatively dense. Sometimes there's a lot of things
Yeah,
to mention.
it is too complex.
Yeah, yeah, yeah. It is, but at the same time, it's very exciting, no? Because there's a lot. I'm going to ask you some questions if you don't mind. So
Yeah, sure.
can, trying to do the Q&A session earlier with you. Some questions only, and let's see. Okay, so because we have already many, so
Yeah, 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 sure.
that's good. So let's start with this one. Uh, the first part of the question: Who will set the rules in the decentralization environment? Without common rules, you are under a risk of chaos.
Yeah, so basically, just because we are having a network of people who are basically working in a peer-to-peer network and connecting into a peer-to-peer network, so who will agree? So basically, these people who are into this network, these people will mutually have to agree over something. If most of, I would say, the majority of the crowd, just suppose we are having a blockchain network in which there are thousand nodes. Just suppose, what I mean by saying thousand nodes is basically there are thousand systems and computers which are into that network, which are working in a peer-to-peer network. So just suppose if someone wants to try to basically make a rule, so the majority of the crowd should basically agree over that rule. And if just suppose out of those thousand, just suppose majority of the crowd agrees to a particular set of rule, then we will basically finalize that rule. Otherwise, we will drop that rule. So basically, it's a like of kind of democracy. Like if
Okay.
majority part of the chain is basically agreeing to some changes or basically willing to do some changes, then that change will be implied in the future. Otherwise, it will not.
Okay. So the second part of the question is here, and I think you mentioned about that. No, but the last part here. No, we are actually moved from one set of identity owners to another set of identity owners. So any comment about that?
I would say like okay, so let me read it again. I'm sorry.
No worries.
I would say that we are not exactly like moving from one set of identity owners to yeah, basically okay. So let us understand it in this way. So initially, like in Web 2, like some sort of authorities were having control over your digital asset and your data. So like building a network or building like a next gen web, that is Web 3, we are basically providing that ownership to those users who are basically into that network. So it should be a nice thing now, because user is having their the complete access of their own data and also having their own ownership of their own data. So in case in this scenario, nothing misfortunate can happen, because you are the only one who are having access of your data, as long as you are not sharing your private keys with anyone, as I've already told you, told everyone in the earlier when I was basically explaining the slides. But I guess if we are like moving from one set of identity owners to others, so it's a nice thing now, because we are basically giving the control to users only who are into that network, instead of basically giving all the authority to a single organization or a set of organizations, if that makes sense.
Yeah, yeah, yeah. Okay. Another one. Does this mean we can trace ownership of articles and contents? Does this have an impact on source detection of information?
Yeah, so actually, yeah, you can basically get to know like who basically did something over blockchain. So it is traceable, as I already like mentioned that the whole network is traceable, and having some sort of democracy. So each and everything that happens in the blockchain happens in the form of transaction, and each and every transaction is traceable. And it is like I would say to the transparency is like up to its peak. If you are having the public address, the account address of that person, which is public, which is not private. So in blockchain, what we have is, we do not know each other by their name, we know each other by their public address. So if you are having that public, like that address of that particular person, then you can basically trace like whether that article or any content belong to a specific person or not. So yeah, it is traceable, some sort of.
Okay. Here, another one. What do you think is needed for Web3 to be massively adopted?
That's a nice question. I would love to answer this. Okay, so as we all know that as the time passes, technology grows, and we should adopt, like we should basically adapt according to the technology. Now, talking about the present need of Web3, so I would say there's a lot of data breaching, a single authority and organization controlling over your data assets, and also basically you are having reliance and dependency over some single authority owners, data owners. So the main I would say the main prospect of basically making some transaction and to basically making other people aware to adapt from web 2 to web 3 is basically it will provide more ownership to the user. Also it will minimize the dependency, because you won't be like asking anyone for your help. You will be like yourself, you will be doing stuff over the internet. And also it's good because it has really helped a lot into like many industries, like I already mentioned, like healthcare, whether it is like logistics and supply chain, gaming and other stuff. And also it is more secure because just like if an attacker basically tries to do some attack over that blockchain, so that is next to impossible, because if basically that person will try to do some manipulation with a single block, then the blocks which are connected with that specific blocks will get notified, okay, that something had happened to that block. And as I already told you in the first question, when I was basically answering the first question, the like how basically all the people agree to the some common sets of rules. So if an attacker basically tries to do something, so all the people which are already present in the network won't agree to that change, which will basically prevent that attacker to hack that particular network, and will make more secure network. And yeah, that's it.
Good, good. Another one that is also interesting and is regarding costs. So how to make the costs of blockchain
Yeah,
operations cheap.
so yeah, it is still an issue because for each and everything like you do over a blockchain, you have to pay some gas fee, and it varies according to the complexity of transaction you are performing over blockchain. Just suppose I am deploying a smart contract over blockchain, and that smart contract consists of only a few functions. So it won't cost me, or if I would say like for that particularly specifically, I won't have to basically spend more amount of gas fee, because that smart contract consists of only a few functions. But just suppose if you are trying to perform some complex transaction, so that will cost you more gas. And also if there's a time which basically you need to basically which basically the network needs to confirm your transaction. So just suppose they allotted you a time that okay, this transaction will finish execution in 10 seconds, and just suppose you want to execute the transaction more rapidly in a more fast way. So for that, basically to reduce this basically to enhance the speed and reduce the time, you have to spend more gas. So yeah, it is a drawback, but I guess just because this technology is in the developing phase, so it will adapt in future for sure, and we will get like more I would say scaling solution and other solution to basically get rid out of this issue.
Okay, Kariki. I think we are okay with this set of questions. I will saving some of them for our Q&A session.
Yeah,
Thank you for your time. Let me introduce the next speaker, if you don't
yeah,
mind.
completely my pleasure. Thank you so much.
Great, great. So, hey, hey, yeah. Then I'm really sorry if I'm
Hello.
not pronouncing your name correctly. So, uh, uh, welcome to
No,
the.
it's great. I'm sorry. I just need a second because it's the first time I'm using StreamYard on this, and I need to be able to share my presentation. Otherwise, it's not going to be working. And I should
No
have
worries, no
done
worries.
this.
Meanwhile, I
It's
will.
it's it's okay. Now it's okay. It's all done. Sorry, Hugo. Nice to meet you. Mm, it's a pleasure to be
Nice to
there.
meet
You
you
can
too.
hear me right. You can hear me okay, right?
Yeah, yeah. All
Oh, can you
perfect.
hear me?
I can hear
Hugo.
you.
Okay.
Yeah.
Okay. So thank you for welcoming me to the stage, and it's again a pleasure to be here at Geekle. It's not my first time, not my second time. I've been there for a while, like 2 years now. So I've been moderating and speaking, so I'm quite used to it. And you're doing a great job at moderation, so it's nice.
Thank you for that. So yeah, let's start. I'm personally very happy to listen to your speak because I'm a total fan of Quarkus, so I need to see what's new.
We can have some stuff to talk
Okay, I'll
about
leave you.
after then. Thank you.
Go.
Okay, so today's presentation is going to be called Hands-on DDD and EDA with Quarkus and Kafka. So it's a lot of buzzwords in the same sentence. So DDD stands for domain-driven design, not development. EDA is event-driven architecture, and Quarkus is a Java framework like Spring to make whatever you want, CLI, web development, native application. And Kafka is a message broker for things and in the
I'm sorry to interrupt you. Something happened with the audio. It was okay at the beginning. No, we can hear you, but something is going on. Like you're like with echo. Let's try again.
Can you hear me?
Yeah, now it's perfect.
Okay. I don't know what's happening. StreamYard is sometimes acting weird. Okay, and Kafka is a message broker. It's a lot of topics, and I don't have much time, so I will do my best to make it quick and just pinpoint you into great conversation. And if you want and have any feedback after, I'll be glad to talk with you and share about these topics. So, okay, just a little about me. My name is Gaëtan. I'm French. I have 11 years of the field of software development, and currently I'm a software architect and technical lead for Key Consulting, which is a great French consulting company, and I have a pleasure working there. So there is my social account if you want to reach me. So let's go. What about the agenda? So first of all, I will do an introduction to domain-driven design. We will take this talk about a use case, a small use case to apply DDD and EDA to it. Otherwise, it's a bit dark to present this concept. We will first talk about DDD strategy design, what it is, then tactical design. Then we will talk about behavior-driven development, BDD, which is a very misconcept and really necessary for me when you're doing DDD. After that, we'll talk about implementation and how in my project I implemented this microservices-driven architecture using hexagonal architecture for each microservices. We'll talk about Quarkus, of course. What is the anatomy of one microservice? We will recap what is event-driven architecture and talk about the different patterns that I'm using to consolidate my architecture to make it work. So the outbox pattern, the saga pattern, and the SecureS. SecureS stands for Command Query Responsibility Segregation. So, introduction to DDD. First of all, I cannot speak about DDD without mentioning these two books, especially the first one, famously named The Blue Book, which was written in 2004 by Eric Evans, who is the father of domain-driven design. I cannot believe it's 20 years ago, and we're still not fully impacted by this methodology, and now it only starts to really emerge in every project that you can see. And the second book is the Red Book, followed by the Blue Book by Von Vernon, who talked more in details and added some concepts about domain-driven design. So what is DDD? So it's a methodology that models software based on real-world business concept and processes. It emphasizes the importance of understanding and modeling the domain of the problem you're trying to solve. So basically, you have to know the model. What's important? It's the domain. Domain can be business. It's really the core of this methodology and its design. And it promotes collaboration between domain experts and developers. So we're going we're involving all the stakeholders. Everybody has to speak the same language. Everybody has to speak the same word. Even if it's French, even if it's German, Spanish, you have to speak the same language. Either it's on a conversation with a product owner or with a client, or when it's in your code, even in deep inside your code, you have to use the same ubiquitous language, because that's how you can understand fully the business. And that's what DDD is about. So the methodology provides a set of principles and complex patterns for designing complex software design. This is the strategic design. We can talk about domain events, bounded context, and context maps. After that, it helps to identify and define the core concept and the relationship within the domain. So this is where tactical design enters. You can have to define entities, value objects, and aggregates. I will dig deeper in that after. What does it lead to, DDD? It leads to, in my opinion, at least, higher quality software that meets business needs more accurately, as it's designed around the problem domain rather than the technology itself. So you have to abstract yourself, whether it's a UI, it's a web app, or is it going to persist in an SQL DB or no SQL, or is it going to be in a graph DB? The technology doesn't come into the mind of people before long after you talk about the domain and the business. This is the most important. And last of us, it facilitates adaptability to business changes as the software model evolves together with their understanding of the domain. And we call this evolutionary design. Okay, so I will take a use case. I will take a meal ordering system. I will make it very simple. This doesn't have, and I want to say, this doesn't have to be a microservice architecture. This doesn't have to be event-driven architecture. This can be a modular monolith, a distributed monolith. I'm just talking about microservices because for the purpose of talking about it, not because the application needs it. I want to state this. So this application is about customers ordering meal products. There is a payment system. Restaurant prepare the products, accept the order or not, and customer can track the order. That's it. So let's start with what is DDD strategic design. DDD strategic design is about, as I said before, ubiquitous language. You have to share language between domain experts and developers. This is very, very important. It's all about business. Ensures clear and consistent communication, reducing misunderstandings and improving the accuracy of the software design. Second, we have bounded context. Bounded context for me are, there's many words for this. You can call them domain, subdomain, and it can end up being a microservice. It can be ends up being a module of your monolith. But for me, it's a unit of business where everybody speaks the same language. So it defines explicit boundaries within which a specific model and ubiquitous language is applied. They allow for a clear separation of concern and help manage complexity in large software systems. Context mapping. Context mapping is the mapping between different bounded contexts. So I will show you after a bit. Basically, you identify different contexts like order, payment, restaurant, customer, and then you have to map them between each other, like which one is using the other, which one is conforming to the other. So it's a technique used to define the relationship and the interactions between those bounded contexts. After that, we have the domain events. Domain events are very important because they drive everything after. For me, domain events is the start, as we will see in the event storming session, because domain events define your use case, define your scenarios, define the actions of the business that will occur in your application later on. So it's a state. those events enable loose coupling and asynchronous communication between different parts of the system, promoting scalability and flexibility. After this, there is like the strategic aggregates. I will talk again about aggregates later, but they are clusters of objects related in a single unit. They encapsulate business rules and protect the consistency of the domain model. This is one of the hardest things to define and to identify and to implement. So I will go deeper into this after. And there's the core domain. In DDD, you have different types of domain. And the core domain is the one which gives you the, which makes your application or your company worth it. Basically, why this is the core domain. Why is it for, and what you have to do for this core domain, and what is it going to do for your application? And this core domain needs to be identified in the beginning. Your application needs to be direct about this core domain. If you're doing meal ordering, it's about ordering. So during this process of tactical strategy design, Alberto Brondolini invented, quotes, the process of event storming, which is a collaborative workshop technique that helps to uncover and model the domain by capturing events and their relationships. So I advise you to go to his website. He's very thorough about it. And it's a technique that involves all the stakeholders from different domains coming together for a workshop-style session. So basically, everybody is coming either virtually or in person, and they have post-its, they have labels, and they put it on a whiteboard. And everybody is putting his part of it. Developers, stakeholders, domain experts, principally domain experts because they know what they want and they know what the business is about. So this aims to uncover the essential events in business processes within the domain by encouraging open discussions and knowledge sharing. To be honest, it's better in person than virtually because you can have like a 2 miles long dashboard, and if it's a big business, it's quite interesting to participate in that. So you use sticky notes and cards to capture domain events. You start with the domain events, and then you map those events to relationship, commands, and users. So I will, for my application, I will do just a small example of this. Let's say my application is very small. It's just a meal order application. So let's say we're 3 people and we just like brainstormed and then put some sticky notes like order created, order paid, payment completed, order rejected, customer created, payment canceled, order canceled, payment failed, order approved. Basically, that's how it starts. Everybody puts the sticky notes about business actions, domain events. So you collect those domain events. Then you refine them. You put them into consistent and cohesive units. So you can identify already orders, payments, order rejected, order approved, maybe can be done by someone else, like the restaurant, and the customer created can be somewhere else. And we end up with something like this. So the yellow sticky notes are the actor, the blue sticky notes are the commands, and then we still have the domain events there. And you end up with something like this in a really simple way. The user order leads to an order created. The user pay leads to a payment completed or failed. The user wants to track the order. The restaurant might reject the order or approve the order. And a user has to register itself before ordering, of course. So this is really a quick, not recap, but quick introduction to event storming. So now let's talk about tactical design. Tactical design is more about like how you're going to implement after. You're going to use entities. Entities are objects defined primarily by their identity and lifecycle rather than by their attributes. Value object is a very powerful pattern because in your code, you don't define a string name or a string first name or a string, for example, zip code, something. You give names to objects. You give names to types. An address is an address. It's not a string, street, string, postal code, string, country. It's a value object which is immutable at a t time. So as I said, we're going to come back on aggregates. Aggregates are clusters of domain and objects, entities and value objects that can be treated as a single unit, having a root entity, which is the entity, who ensures the consistency of the other entities as a whole. And it's known as the aggregate root. Domain services is an operation that does not conceptually belong to any object, and it can be implemented in a domain service. These services contain domain-specific only operations. Repositories are a mechanism for storing, retrieving, and querying aggregates, and factors are a way to encapsulate and create complex domain objects. I will pass on this. So basically, about tactical design, I come back to the event storming I was doing before, and it can seem really rushy, but we identified like 4 contexts that can become microservices: 1 order, 1 payment bounding context, 1 restaurant bounding context, and 1 custom bounding context. And with talking with the stakeholders and the business, we identified order root, which is the order aggregate root. We identified value object like address, money. We identified other entities order item, product, restaurant, customer, which reside in 1 bounded context, which will after become 1 microservice. In my example, at least, not every time. So you can see how we can get out those aggregates, which is a really, really difficult thing to do. A small part of behavior-driven development, which is for me really essential and important. And I want to go through some misconception about this. It's scenario-focused, so it's business-focused. It's use real-life scenario to define software behavior, provide a concrete example that express what should happen in a specific situation. It's a collaborative approach, so it encourages collaboration between technical and non-technical stakeholders. You can put it in your user story, you can put it in your specifications, you can put it in your test plan. And it leads to understanding the behavior, and it will lead to the implementation after. Like DDD, it emphasis on ubiquitous language, and there's a big misconception about BDD, and it's often misconstrued as a testing technique. Like when you use Cucumber, okay, it's about acceptance test. It's about like end-to-end test. No, it's not. It's a design. It's a methodology, not a testing technique. It helps you understand the behavior and design your use case after. It guides you into implementation of the software, ensuring it aligns with the intended design and business needs. It helps validate that the right software is being built. And BDD is an awesome complement to DDD, a scenario derived from event storming and DDD strategic tactical design that we expressed before, and can be implemented using BDD. About BDD, you can use anything you want. You can use Cucumber, you can use SpecFlow, you can use any tool you want, or just plain unit test. It's just a guide, it's just a methodology, it's not about technology. So let's now talk about how implementing this. I'm a big fan of hexagonal architecture, others call onion architecture, Uncle calls it clean architecture. So what is it about? It's about ports and adapters. Hexagonal architecture, also known as ports and adapter, organize the code into several layers of functionality, which the core business logic is in the center. So it aligns with DDD because you put the logic and the domain in the middle. That is what it is about. And that's what we want in DDD, and that's why we choose to use hexagonal architecture. It's domain-centric, as I said. It isolates the domain, the business rule, from the framework, from the UI, from all kind of noise that you can have other than business rule, which is the real thing that matters for customers. External systems communicate through well-defined ports and adapters, which is basically an inversion of control, dependency injection kind of thing. The domain doesn't know about who is implementing him or who is going to use him. He just takes care about himself. And this architecture is about interchangeability. This architecture allows the ease of change from one external system from another. If you want to go from Quarkus to Spring, you can. If you want to go from Java to .NET, you can. It focuses on use cases, and use cases, it's, for me, exactly the implementation of BDD. For BDD, you have one scenario, you have one use case. And hexagonal architecture directly supports DDD, as I said in the beginning. So this is a really great one article from 2018, and you can go to the website, and I took it from here, so it can be cumbersome. But basically, you have on the left the user interface, which I call presentation layer. We are in the outer layer, and the infrastructure on the left side, on the right side, which is all the search engine or database. On the left, you have UI, CLI, REST controller, and in the middle, you just focus on the application and the domain. And they are really tightly coupled. They are not tightly coupled. Domain is really isolated, and it go outwards. It go inwards, sorry, instead of going outwards. So the dependencies goes inwards. Domain doesn't depend on application. Application doesn't depend on infrastructure or presentation. It's just implementation, port, and adapters. Let's get down to some technical points. I don't even know how much time I have left. Not much. So what is Quarkus? Quarkus 3 is an awesome framework. I was a big fan of Spring before, and I'm still. But Quarkus is just awesome. I'm very biased, so I can only do so well. So it's container first. It's minimal footprint Java application, optimal for running containers. Quarkus doesn't have to be compiled natively to work better than Spring. It just optimized even for JVM-based application. You don't have to go native if you go Quarkus. This is a misconception. It's cloud native. It embraces the 12-factor architecture in an environment like Kubernetes. It's actually Kubernetes native. It's made to be deployed in the cloud. It unifies imperative and reactive programming. You can do at the same time, which sometimes doesn't make sense, reactive and imperative programming with non-blocking queues, with non-blocking operation and blocking operations. It's standard-based. So if you are a Java expert and you're not tied to any framework yet, it's the standards of Java. It's JAX-RS, Hibernate, JPA, Native, Vertex, Microprofile. It's all about Java, not about adding a layer of abstraction. It's the same as Spring Boot. It's just a utility, and it's helping you a lot. It's microservice first, so it brings the lightning fast start to time to code turnaround to Java apps. For example, if you compile in native, it's great for serverless application in Java. And it's developer joy. I can testify about this because it's developer centric. It recompiles at runtime to make you rock around and play with it, and it's just a joy building application with it. And now I cannot make an application in Spring anymore. So for my application, what is the anatomy of one microservice? So basically, I have one microservice in the middle, which is the main microservice, let's say, which is order. It uses Quarkus. I'm not talking about domain right now. I'm talking about all the technology surrounding the microservice. So you have all the standards encapsulated with Quarkus. You have REST-easy, small wire for active messaging, microprofile, Eclipse specifications for OpenAPI, and many other things. You have GTPC, GPA, and Jakarta persistent. GPA is now Jakarta, and Hibernate for the ORM, OpenTelemetry for distributed tracing, Micrometer for the metrics if you want to put your metrics in Prometheus, and GBoss logging if you want to put your logs in Fluentd in a Kubernetes environment or in any cloud. Basically, I just want to focus on one microservice in particular, just to give you actually, because this is one of the things I struggled the most when I started this hexagonal domain-driven mix design. So basically, there's the order at the top. On the right, you can see there's the application. First of all, there is the domain. There's the entity. So we identified the body context order, which has entity, customer, order item, product, restaurant. There's one error. There are events which are exactly the domain event we identified before, order canceled, order created, order paid. There is one domain service, and there's all VO, which are the value objects, which are meaningful for the application, which is address, money, identity, quantity, stuff like this that have meaning that encapsulate primitive types. On the right side, we have the application, which is the upper layer of the domain, which has common query when you do secure REST, which has the DTOs, which are the object that you transfer for the from the, for example, REST endpoint or something. There's the error, the mappers, messages. Now we can talk about messages, and we will talk further about it. And ports, mainly what I mentioned about hexagonal architecture, which are two kinds of ports. The input port, which are the use cases. And that's where BDD comes in. You have one use case, you have one BDD scenario, and you are implementing it in this use case. Those are interface. They are implemented in the order command handler, but they are the interface exposed to the REST endpoint that I will show later. And the output port are interface that are implemented by the infrastructure, like the GPA repository, the ORM, anything you want. So I'm going to the infrastructure. So you have ports, and then you have adapter. Adapter implements ports. That's what we said. So secondary ports implements the customer repository. Order address are the entity in JPA term, not the entity in terms of DDD. And you have mapper. And on the presentation, I have only one adapter primary, which is an order resource, which is a REST endpoint. So event-driven architecture. Event-driven architecture, what is it? It's a design paradigm where software components communicate through events. I think I need to go faster because I still have stuff to do. It's synchronous communication. It's about decoupling. It's about well, it doesn't make sense if you're in a modular monolith to use event-driven architecture. It's when your microservices are isolated and do they work on their own. It's about scalability and resilience. It's about consistency, which allows you to implement patterns like Outbox, like Saga, like event sourcing. It's about aligning this, your implementation with the DDD focus on domain events, because those domain events becomes domain events in the sense of events in your event-driven architecture, actually, which makes total sense to me. So now let's talk about the Outbox pattern. The first picture is from Debezium. So in the Outbox pattern, the idea is to not have to face commits. You want to be able to publish even to other microservices within the same transaction than you want to actually persist your entity inside your inside your microservice database, because each microservice has its own database, and you cannot fire an event and persist to your database in the same transaction, because it can fail. One and the other can fail. If you send the event but the persistence failed, then you're in trouble. If your persistence occurs but your event failed to be sent, then it's also troubling. So basically, the outbox pattern makes you persist your event inside persistence unit, a database, and your entities inside the same transaction. So this is all that is about. There's two different techniques about this. There's the pooling technique, where you have this scheduler who is checking on the outbox table. And there is the technique where you have a CDC like Debezium who is log tailing the outbox table. So a bit of code in my application that you can check on GitHub. I will give you the link at the end of the presentation. For example, you have on the top one transaction, which is create customer. You have one command. What do? You map your customer command to your customer. You set the UUID. You save the customer in your repository, and then you create your customer. You persist to the event outbox table. And what does it do? You can see below. Actually, with Quarkus and Debezium, there's an extension, and it doesn't fire an event, not much as you can see. It actually persisted to the outbox table, which is after tailed by Debezium CDC, which will put a message in the Kafka message broker queue. So this is just a snippet from my code that you can check online. After that, we have the Saga pattern. So Saga pattern is essential when you have distributed transaction over different microservices. You have sequence of transaction where each transaction update data is in the single services, and sometimes when you have many microservices, you cannot have a trace of each of them. So you need a pattern to be able to debug in case of problems, to be able to just make sense about everything and not in these transactions. Sorry, I need to go faster. When something is failing inside this Saga pattern, you have what we call compensation actions in Saga, which essentially roll back your whole operation from your order. If the payment failed or the restaurant didn't approve, then it will roll back from the beginning of the transaction. There's two types of Saga: orchestrated and coordination. Orchestration and coordination. You can ask me after in the Q&A if you want more detail. I won't go into detail. I personally use orchestrated in my project. It ensures consistency. It's isolating the failures. And Saga, once again, fits naturally into event-driven architecture because events can be triggered to local transaction outbox and in different service and communicate failure success, where you can do compensation or validate your order. So this is basically what I implemented in my project. You have your order. First, you have your order created. It goes inside the outbox table. You go through the Kafka topic. It goes to the payments. The payments is completed. It didn't fail. Then the order, the orchestrator of the Saga is sending to the restaurant order page. You can now prepare the order. The order is approved, and then it's sent back to the order where the customer can track your actual transaction. Then you have not the happy path, the failing path, where the order is created, the order is paid, but turns out the restaurant is out of stock, so they cannot accept the order. So the order is rejected. I know it's a dumb case, but still, it's just for the purpose of demonstration. The order rejects. Now the order microservice have to do the compensation unit and rollback, and the payment has to do the rollback itself too, because the order was rejected. So if the customer has to be refunded or something like this, it has to be consistent everywhere. Last pattern, and I want to finish by the most complicated one, even though I didn't talk about event sourcing, and I'm not gonna. The common query responsibility segregation pattern, which is called SecureS. So SecureS is about separating the comment from the query, as you could have seen in my hierarchy of folders. So it separates what you write using your ORM or anything inside your database from the read actions. It's a different kind of storage. Or it can be the same storage, but it optimized for reads and it optimized for write. Basically, the commands, the write, are not coupled to the read. It's event-driven. It allows microservice flexibility. It enhances performance because you can read, write. There are caveats to this, and we can talk about it after, and I can see it coming. And it fits very well with hexagonal architecture and DDD. Basically, you can, with SecureS, you can have like your ORM doing all the write, like using Hibernate or Entity Framework for .NET. And for the read, you can have, if you don't want to add another storage, you can have some kind of views and some optimized badass SQL queries reading your model for reading. Or you can have some kind of Elasticsearch if you want to have performance on the read side, but you have to keep both you have to keep both them consistent, meaning when there's a write, an event using outbox table or any kind of other pattern have to go to the other storage if you're using a different storage or if you're using a different kind of view in your storage for the user to be able to read. Because the user, when you're using SecureS, has to accept the fact that when he saves something in his database, he's not going to be able to read it in the nanosecond after. You cannot say something is created, it's just the event which was sent, and eventually, which is called eventual consistency in SecureS, is going to be consistent across all your system, but it's not going to be at the T time. And you don't, if you're doing a pure CRUD and you want your stuff immediately after you persisted it, SecureS is not for you. You have to accept that SecureS is eventually consistent. So it's not going to be immediately the same thing in your write model and in your read model. So yeah, basically I took this from the Martin Fowler blog, which is exactly what I said. The first on the top is when you have your read and write model on the same, and the model reads from the database, service provided information, user makes change forwarded, model data database. That's it. And in the second one, you have two models, the query model and the comment model. So this is basically what exactly I explained, but I wanted to put some Martin Fowler bits in there because he's an awesome person. And that's it for me, but no, wait, just go there and you can see my fully fledged project implemented here. And now it's over for me, and I hope I'm still in. I think I overdid it, but anyways, I'm good to go now. Okay, for the Q&A.
Great. Thank you very much. Very.
I know that's a lot of content, but
no, but very in all the slides, everything was very clear. So let's go to the Q&A session, and It's going to be only with you, so, and we have many
Okay, no
questions
problem.
already. Okay, so let me add this first one. By the terminology domain event, do you mean something that happens within one bounded context or other several ones present in the whole domain?
So basically, there's different school of thoughts. If you're purely DDD thinking, domain events is something that trigger another domain inside your bounded context operation. It's just a business rule, let's say. But the way I see it, and that's the way I extend DDD to be able to be event driven, is that I extract those domain events to make them usable inside my event domain architecture. So the domain events triggered inside the bounded context are going to be triggered outside of microservice to be exploited by other microservices and other bounded contexts.
Okay. Let's go to the next one. How will you materialize strategic design to artifacts and make them testable? Strategic design.
Okay, let's decipher the question first. How you materialize strategic design to artifacts and make them testable? Okay, I'm not sure what is the hint on this question, but what can I say that at the point of strategic design in domain-driven design, you're not talking about testability in the sense of software, but which is a good case is behavior-driven design, where this come in case, because in strategic design you identify your domain events, and this BDD, which is not a testing framework, which is a methodology, can be used after to do some TDD and testing, using those domain events and scenarios that you have completed with the stakeholders to make them possible to be testable. But I'm not sure what the question is really about, so it's hard for me to answer right now. But yeah, I guess testability is not really there at the time of strategic design in DDD.
No, I think that answers the question. No, because probably the doubt is if how this can be something testable. But
I get the
testability.
The testability is done after. The testability is done during the implementation, and even at the tactical design, because you already have your entities, you have your business rules, you have your domain service. This is tangible thing. You can actually test this. You can have unit tests in sense of unit, instead of scenario-based tests, which test, but not at the strategic level, at the tactical level.
Okay. Okay. Next question: do you have any experience playing architectural katas for event storming? Can you suggest any practice in this approach?
Yes, a kata would be. I think. Well, I have some videos and materials I can share with the person who asked this question. But yeah, you can. I don't have any exact scenario where you can do this, but basically just take the maybe the one full-fledged spec from some kind of I don't know. You have access to some kind of specifications, and you have access to people who have knowledge about this, and because to do a kata about event storming, everybody needs to know the business. So you cannot do something out of nothing. So you can do a kata if everybody reads the documentation and the specification of a domain, of a business beforehand doing the kata. So you have to you need people who have knowledge in order to do event storming. Otherwise, it's pointless. Nobody is going to put sticky notes on something they don't know. That's why you involve everybody. Usually the product owners, the customers, the people who owns the business will have many sticky notes. The developers will just watch and discuss. But to do a kata, you need like I don't know, just take a big specification, everybody reads it, and everybody put some sticky notes on the whiteboard on what they understood. So yeah, here there was like some event I couldn't understand, the user registered, the user logged in, or something like this. But there's no kata that I know of who you can experience this. But my advice would be that you actually read some kind of specification and gather with your team who you didn't talk to before, and then do some sticky note stuff.
Good point. Thank you. So now we have two-part question here. So let's go with the first part. Over time, I started to believe that using messaging to propagate domain events to other bounded contexts adds undesired technological coupling between them. And the second part,
I think I need the second part.
yeah. No, I prefer to handle listen domain events with messaging locally in my bounded context, and then propagate actions to other bounded contexts using API call. Do you have an opinion about that? I have a lot.
Yeah. Basically, what you're saying is that you think that if you basically what you're going against, and this is actually why I said don't do microservices because it's cool, don't do event-driven architecture because it's cool, don't split your simple modular monolith into many microservices just because it's cool to have microservices. If a modular, small, simple monolith distributed works, it works. You don't need events to make it work. You need events when you want this decoupling. It's, for me, if you introduce this notion of event-driven, and this is because of a need, because it's because of a bottleneck, you have something in your monolith. You introduce this so other microservices can do the task whilst you still work on something. So basically, you just, if you need, first of all, if you need to do REST API between microservices, why split them between microservices? Just put them in the same monolith, please. That's because the base of the event-driven domain architecture is to be asynchronous. You don't make REST API call to other microservices. You talk only via message brokers and messages. Otherwise, it's the same as doing a freaking modular monolith. Don't do microservice and event-driven architecture if you don't need it. If you're tightly coupled, don't decouple it. Just keep it simple. Keep it simple, stupid. My example is stupid because it can be a modular monolith with no need absolutely for event-driven architecture. It's tightly coupled. It would be a cool modular monolith. It's just for the sake of example. But Hugo, please give me your opinion about it.
Well, I totally agree with you to start with, and given that in a few we are going to switch chairs, and I'm going to do a talk. I'm going to address this topic also. Let's. I think
okay. I will watch it.
We'll reserve for that. Okay.
Okay.
So let's go with the next question here. What is Kafka in short? Just a message broker, or does it have any special?
In short, I like the in short question. There's no in short in Kafka. It started with a pub sub. I don't want to piss people off at LinkedIn who invented it. A simple distributed pub sub system. Now it's pretty much doing everything you want. It can be an event store. It can be a message queue, because originally it's not supposed to be a message queue like RabbitMQ and MQP. It's supposed to be a pub sub service. That's what it does the best. But now it's also a distributed cache. So there's no in short in Kafka. But my guess on this is use it for what it does best, which is pub sub, and keep it to it. Don't try to do everything with Kafka. Don't try to do even even sourcing with Kafka, if you don't need to, don't try to put everything in the Kafka message queue, and then that just doesn't work. And the schema registry thing is becoming hell. And so there's no Kafka in short, but just for me, use it as a pop sub with the small feature they have that does great, and then I think that's enough. But it does a lot of things.
Yeah, it's a good broker, and yeah, certainly you can also see others, that are that have similar features.
I like Pulsar too. I like Pulsar, which
I think we need to work together because I like it. All right, I think well, there are a lot of questions, by the way, but
yeah, I can see them. I have because I'm moderating after you. I can see the question.
Yeah,
I will answer them in the chat if I have time. Okay.
Yeah, do it, please. And now I think it's time for a quick break. So thank you very much, for the time, and
thank you, Hugo. And yeah, I will be asking questions. See you later.
Okay. Okay.
Bye.
Thank you.
Thank.
Okay, so now that's my turn to moderate the last part of this journey together. So we are waiting for Hugo to come back because he was moderating for like 5 hours and now it's my turn. So give me a heads up when you're here, Hugo. Anyway, that was great talk today, and I learned a lot. And now it's time to go with Hugo. So Hugo joined us. I will hide it to the stream. Hi again. Was
Hey
the
again, sorry.
break too short, right?
Yes, but well, I'm ready. I hope you can hear me better than before.
Yeah.
Now I'm using.
Yeah. It's real. No, I could hear fine, but yeah.
Okay.
So the stage is yours. I'm removing myself, and I'm looking forward to hear your talk.
Awesome. Thank you very much. Let me hold on. Just want to be sure that everything is. There you go. Okay. So thank you everybody for being here. As you saw already, we had a lot of excellent talks and a lot of good content. So I hope the content I'm going to share is at the same level. Any feedback is always good. So my whole intention with this talk is just to share some of the experience about software architecture and this keyword, that we all hear very often, that is the trade-off. Trade-off is probably one of the most important things that happens when we are in the software architecture. There's a lot to decide, a lot to balance, and it's everything based on exactly that, getting more knowledge so we can decide better, or at least understand the risks of what we are doing. So in the end, what we are doing is, we are in a path of choose your own adventure, because we are going to be different paths, and probably what I just mentioned here about the choose your own adventure, hinted something in your minds, that I'm going to mention in a few. Okay, a little bit about me first, and it's just some lines about me. First, I'm a software engineer, like around 25 years of experience in the field. In my blog, I'm a developer, but I had the opportunity to work as a software engineer, so doing architecture engineering for a while already. Currently, I'm director of engineering and principal architect at Mojix, and you can find me or you can contact me. There's no restrictions here. So here in LinkedIn or Twitter. LinkedIn for me is a great platform where I built a very nice circle of people that where we have this kind of discussion about architecture, very open, nothing really formal. It's just like a question answer, and it's very nice. Talking about my hobbies, if you want, one of my biggest hobbies is to read books, different type of books, in general, technology, of course, for sure, but also other type of books. So then podcast, I do taekwondo, and play games. And my driver, as many of you, of course, is my family. So there is nothing else that drives all my passion in life. But let's go to the talk, and for the talk, I really need to first explain a little bit of what you are going to see. So it's nothing. It's not a bad surprise, at least, and it's the format. So I'm combining this passion that I have for software architecture, software engineering, and one of the books that I liked, the most, and that was exactly that. Not Choose My Adventure. It's a book that I like a lot. It's not just one book. It's like the format that it has is very nice, and I think it applies exactly to what we do as developers or software architects. We are choosing our adventure while we are going in this field. So let's start. Now that I mentioned the format, so this is not a surprise. So here's a book, and the idea is to go in this journey together. It will be great to let you participate as audience and select which page I'm going to go. But well, we don't have enough time for that, but at some point I'm going to have that type of presentation. I really want to do that, but bear with me. I'm going to simulate all the paths. So we will see. In any case, we will have the same experience. Okay, so let's start. You are a software architect. You have been tasked with designing a new application. So now you have two choices. One, you have to decide if you want to learn about the system requirements, or if you want to learn about the different software trade-offs. So let me stop this, and let's imagine that. Of course, probably my first question will be, okay, tell me what you want. What's the system that you want? And our customer starts just with this. So the system needs to be able to handle a large number of users. It also needs to be reliable and secure. Okay, so we have a lot of info here, even that it's just very simple 2 sentences line, but there's some important details. First, large number of users. What does that mean? 10, 100, 1 million? Are those users are going to access the system concurrently? We don't know even what type of process they are going to do, or what type of actions they are going to do. So let's, for the sake of this, let's assume that the only thing that they are telling us is a large number of users. So we are going to imagine that the system requires a capability where this large number, I will assume that we're talking in the order of thousands. And then it's asking us that the system needs to be reliable and secure. Yeah, secure, I think, is the most clear thing here, because it's secure is probably that the user needs to have some sort of rights or permissions to enter to the system, password, and so on. But reliable, we understand that as a characteristic of a system that will provide to the end user an experience where they are not going to be affected by any problem that is happening in behind. So yeah, usually when I think about reliable, so if the house is on fire, nobody needs to know it. That's you still see the nice house. You can still go there, and we have some examples of that. In real systems. When, for example, we log into Netflix, and sometimes the results that we see there are not necessarily what you expect, but still there are results. It's because something happened, and the plan B of the system is to show some default values there, and then you're not even sure that something is happening, but with some knowledge or understanding, you see that the response that you're looking at is like a plan B or a default response while the system is recovering. You know? So that kind of thing, you know, or not losing data and so on. So you see, you know, so with just this requirement, I think we were able to think a lot of aspects of what we want. So now the next two options that we have that we need to decide, and I hope you can see my hands, and I'm doing like what the talk is about, no? The trade-off. No? So are you going to do a centralized architecture or a distributed architecture? First question. Okay, and what is that? So I will go back to page 1. And remember that in page 1, I had the option also to see what are the different software architecture trade-offs. So I will go to now page 3, jumping into page 3. Just to read, you know, a very simple definition of both. And remember, this is a very simple, it's not the whole definition of each of them, but enough, at least for this example. No? So a centralized architecture are more efficient, but they are also less scalable. On the other hand, a distributed architecture are less efficient, but they are more scalable. We have these concepts here just to be able to compare, not to do this trade-off. No, it's not necessary that, for example, the centralized architecture is less scalable, but it doesn't mean that it's not scalable. No? There are some levels of scalability that we can have and some limitations. The same with distributed architecture, it says that it's less efficient under certain conditions. No? So there are some ways to make it more efficient or to mitigate this characteristic. No? But you can see here, no, that with these two different styles, we can start our journey here. No? So I will go back page to page 2 and then continue the process. Let's now assume that I'm going to go to page 4. So I'm deciding as an architect that I'm going to do a centralized architecture. So, okay, so the centralized architecture uses a single server to handle all the system requests. So with this, we are pretty sure that the system is going to be efficient because there is no hubs, there's no networking behind the scenes. So it's probably an application that is running in the same process or on the same server with all the resources that is needed. So the execution itself is going to be good. No, yeah, let's say for now that it's going to be good, but it also makes a single point of failure, because if the server that server that is efficient, that where everything is working well, if it goes down, then we don't have our application working. No? So then we have a problem. That this is the trade-off. No, so we are gaining on one thing, but we have a problem, a possible situation in this other hand. No, so now we need to think about our next step. So let's continue the design, having this in mind. And you finished designing your system. You're confident you meet the requirement. So now this is this one. Sorry. You decide to use a centralized architecture, and you know that this will make the system more efficient, but you also need, you have this single point. So you plan, no, to implement redundancy and load balancing to mitigate the risk of a single server. So again, no, so part of this thinking process, we see that centralized architecture is not has this problem of single point of failure, but there's a solution. No? So, and it's one of the most common solutions that we have right now. And also, we have redundancy, we have load balancing. So if this server goes down, the other one will start and then take or continue the processes. There's a lot of techniques around that, but yeah, to be simplistic here it may be enough. No? So with that, then we have a nice or good ending here. We start implementing the system with a decentralized mode. We are applying all the techniques to mitigate the risk of single failure, and the system ends to be successfully implemented and is meeting the requirements of the users, because we are handling a lot of users, is reliable, and is secure. All good here. So now, given that this is a simulation, and that's one of the nice things about these books, is that I can go back and now start over and take the other path and see what happens there. So let's do that. I'm starting over. Now I'm going to do I'm going to decide to use a distributed architecture now. And what is that? No, your distributed architecture in this case uses multiple servers to handle the system requests. The first thing that we are talking about. Again, I'm probably simplifying a lot of other concepts that are around this, but right now this is again is just to see how this thinking, all the analysis that we need to do is happening. So we have multiple servers to handle the system request. This makes then our system scalable, by definition, because now we can add more servers in order to handle more requests, which is one of the requirements. And then I can think that then I can start small, and whenever the load of users or the quantity of users starts increasing, then I can add more resources. So perfect, it answers the first thing. But in the other hand, one of the aspects that we saw in one of the definitions is that this approach is less efficient. And it's true in some sense, because now these servers, these nodes need to communicate. There's let's say like hubs. So it's not like a native communication when we write our code and then one line goes to the next or calls another class, another method within the same process, processing unit in this case. Now we are talking about different components that have their own resources, own life, and now you need to communicate. There's some dependencies and so on. So that's what it makes less efficient than the other one. In any case, if one server goes down here, there is no problem. So we're still handling all the requests, so it's good. So we can finish here with this way. So we finish the designing of the system. We are confident that we are going to be able to handle this large number of users. There's no problem with that. And you are also confident it will be reliable and secure. Great. So, okay, so most of you will say, okay, so basically we ended in the same good result no matter what. So if I choose centralized or I choose distribute, then I ended here in a good result. So how I can decide? So of course the next questions or the next requirements for the system will start driving or evolving whatever you decide. So that's the nice thing, and also the stressful thing, if you want, of our work, because we need to keep deciding, keep changing, thinking ahead, so we can build something that can grow or can change. And so if you wanted to see like what, and we know that this doesn't exist, not like a bulletproof one recipe that applies to everything. There is no, that doesn't exist. And no matter what we choose, in this case, we got into a good result. But as I said, if we keep evolving, then we will see that sometimes we need to or either evolve or change everything, So let me go now to my next slide. That where I try to grab a lot of choices, not all of them. So if I continue with that book, then I can have this type of branches, decision points, where I can go from to one path or to the other. So instead of continuing the book format, let's see this here, so we can kind of visualize everything. And here we're talking about exactly that, trade-offs. So all what I did in the previous pages in the book was doing a trade-off decision. So if I go for centralized, then probably I'm going to have this problem. But if I go for distributed, maybe I'm going to have this problem, but I'm gaining this. So then, and based on the moment when you are doing this type of decision, you are going to see, if whatever you are going to decide will apply to the next steps, to the next step. So in all the previous talks that we had, you heard about that. So for example, what we heard in the previous one is, don't go darkly to microservices, for example, just because it's nice, or it's what everybody is using, or any of what you see here. And probably one of the biggest advantages of these kind of summits and talks that we are having here is that we are gaining a lot of knowledge, so we can decide better. We can see what are the real trade-offs. So in this diagram, we see two different branches. So let's say that I'm starting my project, and my first question will be, okay, I care more about performance, or I care more about my maintainability. Another two concepts. And it's not how you are going to start always. Sometimes you are going to start with a different question, and your branches are going to reconfigure. So in this case, let's think that what I care more is about performance. It doesn't mean that I don't care about maintainability, but probably this has more weight for me. That's more important for me right now. So it means that then I'm going to go to this branch, through this branch, performance. And okay, performance is what I need. Then okay, my next questions. Okay, inside performance, do you care more about low latency or throughput? Okay, hard to decide, right? But you need to choose one. And just to select which one is the most important for you. So let's think about low latency then. Okay, I will say that that's my preference. And okay, so in low latency, we have these other two options. You want to do microservices, or you want to do monoliths. Both are going to give you this characteristic, low latency. But there are some trade-offs between them. No? So in microservices, for example, probably the trade-off will be related to how complex that can become, and the type of communication that by definition a microservice has. That right now is we're talking about HTTP communication or other type of protocols that are more response or ask response, or a monolith where all the processes are running all together. No, so if I choose microservice, for example, then my next question will be, okay, and now you want to do service discovery or load balancing for those microservices. And again, here there are some trade-offs too. So service discovery, where all the microservices are registered in a way where a service, in this case, the discovery service is able to know how to communicate between microservices, or a load balancing, which is another method where you have a proxy in front, and this proxy is the one that is routing all the calls between from outside and also inside your network. And this doesn't end there, right? There are, of course, more questions that can come here, but one, I don't have a space in my slide for that, and also the main goal here is just to so everybody's clear, no, that there are some good options, or no, sorry, that you have a lot of options, a lot of paths to follow, and it's not just one way to do everything, no, and probably if you go to different branches, you are going to get also good results, no, but at some point then you need to decide again, no. So let me go to the other branch just to complete the example here. So if I decide to go that there's more weight on maintainability, then my next question is, okay, so you want modularity or simplicity? No? So probably this is relatively simple to understand. Also, you want to have an architecture that is based on modules, or something that is simpler than that. No? Let's think about modularity then. No? Then you have two other questions there right away. Okay, so you want to do a SOA, service-oriented architecture, or you want to do event-driven architecture. And this is important, you know? And there are some differences there. In one side, you are talking about orchestration of the requests and between different services that are separated. No, they are all modular and separated, and there's a backbone or a service bus or whatever you want to call it that has enough logic so it can, all the requests can travel and be delivered to other services in an orchestrated or based on a specific set of rules. No? Or you want to do event-driven. And in event-driven, we are, we are talking about events. So there's a way, the way the services are communicating between each other is very different. No? They are just kind of listening or to some type of messages and then triggering any action based on that. No? So there is a different way. And if I choose event-driven, then my next question is pops up or message queue. So it's going to be like just to be very simple here. Are these systems waiting for a push message or are just listening? No? So and again, it doesn't end here. There are more questions that you can have while you are progressing.
So with that, I think I hope I really share with you all like a thinking process, thinking about the trade-offs. There are a lot of books, a lot of documentation about each of these aspects. I'm sorry, and you will end understanding something. At some point, if you, for example, selected to use Monolith, at some point, something is going to tell you that now you need to migrate to microservices because you need to scale, for example. No, let's say that that's your big problem. You hit the limit of any vertical scaling, and now you need to go to an horizontal scaling, and probably the best way to do that will be with Monolith, or microservice, sorry, no. But then at some point, then you're going to see that some of your services require a different approach, like, for example, event-driven. So, and one of my theories, and it's something that I'm always discussing in this type of talks, is that it's not that you're going, depending on the evolution of your system, you are going to see that you have different layers. Some of them are, or your services are in one model, some others are in a different model, and it's okay. No, you are balancing, you know, all the trade-offs. I think I'm almost right on time. So this, that's basically it. Thank you everybody for your time. Thank you for the opportunity. Don't hesitate to contact me via LinkedIn or Twitter. So that's it.
Thank you, Hugo. Great presentation after my, I'm giving you the dream of event-driven architecture with DDD and hexagonal, and this is the architecture you have to do, no matter what is the trade-off. This was actually the point, and you understood that, right? I like that it's balanced, and you actually make a decision about architecture not based on what's fancy or based on what's popular, but really based on your requirement and trade-offs, and not based on some other things. And start simple and evaluate if needed, but don't try to make it as hard as possible at the beginning just because it's cool. And I like your tree. Yeah. So thank you. So thank you, Hugo. I will catch up with you at the Q&A session. And now we're gonna welcome Habeeb Yakubu. Hello, Habeeb.
Hello, can you hear me?
Yeah, we can hear you fine.
Perfect.
How are you doing?
Fine, and you?
Yeah, I'm great. Where are you from?
Yeah, I'm from Nigeria. Currently working out from Spain, Malaga, Spain.
Yeah, that's why you said gracias.
Yeah.
Okay. Yeah, so I will leave you the floor and the stage, and you can talk about your speech, and I will take back in 30 minutes. Thank you. I will put your presentation on the stage.
All right.
You can start now.
Okay. All right. Hello, everyone. My name is Habeeb Yakubu, and I'm going to be talking about avoiding and managing technical debt for this Worldwide Software Architecture Summit by Geekle. Thank you for this wonderful opportunity, because obviously it's not really about my speech. It's actually the opportunity to be able to listen to more experienced architects and engineers, getting their perspectives. And I believe all of this pool of information in a single spot is really what is going to help the community and help people develop better solutions, right? So I'm just going to say a little about me. So before we get to see what exactly are we talking about today. So I'm a software engineer. I've been working mostly on Microsoft technologies for 9 years now. Yeah, and in the past, I've been working in consulting for most of these years. and using .NET, cloud development on Azure, and Dynamics 365, customer engagement, and the Power Platform. And so all of these we've been doing with clients, building solutions for different clients across multiple countries. So, and usually this a lot of issue about technical debt always comes up, and so and that's why it's quite easy for me to talk about this topic, because if I used to tell my friends that it's like all of my projects are always the messy ones. Come and clear the mess. Come and clear someone's mess. Come and do this. Oh, there's an issue somewhere. They've got a previous software vendor, and all of the users are complaining that they can't use the system. Okay, now the task is not to build anything new, but to stabilize the system. That's just the task. So, and be like, every engineer wants to work on greenfield projects. Everyone likes to work on projects that are extremely new. So you're able to build things from scratch, bring in your creativity. But in some cases where you just need to, the task that you need to deliver is actually to make things work, or to make things work faster, to be able to deliver value for the business, to derive value from their financial investment from their technology investment, right? So, and sometimes it's really could be awkward when you're in this situation, because you are like the Superman and you are actually trusted to deliver, right? To take them out of their problems. But yeah, that's the fun, and all of this is what has shaped my experience in the industry, and being able to share my experience about this topic. And I also worked at Kuda Bank, so usually there is the usual workplace consulting on side, and so at some point in time, I took a break to work with a very beautiful idea, which was about digital banking, disrupting digital banking, the way of banking in Africa, and now extended to a lot of other places across the world. And I joined at the early stage. And so why this is important to me in this particular speech is because at that time, there's a lot of uncertainties, and there's a lot of most likelihood, the probability to actually commit a lot of technical debt was high, because it was a startup. We are less resources. We are working in an agile manner. Things need to be delivered on time. We needed to produce an MVP. We needed to do a lot of things. So, and so that experience also is also what forms some of my thoughts and experience about what technical debt is and how to respond to it. And I also architected a payment solution, because I'm not really experienced in architecting that much, like compared to the other speakers that I've spoken. But I was opportuned to architect a payment solution, and that also was a very, very big opportunity for me to put a lot of things in practice, to see things offhand, and going from a senior developer to an architect was like really my first opportunity to actually do that, to be in that role. And yeah, so this speech is actually targeted at people who are also into becoming an architect, right? And trying to see, okay, what was involved, or you're a new architect in your role, and you like, okay, now you have a lot of responsibilities. All of the design questions that you used to ask your team leads before, now you need to be the ones to make those design decisions, right? You need to, the business users need to come to you, or you need to meet with them to decide on when and what needs to be developed, right? So all of these decisions are very key decisions that even Hugo has mentioned in his speech, in terms of trade-offs. So you find that all of the topics in this summit are quite related. You need all of this experience to be able to make decision in the order, okay? And same thing applies to technical debt. It's not a new technology. It's not something, it's not innovative. It's not something like, it's not rocket science, right? So it's just something that it's related to what all other speakers have been saying. So, and because all of what the speakers have been saying is being able to develop scalable and efficient software. Okay, and that is the idea of managing technical debt also, because in the process of developing that, you need to, at some point in time, you need to make a trade-off. You need to make a decision between what's going to work now and without giving us problems in the future. So yeah, so that's basically how my experience is related to what to this speech, to the topic of this presentation. And yeah, I also need to say, very important, that I currently work at Avanade, Spain, as a technical consultant, same Power Apps, .NET, Azure, and Dynamics 365 customer engagement. Really, really beautiful team here at Avanade. Okay, so first off, I just want to say that mistakes are proof that you're trying. So you're building software for the first time as an architect, and you'll be like, God, you so nervous. You're so thinking of, you don't want to make any mistake. You're so scared of being responsible for any flop in the system, any issue. You don't want to be the one behind any mess. But I think this is just to remind you, to tell you that you need to build something in the first place. You need to start. You need to be able to attempt something, and evidence. Mistakes are actually evidence and proof that you've actually attempted to do something. So there's a mindset thing and that's what I'm trying to bring out in the speech, that it's actually a mindset thing. It's more of a mindset thing. Okay, and that's why we are actually doing and that's why we this quote is the first thing that I brought up to the screen, that okay, let's actually fix the thing of people getting scared of making mistakes, of writing a shitty architecture and being blamed for it in the future. So all of these things should be avoided. So you need to put your mind at rest. So technical debt is so the word, obviously, if you check Google, it's on the internet. It was first used by Ward Cunningham, in the early 90s, and this guy also happens to be the creator of Wikipedia also. So, and he said he described the technical debt as an implied cost of future reworking required when choosing an easy but limited solution instead of a better approach that could take more time. Okay. So, and and obviously also analogous to monetary debt. If technical debt is not repaid, it can accumulate interest, making it harder to implement changes, right? So these are internet definitions. These are generalistic definitions, no context, just saying technical debt, generally what it means, whether in software, whether in business, whether in finance or anything. This is general context. This is the general definition of technical debt, which is okay. It is fine because the person that coined the word has something in mind before mentioning the word, the phrase technical debt, right? But in this presentation, I'm going to be relating this with my own experience and what I believe to be what technical debt and its solution. Okay, and we're going to look at what it is and the context, and also what to keep in mind to manage it. Right. So as you can see, I did not say, you don't find anywhere where I say, oh, you can avoid technical debt. There's nothing like that here, even though the topic says that you can avoid. But so it's so by the end of this session, we should be able to say, okay, is it possible to avoid, and is it even possible to do away with technical debt in the first place? So in the best metaphor I normally use to explain to people when it comes to technical debt is, think of you getting to a kitchen and you do not clean your kitchen after cooking. For example, you finish cooking and you do not clean your kitchen. Okay, so the first meal you're going to cook is going to be much quicker if you don't clean up. But every consecutive meal you cook gets progressively harder to prepare. So it's not just going to be harder in a linear form. It's going to be complex. It's going to be exponentially getting harder more. So the first meal is the fastest. It's going to cook. You're going to cook the first meal. If you're going to do some sandwich without cleaning your ovens, cleaning your items or utensils, it's going to be fine because you're going to get your sandwich in probably 30 seconds. Okay, because everything is there for you. You ain't even clean anything. You just go there and put stuff. But the idea is, after you finish that, you're supposed to clean those things up, okay, and put it then for the next person to come. But what happens is that you find people coming and dumping more plates, more items on the same inside the kitchen. So at the end of the day, you see things exponentially increasing. Okay, and if you calculate the cost, you would see that if you had X time more, by the next time you're going to have X times 2. By the next time you're going to have X times 2 times 2. So it gets increasingly, progressively harder to prepare meals. And this is the same thing that happens in software. So the moment you do something now, you are building a solution and you just say, oh, this is the cheapest way. This is the easiest way for you to go. I don't want to take time to do the hard work because it's going to take time due to some issues which we are going to look at later on. Say, it's too much. I don't want to do something. I don't want to take the pain to write best practice or best fit. That can wait. I can do that later. Yes, you can do it later, but what happens when you have more requirements, more users, and things get really, really bigger than you thought, which usually is expected in software, right? So, and when these things change, so is your software able to maintain the same? Is it able to respond to these changes? No, but you need to start going back to clean up your mess. You need to go back to do reworking of code every time. And so that's like the best way to see technical debt, like someone who's in the kitchen and does not clean the plates after cooking. So the first meal is going to be fast, but subsequent meal is going to get even harder to prepare. So some of the problems that we have, and so when you look at this screen, you see problems of unaccumulated technical debt. So I put the accumulated very small because I don't actually believe that technical debts are bad, all of them. So I don't believe in the problems of technical debts that, technical debt is bad. It is bad, but not all technical debts are bad. So that's why I say problems of accumulated technical debt. Okay, so it gets only worse when it's begin to accumulate, just like your debt in your normal economy, for example. In the normal financial system, and you have debt which you take from the bank. In the first place, if you use your debt correctly, if you use it positively, for example, to buy assets that can generate money for you later on, and you pay the debt, that's not an issue. As a matter of fact, you even get higher credit score to be able to even get more debt. Okay, but if you use your debt and you buy liabilities, you buy stuff that is not useful, and at the end of the day, you take more debt, and you're going to run into problems. Okay, you're going to run into problems, and you're going to probably be chased about by police. Okay, and especially if you take the loan from loan sharks, you are in soup. Okay, so that is the idea of technical debt. So not all debts are bad, but however, let's look at when these data are accumulated, what is going to be the impact on our system. So unmanaged debt gets worse. It has multiplier effect. One debt today can cost you millions tomorrow. Like a loan, late repayment of technical debt costs you even more. So when you don't manage them correctly, when you don't repay those debts because it's not documented anywhere, nobody knows, you're enjoying the software goes live, investors are happy, the business is okay, you've been given an award, it's gone live. I'm sure most of us on this platform would have seen a lot of times when you complete project within weeks or months, you meet deadline, everybody's happy, you have a party and all, but after the project, you keep maintaining that project even till forever without even saying, okay, this thing is not even usable. It's not usable, and you must have done the celebration to say, the project has gone live, our product is in market, but is it really in the market? Are people using it? No, there's one issue or the other. Things are not even working, no report being generated, things are just there. It's until probably years later you need to rework. You start reworking. And when you rework, what happens? You lose confidence of clients. When you rework too much, what happens? You take too much time. At the end of the day, you lose money by not meeting contract agreement based on the SLA that have been agreed upon. So it's either you become frustrated, because this is a personal experience, and a lot of people can relate to this. Engineers are frustrated. People that come after the implementation, that will be met with what's it called, with bad code, bad design, and everything. They will just get frustrated and start blaming the previous engineers. They are the issue. Okay, but in this presentation, I am acknowledging the fact that yes, the engineers can be the issue, which is valid. We can have bad code problem, but however, I am saying it is not, technical debt does not equal bad code, which is usually the popular thing out there. When you say technical debt, most people believe is bad engineering, bad coding, but it's not like that. So I'm going to share why I think it's not that way with you. So now the question is, can we really avoid technical debt? Can we let's take a look at it now logically. So can we really avoid technical debt? Is it possible to avoid it? That's a question we need to answer in the first place. Can we do away with technical debt? So the first time we build a system, the first time we got it right, no issues, nothing to go back to. The software is working perfectly. So, about layman's law of software evolution has a clue to this question. It says a system must be continually adapted, else it becomes progressively less satisfactory. What does that mean? A system must be continually adapted, or it becomes progressively less satisfactory. So you need to do things. You have to maintain a system. You have to upgrade it. There's framework issue. Your framework might get expired, outdated, out of support. There are new features, new versions of libraries. There are new regulatory requirements in the industry. If you are working in fintech, for example, say, okay, don't give us the report in Excel anymore. Give us in PDF. Okay, so systems must adapt to the changing requirements. Okay, now that is one. That is one, right? Now, on the other hand, you also say that as a system evolves, its complexity increases unless work is done to maintain or reduce it. Like, so where do we go? You say I should do this, and you say if I do this, I will do. So what's the issue? So you say the system cannot be left alone. You say a system must be continually adapted, or else it becomes less satisfactory. Now you are saying also, if I'm evolving the system, I have to also make sure that I manage the complexity, and it's just the fact. Okay, so and what kind of problem do we have there? We have what we call things like every change destabilizes the system further. It's most likely there might be issue that those are possible problems. People will be scared to add new features. You're scared to add new features to the solution because now that we want to add new thing, we don't know what's going to happen. Let's just leave it that way. Let's don't add anything. Let's go and integrate with another system. Okay. So now, and that's the problem that technical debt causes. So when you have technical debt, you will have issues with the second side of things, which is as complexity increases, unless work is done to maintain or reduce it, the complexity will be increasing. Okay, so because if the system is evolving, the complexity will be increasing, unless work is done to maintain or reduce it. Okay, so that's the point that I want to establish. So what I want to establish here is that this is actually a normal problem, is a normal thing for you to face during your project presentation. Okay, so it's not something that has to do with what's it called, maybe something not done right or anything, but it's just normal. So this is another quote which I also put here. So what is the cost of technical debt? The cost of technical debt now, if you've seen the last slide where I was talking about this happens, this could happen, which is you can have people getting scared of changing code, you can have code breaks, you can have a company not responding to the what's it called, to the company not responding to the changing market, to the changing requirements because of technical debt. So what exactly causes technical debt? So software is never really finished. It is built in evolution process and it's also maintained. So that's something that we need to also take very important. Software, you don't say, oh, you are done with the software. So we have this mindset that, oh, done once. No, you don't get it right once. So it's software is because there's a lot of uncertainties, even in life generally. So even in software, at the early stage, you don't get everything spelled out for you. And that is the essence of some of the pitfalls of waterfall model in those days, where you have people, the timeline, what's it called, the plan, methodology requiring you, forcing you to make sure you do all designs up front. Okay, and so now we have agile where you can be having incremental changes, you have more feedbacks, you have less iteration. So because software is never really finished, It is built on an evolution process, and it's also maintained. As a matter of fact, 80% of software building effort is actually spent on maintenance. So you can build for 6 months, say you have a software, but maintaining the software and adding features, removing features, tweaking is actually what takes more time. And that is actually the measure of your technical debt, how good your software is in the first place. Now, the usual suspect, when we look at the cause of things, the usual suspect everybody would say anywhere in the world is, we have the code is bad, it's not following best practice, we don't write tests, we don't write clean code, we've not built for observability, we're not able to detect errors before they happen, or when they happen until the users report them, we are not able to observe, we are not automating deployments, we are not carrying out quality checks, we are not ensuring. All of these things are actually valid issues which happens in code, which must be fixed also. When we are looking at the code properties of technical debt, engineers should also focus on looking for the best fit, not writing bad code, following best practices, solid. So I use the word best fit because I'm not really a fan of just following best practices rigidly, like without any, what's it called, looking at the cost benefit analysis. So that's why I say best fit. Each of the practices that you have, look at your requirement, your environment, your business organization, your model, and even the organizational hierarchy. How are the teams structured? All of these things will determine the kind of practice that you go for. Okay. And you have to do a lot of discussion with people and stuff like that. So, however, in some cases, you still have bad code. You still have bad code, maybe due to intentional technical debt might happen, which is intentionally, which people say, okay, yes, let's add code this thing, where we will come back and do the right thing. Okay, and there's unintentional. Is a rookie. He doesn't know that he needs to write an interface, and the class needs to implement that interface. Whether he just goes to write the class, and someone comes and says, "Oh, we need something again." He goes to add more tables, more columns to the method or more arguments. Another person comes, but a senior engineer could have said, write an interface and have different implementation of the interfaces of that interface. Okay. So, and that's basically things that can happen unintentionally. So those things should also be taken into consideration. And if you want to look at the measure, you need to consider the code complexity and the code change frequency and also the impact. So these are things that you need to do when you are making sure that from the code side of things, you want to avoid technical debt. So you need to make things must be loosely coupled. So changing one thing does not impact many things. Code should not be complex. And that particular bad code, what is the code change frequency? When you have bad code that is always, when you have a code block that is always changing, then you have there's an issue. There's an issue with it. Okay, which you actually need to take into consideration with and make engineering decisions on. Okay, and you have too many impact. Changing it is affecting a lot of things everywhere. So those are you have complexity, too many functions. There's no cohesion. There's no too many if-else logics everywhere. Okay, so you need to take that into consideration also. However, is code really the issue and cause of technical debt? Let's be frank and let's ask ourselves this question. Equating technical debt to bad code allows us to believe that if we write good code, we won't have technical debt. So are you saying that if you have good code, perfect code, a good engineer, and the code is okay, you have an A team, are you saying we're not going to have technical debt? No. It's not correct. So the real culprits of technical debt, who do we blame? Which component of the organizations are we going to address for us to curb technical debt? Is it the engineers? Is it the business department? Is it the investors in case of startups, or shareholders in terms of normal businesses? Is it the product department? Is it even the customers or the engineers? Okay, so when you have all of these things, you begin to ask yourself, and if you are not seeing it that way before now, this is what I encourage you to see, because everyone contributes to technical debt. The business department will tell you we have limited time to go to the market. Okay, that because they're on the business side and it is valid. The customer say just put a large button here like it was in the old system. So you're implementing a new system, and the customer says this new system is okay, but it's too complex, and the old system is not beautiful, but it's easy to use. which is also valid. But you are saying this system is better than the old system. This is the new way of doing things. The customer saying, no, I like the old way. Just put a button here for me to click and export to Excel. Right? So anyone who is just like, oh, okay, I want to do the customer this thing, then you need to go back and start putting things just the way is going to mess up everywhere. So for engineers possibilities maybe this is the best way I can do it. That is, for example, knowledge gap. He doesn't know that you can actually write interfaces. He doesn't know that you can use specific libraries to do your background job. Doesn't know that you're able to use specific search term in Google to get a particular solution, and that is those are also possibilities that can make people fall into technical debt. So, and also this works for now for even guys that are very good that know what they are doing. So it works for now. Let me use it that way. It's going to, because I'm under pressure, I need to do it this way. And there's also, I forgot an edge case. So unit testing was not done properly. The testing phase was not done properly. An edge case was missed. Probably you might say this is not an engineer issue, maybe a QA issue. But yeah, but you already understand what I'm talking about. So it might be a QA personnel and needs to do that. But the point is, missing an edge case will also lead to that and might be costly too. And product department can say, oh, they need to reduce the steps to log in because they are looking at other apps. So you have product people telling engineers that, oh, yeah, it works, it's okay, but is there a way we can allow people not to put their password and let up just use their username to work to log in? And the engineers thinks of a lot of things. This is going to add more complexity to the system. So those things, it can also lead to technical debt. There are a lot of investors too. The seed round. So you have seed rounds. You have people saying, oh, we need the MVPs, and so all of these things can also be factors that can lead to technical debt. So who is affected? Everyone is affected. The business department is affected after technical debt. Customers will see bugs, poor UX. The engineers will also say, oh, every change is destabilizing the system further. They are scared to add new features. Engineers are frustrated. This is like the most painful thing. New engineers are frustrated to maintain the code because there's bad code everywhere. The things are not working. The organization is expecting a lot from the new people and all. The product department is also unable to meet their deadlines. They are unable to also put in more creativity because the system is already locked in a certain way. And so investors are also potential loss, loses confidence and stuff like that. So, but however, this is my proposal. How do we manage this issue? What is the goal? The goal of managing technical debt should actually be that, okay, we are not saying there's not going to be any technical debt, but however, let us do less of addressing poorly written legacy code. So poorly written legacy code should be reduced in the first instance. And any changes that we want to do on our system should be more of evolving the solution as a problem is better understood because things are changing, regulatory requirements will change, problem domains will change, the customers themselves change, customer behavior change. So if these things come on board, we can say, okay, yes, we need to change them, okay? And those ones will be justified. So what we've done before might not actually be really costly in terms of the debt because now we have actual reasons to actually change those things. All right. So some of the ways that we can also manage this is to explore an approach of a creative collaboration of domain practitioners and software practitioners. So at the very early stage, we employ everyone to work together, all the parties, the business domain, the business people and the domain professionals for each of these domains, and the engineers themselves. They need to look at the cost benefit analysis of each debt they are trying to incur. You can incur debt, but it has to be documented. And two things need to be put in debt analysis. You need to look at the operational impact, and you need to look at the evolution impact or future impact. So current impact is what a lot of people see, okay? But the future impact, we don't look at it. I had reasons to analyze the system recently to do an audit analysis, and it was almost over 20 pages of issues here and there. The system is working fine, but I see a lot of future impact. It's working okay. There's no operational impact, but maintenance impact would come up at some point. I also encourage people to also think long term and also know that not all debts are bad. And the fact that people should know that they will spend time maintaining code, which is normal. Okay, but what matters is what is the frequency of maintenance. And that is how you measure it. You measure by considering the time spent maintaining the existing code. Okay, so and that's where the issue is. So if there's an issue even in the first place that will make the maintenance to be too much, then that's what you need to discuss with all stakeholders, right? And you also prioritize your debt based on urgency and utility. I think time is really against me right now. So thank you. I'm just going to stop here and probably take this conversation.
Habeeb, yeah, you just got a bit out
Sorry.
of the limit. But it's okay. Maybe if you have something to add later on the Q&A, maybe we can ask you some questions. If you
Okay.
have some adds, no problem. It's just to let the next speaker talk. Sorry about that.
That's okay.
Thank you for the speech.
Thank you.
So now it's a recording from Edward Coderman, CTO at Mythic Development, and he's going to talk about the fallacy of best practices, why following them can lead to failure, and it's a good talk about talking after technical debt and pitfalls and trade-offs. So I will add it to the.
Howdy. I'm Edward Coderman, and I'm here to talk to you about best practices. Well, more specifically about when not to use them. Today we're going to talk about some examples from my career, and then we're going to go over the big picture, and along the way we're going to do some takeaways, hopefully that you can use in your day-to-day. So let's start at the beginning of my career. When I started as an enterprise programmer, I'd already been coding for a long time. But that was my first time at a real shop with other developers on a team. And it was a C# shop, they declared. And I'm a big rule follower. It's what makes me a good developer. And so I started learning C#. I didn't know C#, but I started learning C#. And along the way, I'm learning all kinds of stuff because it's a big shop and I'm learning things that I didn't do in my personal career. So I was learning about dependency injection and test-driven development and all the things you do in a real enterprise sort of situation. And so I'm drinking from the fire hose, so to speak. And about a month in, one of the higher-ups at the company stops by my desk. Now, this guy, he was high in the company. He was like best friends with the president. He says to me, I need you to create a bunch of shared folders on a shared drive. And I was like, that's kind of a weird request, but okay. He says, I'm going to send you an Excel file with a bunch of folders, and I need you to put them on a shared drive. And I said, well, how many folders do you need me to create on a shared drive? About 500. Okay, this is not the kind of thing you can just do by hand in a few minutes. So I started thinking about what it would take to do, and due to C#, I was like, okay, well, there's file management, and I don't really know about how to handle the operating system files in C#. And well, this is a shared drive, so it's probably a little more complicated than just managing the files directly on my computer. So I want to learn that piece. And then I was like, okay, well, there's reading from Excel, and there's the whole Office.NET suite complications that are involved there. So that's going to take me a little while to figure out. And then I was like, and then should I read it from the email directly? I don't really know how to do that, but I probably should figure out how to do that in case he sends me another email so I can just automatically process it. And I was like, that's a lot of stuff, but I was optimistic, probably too much so in my early career. So I said, I don't know, 3 or 4 hours, I can probably figure that out. He kind of frowned at me and walked away. And I thought that was a little excessive. I thought I was being generous. So sure enough, a few minutes later, I still got the email in my inbox, though, with the Excel file. And it looked a little something like this. Now, obviously, it was a lot bigger, a lot more companies, but it was a bunch of company names, and he needed them created as folders on a shared drive, just like he said. Pretty simple. So I was about half an hour pecking away at Visual Studio when my manager came up, the software development manager at the company, came up to me and asked me about the project. And I explained to him what had happened and sort of the problems I was having along the way and the challenges I faced with the learning curve involved and the reason it was going to take me 3 or 4 hours. And he gave me kind of the same frowny look. And he said, come over to me, and brought me over to his desk. And he cracked open the file just as I had. And he said, all you have to do is this. And he clicked on it, inserted a column here, Let's insert a second column right before that. And he said, oop, and then he went. And with Excel, there's this wonderful feature. You can just double click here and double click here. And then we can save as. And we just go down here and select CSV. And I think he had it tab delimited, but I'm going to use a pipe here. Not a big deal. And now we can open it up in our text editor, which is what he did. Ooh, I screwed up. Did I miss it? Hey, we scrolled down. That's fine. Let's save it. And there we go. So now we can easily replace. And you know what? That's not quite right. So we'll just do this. And we're done. We copy this, and that's what he did. He copied that and he pasted it into a terminal. And half a second later, he had 500 folders created on the shared drive. It was about 2 minutes with explanation to me of how to do it. So I took that and I went back to my computer and I played with the little script and tried it myself and managed to do it a couple times, delete the follow folders, recreate them 2 or 3 times before I sent an email off to the higher up and let them know that it was done. So was I wrong there? I mean, I was trying to do what they told me to do. I was trying to use C# for everything. Was my manager wrong there? I mean, he wasn't using C# like he said he was, but he also got it done so much faster. Was the higher up wrong to give such a weirdly non-development task to a developer? I don't think anybody was wrong. That's kind of the point, right? Is it's not about the code. It's not about C#. That was the general rule there, but it's not about the rule. We're tasked with just getting the job done. We're there to solve the problem. That's why they give us admin access. And that's a shout out to those of you who don't have admin access. I'm very sorry for you. But there's a reason that your job is problem solving. It's not about lines of code. And that's a shout out to those of you who are being judged on how many lines of code you write. I'm very sorry. Write more comments. It's not even about software development. It's about problem solving. Our task as developers is to solve the problem. Our managers, like in my example, often were developers and know what they're doing, but they don't have to be. Their job is to tell us, this is the problem I need you to solve, go solve it. Especially when our role is architect. At least if with a developer, you have the excuse, when I was new, I'm trying to do things the way I'm told. But the architect's job is to tell them, you're the planner. Our job is to plan for every eventuality, or if we failed. Wait, that's not right. Our job is to plan for every eventuality the client comes up with, or we failed, which is somehow harder. Okay, so we can't plan for every eventuality the client comes up with. But that's kind of why companies have converted from waterfall to agile, right? Because now when the company changes their mind in 2 weeks, we've caught that and captured that change and managed to make it earlier rather than later. And that's our job, to plan for that and handle that. So if the client suddenly says, well, Agile's not early enough for me, I need to meet with you every week. Is that wrong? Well, to some extent, your goal with Agile is to ensure that we get some balance there, right? Waterfall was complete focus for developers. And if we went the other way, there'd be constant meetings and the developers would never have any time to focus. But if your UX team just made some major changes to the way things are going to work in the application, maybe you should just set up a meeting with the client. There's no reason to wait till the sprint end meeting to explain to them that, oh, yeah, by the way, nothing works the way it used to. Nothing here is set in stone. We're the writers of that stone. We're the architects. Everything's optional. Nothing is dangerous. despite what you may have heard about singletons. At Apple, they had a slogan. If you went and applied for a job there back in the 90s, I guess, their slogan was "Think Different." Does that sound like we need you to follow every best practice every time? No, it sounds like be creative, come up with a different solution. Which brings me to the next point about best practices, is sometimes they're not really best. And by that I mean, you need to stop and think about it. Our job as architects is to decide what is worth doing. It's about trade-offs, right? You sometimes are trading off speed in network for less hard drive space, or you're trading off more memory for less servers. There's various and sundry different trade-offs. That's what we're doing. The best practice idea is here's an optimization in this specific scenario of a trade-off, a perfect optimal trade-off in this specific scenario. But we're not always using those correctly. We're applying them in the wrong cases. And sometimes we're just completely implementing them incorrectly. So be wary that it's actually the best practice in that scenario. A great example that's very much in the news right now is AWS. Amazon have found out that the founders of Lambda found out that serverless is crap for them. They're too big. The idea of having a bunch of little serverless microservices all over the place is not the optimal way. It costs them millions of dollars more a month to run that than it does to just have a giant monolith. And so that's what they did. Was that wrong of them? I think they know what they're doing, don't you? But that's what I'm talking about here. So let's look at another example. So today, now we're going to look at some Python, and then we'll do some JavaScript, and we'll talk about Java and somewhere in there, and then we'll get to some C# examples. This is a pretty basic Python example of connecting to a database. We're doing things fairly Pythonic. We're using some try catch here so that we nicely close our database connection. We have our environment variables getting set. And now I wouldn't worry about these being nullable. So we didn't, because you don't want to try and connect to the database if these aren't there. So we're going to leave these. It's okay that they show up null. We want an error to happen if our database connection is not configured correctly, right? So we're a Python guy, we're architecting this Python app, and we're like, you know what? Our developers need to be able to run it on their machine intelligently. So we should move these environment variables into a .env file. That way we can set them up and they can point it to localhost, and then on the server, we can swap it out for production code that points to the actual database in RDS or whatever it is. Okay, that sounds nice and clean. So we'll do that. And so you set that up, and then you go, all right, now it's time to hook that into the main application file, and we import the database. And oh yeah, we need to import this load.env stuff now for loading the environment variables. And let's go ahead and create another nice clean class. We'll set up our database connection, and we'll set up a main function that loads the environment. And there we do stuff. And then we'll run that only when the app runs. So we go to run this file, and I don't think I have the, I don't think I have it here, but this will throw an exception. And the reason this throws an exception is because of how imports work, right? We import the database py file, and that's going to automatically run all of the code in here. And there's not really any code getting run in here, so that's okay, right? Well, we were Pythonic, and so we use data classes. And data classes creates this instance it can copy of this database connection class. And in order to do that, it has to load this environment variable, and that's where we throw our exception. So the entire app doesn't work. What do we do? Well, we could just do this. We don't really need the class anyway. It was fancy syntactic sugar. we could just run our main function like that, and we can load our .env and then import the database and then create the database connection, and that'll work. But I imported the database down here. It's fine, guys. This is probably a 30-line file doing a bunch of imports, and that's it, because the work actually happens somewhere else in the code. The point is that your developers are going to have less cyclomatic complexity looking at this. And it works. So did we break best practices, or did we just do things differently because it was optimal for our scenario where we needed a .env file and a database connection class? Let's move and look at dependency injection, one of my favorite tools in the world for testing. Now, dependency injection allows us to test cleanly without connecting up 50 different dependencies, so we can write a test that runs in 1/10 of a second instead of a test that runs in 10 minutes, which is important because if your tests take too long to run, then your developers aren't going to run them. So what's the point of dependency injection outside of testing? Well, it's supposed to allow you to swap in dependencies at runtime. And I can't think of a whole lot of scenarios where I actually need to swap in dependencies at runtime. But there are some out there, and if you're running into that scenario, then maybe you can benefit from inversion of control. But most of the time, it's overkill or automatically implemented on your project by some tool called AutoWire, which doesn't allow for you to swap it out in the constructor, thus defeating the purpose of the dependency injection in terms of testing. So be wary. Anyway, this is an example of some JavaScript code. We have an HTTP client, does something really simple, just runs fetch, converts it to JSON, and returns the actual data from the HTTP service. This is existing code in your code base in this example. And we're going to look at some more existing code in your code base in this user service. And it has a get users call, and it pulls that HTTP client and calls get. Pretty simple. And because this is existing code in your user base, it's exported, and that means that other files throughout your code base depend on it. But we need to test this. And so we want dependency injection to swap out this HTTP client. And so we create this dependency injection version of the user service. And it exports a class instead. And that allows us to pass in the HTTP client. We can probably get rid of that, and then we're good to go. We're able to then call just get as long as the HTTP client implements get. But if this is in use in 30 different places in your code base, when you implement this, you have to change that line of code in 30 different places in your code base. And so your merge request just got a whole lot bigger. Why didn't you just do this? Look how different that is. We added an HTTP client parameter to the function that already exists. And we put an automatic value to it of the old HTTP client, so all the existing lines of code will run as is and fill in as is. But now when we run a test, we can specify the HTTP client as a mock, and it'll work. This is technically dependency injection, right? I'm injecting the dependency here in the parameter. But everybody assumes this is what dependency injection looks like because they're used to it. It's best practice. JavaScript's a functional language. I don't even think ECMA meant to implement classes, except they had to, because developers didn't know what they were doing with functional languages. I'm kidding, but only a little. AutoWire is another example I talked about, right? AutoWire drives me insane because it does stuff like this for your dependencies and gives you no constructor that you can swap out dependencies, so you can't write clean tests. I'm going to do one more example here. Back when I was working at NASA, I drew the short straw. I got to stay late to do a release of a brand new application to the internal infrastructure. That's not a new version. That's a brand new application from scratch. And so at NASA, we had a tool for releases. So I had to build the application in the tool, and the tool gave the DevOps person like a wizard to step through so they could actually plug in all the values that were needed. And so I, using best practices at NASA, compiled it for the tool. And this was C#. So we had an XML configuration file. And in that XML configuration file, we had all the values that were being built by this tool. So the tool would fill in the values in the configuration and then deploy it. The DevOps person could deploy it easier. So I packaged this up, sent it off to the DevOps guy after hours at work. I'm frantically clicking the refresh button, and the application page turns into a 500 error. I get a phone call from the DevOps guy, and he has no idea what's going on, and neither do I. So he enables long error messages, and we look at the error message, and it's the configuration file that he built. That doesn't make any sense. So then he showed me his password. That was best practices with all the fancy characters, the special characters you're supposed to use in a best practices password. Now, don't get me wrong. The tooling we were using for builds, it tried to manage this. It tried to handle special characters, but for some reason, this one just managed to get through. I don't remember what had happened exactly. Maybe it was like a backslash and a caret, but it was really awkward. And so somehow the database password got stuck in like this, and it was completely unable to function. The application would not run. Now I can see you architect brains thinking, you're like, gosh, now we need to go and re-implement an entire deployment tool. It's going to take a month. We're going to have to sidetrack all of our projects. This tool is crucial. It's used for every deployment. No, you know what we did? We changed the password. He wrote a different password. And we went home. The application worked. For all the effort we're doing as architects, sometimes that's the solution. Meta used to be called Facebook, right? And their slogan was move fast and break stuff. That sound like somebody who's stopping to think about best practices? No. But the key to those slogans that I'm mentioning is they also changed them when they were no longer relevant, which is the whole point. Patterns are guidelines. Artists don't use a ruler for everything they do. They use a ruler for when it's relevant, and then they use a different tool or their own capability and creativity. We make the rules. That's what architect is all about. We've moved to a whole different role here. We're not writing code. We're not following the rules anymore. We are the rules. Sometimes you just need an Excel export. Sometimes you just need a different password. Sometimes it's time to throw out a bad idea, like AutoWire. One of the most common statements in programming, I think the first thing I learned, the first acronym I learned in programming was don't repeat yourself. And in the case of don't repeat yourself, we're talking about one of the most important best practices in programming. Every time we repeat code, we have to maintain that code in two different places. That's horrible. You do not want to have to maintain code in multiple different places. So don't repeat yourself is a very important best practice. But there's a very, very blatant exception to don't repeat yourself. And that's tests. Whenever you're writing tests, you should repeat yourself over and over and over again in every single test. because you don't abstract away code in tests. Then you can't read it. Then you have more things to test. You might as well write tests for your test at that point. And then future developers who come on the project can't look at the tests and figure out how things work. So for every rule, there's an exception. So you need to make the decision when it's time to make that exception. And when it's not, that's important too. So the next time some developer comes up to you and says, well, you got to do it this way because it's a best practice. I want you to sit there and look at the forest for the trees and ask yourself, is this really a best practice here in this scenario?
Somehow the video is lagging. Okay, maybe you can finish it live.
Thank you.
Okay, I will add Edward. Edward.
Yeah, all that's left was the sign off. Thank you for your time. But yeah, that was
Okay.
awesome.
Okay, sorry. I thought you had more to say, but no. Okay. But if you feel free to finish something if you didn't.
I'm good. Obviously, we're here to do the Q&A session, so I'm good for that. It did freeze for everyone. Yeah.
Yeah. Okay. So I will bring Hugo to the stream, which is here. Hello, Hugo again.
Hey, hello.
Habeeb was there, but he's not anymore. He's here. So we'll add Habeeb.
Hi, Habeeb.
You mute, Habeeb. You're mute. Yeah.
Oh, yeah.
Okay. Okay. Thank you, everyone, for the really, really interesting talks. And the block was really, I don't know how to say that, but coherent, like consistent with each. One was talking about trade-off, one was talking about technical debt, one was talking about not doing best practices. And that was quite nice to hear such a consistent kind of talk. So we have several questions from the audience. First, let's go back to Hugo. Okay, so it's a two-part questions. Hugo, how does a distributed system make the system less efficient? Which metrics are you basing the metrics on?
Yeah, well, I bet there are many of those type of questions because what I said or what I tried to explain is more the thinking process where you have to decide a trade-off between different methodologies or ways to implement something. And in this case, the only thinking to say that the only thing that the only metric, if you want, is like okay, so if I'm comparing, in this case, let's just think about the centralized architecture where you have probably one block of processing unit compared to another system that is distributed. There is an impact. No, there is an impact. There is no choice. No, there's a difference. No, and probably the difference can be mitigated or can be not necessarily so important. It depends on what you're implementing. No? But in this case, I think I just wanted to show that even these slight differences may be something important to analyze and decide. No, based on that, you're going to decide which path to take.
Okay. Yeah.
I think he's right there. By the way, I think it's brilliant to say that it's less efficient because there's lots of scenarios where distributed system causes all kinds of problems. Like, if you're transmitting gigabytes of data around in a distributed system, that's a mess.
Yeah, Yeah,
That's
that's not the only case, but yeah, of course, that's what he mentioned about trade-offs. You need to have not a good reason, but you need to have a reason to make a choice, or at least metrics the trade-offs of doing this choice and have arguments about why you're doing them, not because it's fancy or cool. Like
yeah. Example, microservice. Everyone moving to microservice. Just like microservice is the coolest thing in town now.
Yeah.
Yeah, my previous talk just before Hugo was about DDD, EDA, and microservices, and I just and that was good because it's a good reminder of this is not a magic pill. This is not for everything. This is not going to work everywhere. This is if you need something, there you have one solution, but there's a multitude of choices. There's no best architecture, like there's no best practices.
Yeah, fact. That's true.
I will don't hesitate to follow up on question I'm asking to anyone. Just part two of the question for you, Hugo. If you have a strong and efficient network, wouldn't the factor of system hops be negligible?
Exactly. That's correct. Yes, it can be, but that's a big assumption. If you think that you have a strong efficient network, and that's the assumption, not that you're going to write down like an architect and say, yes, this will never fail. Perfect. No, it's based on that you're deciding, but there we know that it's not necessarily the right path. You are going to see. No, as I said, no, it's always a balance, and sometimes it's perfect. No, it's really something that you don't care about because, for example, just to be a little bit technical. No, so if I have a service that is going to get the request from the user, and then it's going to reply back right away, and everything is going to happen asynchronously, then there is no problem. You are doing the right thing. The network can even fail at some point, but you already answer and everything is under control. No, so your asynchronous process is taking care of everything.
I think you called it out during your speech too, Hugo. You basically said, you're offloading the pressure of doing well onto another team at that point. You're saying, hey, the hardware team or the ops team needs to be perfect, and so I'm just offloading the work to somebody else is all you're doing by doing that.
Yeah. But again, we all said that there is no magic bullet. There is no like the right answer. No, it really depends on the use case and how. And then probably not the use case now, but also the use cases that are going to, how everything's going to evolve. No?
Something that doesn't make sense now doesn't mean it won't make sense 2 months later or 3 months later, or years later. I mean, it's supposed. Maybe maybe the system is gonna evolve. Maybe it's prepared for. Maybe it's not. But things change. Things break.
Sometimes, yeah.
Sometimes. Okay, I have a question to Habeeb, for Habeeb. How do you sell, with hair quotes, a technical debt to business people if the functionality will not change at the end? I'm not. Yeah, it's kind of tricky. How do you sell that?
Oh, nice. Well, okay. So the point is when you have so technical debt. So I just want to let be clear on the terms now. So to sell technical debt, what does that mean? Does it mean that you want them to accept that you should do this quick fix?
I think that's what it means. I think that's right.
Okay, if functionality will not change at the end. Yeah, obviously. So if you look at when I was so my own personal thing, what I was encouraging this in my presentation was that there needs to be a collaboration. So everyone is actually driving towards one goal. So it's not like a business and technology versus thing. So everyone wants to build a stable software that is efficient. So if the goal is the same, so the question of selling would not even arise in the first place. That's my thought. And you get so because as an architect in this position, you should be able to. You're more or less like more a technical person, but also a business person. So as an intermediary between these two people, so the question is going to fall back to you to say, okay, you're not just a developer. You should also know the business. What's it called? The business impact of. So all of the things I mentioned in the presentation has to be done by the architect actually, because it's not a developer. So a developer can be the one to say, oh, can you allow me to add code this thing and stuff? But as an architect, you are more or less a developer that is not, or a business person that is in the technical side. So more or less. So this kind of stuff, that's where the huge responsibility on you to do all of those analysis, the operational impact and the future impact of the evolution impact of what you're trying to do. So it's not for the business to answer.
Yeah, I think you answered pretty well there. Question for Edward. Do you think that establishing organization-wide best practices, best practice guidelines for the developers is something beneficial, or is it just narrowing the vision and leads to bad decisions? Basically, what?
So there's an example of this that was done really, really well. Twitter established a rule about CSS that they would write as few classes as possible as an organization, and that all CSS, all style sheets throughout the organization would pull from the same list of classes that were agreed upon by everyone. And so it was a huge process to get a new CSS class implemented in the organization. But as a result, you didn't have 40 different versions of the center alignment class, right? And so it had its benefits and it had its negatives. It's a trade-off situation. But I think when we talk about the beneficiality of best practices as your organization, you want your organization to have some guidelines. You want your developers to have, guardrails to run into, but you also want to be flexible and go, this is a scenario where it doesn't apply. And you want to make sure you're hiring people who can think outside the box and go beyond that. So it's a multi-layered approach. You don't just handle this at the architect level. You don't just handle this at the HR level. You handle it all in all aspects of the organization.
Yeah, what touched me when you talked about this is that pretty much you need, especially for junior developers or people entering an organization, you need blueprints, you need some kind of guidance, some rules to follow. So for you, the organization have to also mention that, okay, it's okay if you break those rules or go with your gut sometimes and don't follow them. How would you put that?
Well, some rules are hard and fast, like we're not going to break the law here. That's not a flexible rule, right? But some rules are more flexible, and you just explain as such. And context matters, right? It matters a whole lot more if I'm working on a distributed system, what my network looks like, than if I'm working on something that's on a backroom server that only gets connected to via this one cable, right? It matters. So the context matters too. And I think that's sort of the role of the architect, is to say, okay, this is where we're going to not follow organizational guidelines, and here's why. And you may have to explain yourself to higher ups, or you may not, and that depends on how big of a guideline you're breaking, I think.
Yeah. And also I think some people who lacks creativity, because some people are less than others, might be more at advantage in your position than what you're saying, or some people who likes actually having guidelines and stuff.
Well, I'm a rule follower. I like guidelines, and it took me, till I was in my 30s before I realized that there were contexts around rules, and that's in real life more than just development too. And so I think that explaining things to your people and trusting them and hiring good people that you can trust is a big part of it.
Yeah, that's what I was. Okay, let's go back to Hugo. Again, a two-part question. Hugo, on your diagram, under the low latency, you have microservices, while usually microservices are considered, part two coming, as high scalable solution with average response time due to inter-service communication. Can you explain it, please? Oh, we cannot hear you. Hugo.
Yeah, now
Yes,
you can
sir.
hear me. Yeah. So maybe for some people that may sound contradictory, because under low latency, I'm saying that we have a microservice that is. What was the first part of the question? Can you go back there, please, just to be sure I'm not missing anything?
You have microservices on
Yeah,
the low line.
microservices. So it sounds depending on some of the concepts that we have about microservices, serverless, monolithic, and all those type of architectures. Low latency in this case is just meaning that the response time of whatever you are asking to that service is going to be fast enough so the end user gets the response in a way that looks or behaves fast. Sometimes if you see, I'm trying to not use some words, because when I say fast, then it means that everybody's happy, and it's not necessarily the case. Just saying that when we talk about in this case, the low latency, no matter if we have a high scalable solution and the response inter-service may be okay, the low latency now is in the periphery. So when there's an end user trying to get a result, that's what it says, and we can achieve that using microservice or using monolith. That's I don't think there is anything against that. The only thing is how that is implemented and how it's implemented in behind the scenes.
Yeah, I think this person was just thinking that this means that, so it doesn't depend on how you make it, but things can mean very different things when you implement in different ways. Okay, another question for Habeeb. Can you suggest some techniques or tools for tracking tape depths and analyzing its impact? Habeeb, sound.
Sorry, why do I always forget to unmute myself? Like I do this practically every day. This is a big part of my job every day. So I don't know. So, but yeah. And so when it comes to tools, to suggest tools is a little bit difficult. And if you look at what Edward has mentioned also, that there are really no best practices. And like I always also say, what matters is the best fit. So you look at the best fit, and so usually the concept of managing technical debt is to be able to realize one thing, to identify. The worst technical debt is the one that is unidentified. That is the worst one. That is the one that is actually going to cause issue. So the first question to ask is, how do you want to identify your technical debt? In some places, it's going to be Excel. It's enough. Create columns in Excel to actually document the operational impact, the evolution impact, and also the costs of repayment of paying that technical debt in the future. So what is the cost, as well as the dependency? So once you have these four things, in anywhere, if you like, you want to use Excel, like Edward, it's fine. If you want to use this is the simplest tool out there, right? So if you want to use Excel, you're good. If you want to use Azure DevOps, you're also good. If Jira works for you, but what matters is this information needs to be captured. You need to take a look at the operational impact, the evolution impact, the dependencies, as well as the cost of repayment. So I think that's basically the technique I use. I don't have any specific tools that I use to manage technical debt. So this is quite different from code analysis, because sometimes in your pipeline, you have places where you need to send in your code and some kind of tools checks for errors, automated code review. So this is different. But technical debt as a business digital transformation, or what am I going to call it now, as a business entity or a business concept. So not really something technical like I mentioned, coding. So it's like, okay, we are doing something now in order to gain something else. So those things need to be identified in whatever way that suits the organization or the project that you're working on. So that's basically my answer.
Yeah, this kind of not technical but business debt is high. It's high likely that any tool will be able to catch it up. But
Exactly.
I think this person was more talking about like a SAST tool, like a static analysis code tool.
Yes,
like
I think
Sonar Cube or something like this. But yeah, I understand what you're talking about is not measurable at this level. And last question, and we are good to go for Edward. Yes, you were mean to. Nice name, Coderman. Is there any future in OSGI within the modular systems context?
So I think this goes back to trade-offs, and I'm glad this one did come up and get bubbled up to be talked about, because modular systems are useful. Now, I talked about Amazon abandoning a modular system approach, but that was one example. And if you look, some of the people who talk about it are talking about how, yeah, but in my case, I have a smaller shop and I'm making so much more money and saving so much money by using using microservices, as opposed to going with a much more monolithic approach. And so I think there's a lot of trade-off choices there, and it depends on your setup, depends on your infrastructure. I mean, are you working out of your garage with a server rack in your garage, or are we talking about, some sort of data center situation, or is everything running on AWS? And those are three major different choices, and they all affect your business model a whole lot.
Yeah, I thank you, Guy. I think we can close this session. It was a pleasure to have you and chat with you. I wish I had more time to exchange. Maybe we can exchange more on LinkedIn or something like this. It would be cool. And there are other questions if you want to answer in the chat. So I will say you goodbye. And thank you for participating to the conference. If you have some more to say, please be my guest.
Okay, from me, just thank you, everybody. Thank you. It was until here we heard a lot of incredible speaks, and I was very glad to be here and share a little bit of our pains. Thank you.
Yeah.
Thank you guys for having me. I appreciate speaking on the event.
Thank you.
Thank you.
Thank you, Habeeb.
Thank you. Bye. Bye.
So now we're going to have a small break and we'll go back in 7 minutes. Goodbye. It was Gaëtan from France.
Hi, everybody. I hope that I am audible. If not, I hope somebody lets me know in the chat. So, welcome back after that quick break. My name is Stefan Berkenus, and I have the pleasure of moderating the remaining sessions that we have planned for today, including the Q&A session that will be coming up right at the end. For this first session, it is my pleasure to introduce Tanmoy Sengupta. He is a principal architect at Cognizant and has 20 years of experience across fields such as AI, machine learning, and analytics. And in his talk today, titled Machine Learning Architecture in Azure, a Case Study, Tanmoy is going to share his experience from applying machine learning within large-scale transformation projects. So with that, Tanmoy, over to you.
Thank you, Stefan. Thanks for the introduction. Glad to be here. So let me start with my tell me a little bit about my presentation. So as Stefan mentioned, it's based on my real life experience in building a large digital transformation program, working in a digital transformation program. where I had to assess the options for designing machine learning solutions in Azure and choose an appropriate solution based on the requirements. So as part of this topic, I'll cover the particular machine learning use case. What are the key considerations for building the solution? What are the different solution options that I considered, and how the options assessment was done, and based on the assessment, what was the final selected option, and what is the rationale behind selecting that, right? And finally, I'll show you a reference machine learning architecture based on this chosen option, along with some architectural considerations that you have to take care while designing the solution. Okay, so before I start with the presentation, a couple of disclaimers. So number one is this talk is primarily meant for aspiring and experienced cloud architects who are designing machine learning based solutions on Azure. So a working knowledge in Azure and a theoretical understanding or knowledge of machine learning is needed in order to gain anything substantial from this session. And this is geared towards architects, as I mentioned. It's not really towards the data scientists. So we're not really going to touch upon the data science topics as such, or will not delve into the data science aspects of the solution. And thirdly, what I'm going to present here is my personal view and not my employer's view. Okay, so having said that, let me start with my presentation. Okay, so let me start with the use case. So the use case here is for a leading transport infrastructure company, which has deployed a large number of assets or equipments across various regions in the country. And so historically, these equipments are maintained with a time-based or routine-based maintenance protocol, meaning it's more of a proactive maintenance, more of a reactive maintenance. When something goes wrong or the equipment fails, then the maintenance activities is carried on. Now, as part of this program, the enterprise was actually looking for switching to a predictive maintenance-based regime. So, basically, predictive maintenance will allow the enterprise to benefit in various aspects. For example, it will help with the preemptive corrective actions rather than we can fix those assets or equipments in a proactive manner. Number two is the safety compliance. They can adhere to the safety compliance. They can take a proactive measures to fix those assets beforehand, before they actually fail. And then it will, of course, result in increased asset life. And all of these factors essentially will help in the cost savings, eventual cost savings for the client. Okay. Now, for any machine learning solution, as you know, the heart is the data. You should have the appropriate data to build the solution. Now, for this particular organization, they had various data already in place. For example, for this all these equipments, there are some sensors which basically track or basically captures the asset condition data, and these are sent to the enterprise's data platform. So I should mention here, the enterprise had their data platform built with Azure. So essentially, they had a data lake and few other data services. So all these as condition data are stored in this data lake stored in the Azure data platform. And there are other details like the asset details and their failure history are also stored in different separate systems, on-prem systems and others. And these data are also accessible from the data platform. So this can be ingested to the data platform. So we have a huge set of historical data which will be leveraged. It can be leveraged for building the machine learning solution. Okay. So the goal was to build a machine learning based predictive analytics solution in Azure. So which will basically predict when the asset or an equipment is likely to fail. So it's essentially an anomaly detection problem. So based on the data, they will build a predictive solution, we deploy it, and then we can later predict when a particular asset is likely to fail. Okay. Now, how this program is structured. So we have two major teams. One is the R&D team. R&D team mainly comprises of data scientists. So data scientists are responsible for developing and training the machine learning models, right? All this data preparation, all this data preparation, gathering the data, and this developing the models, etc., done by this R&D team. They also have data engineers who will help with the data pipeline for all this data cleansing, data wrangling, all these activities, and then data scientists who will actually is responsible for developing the models. Secondly, they have the project team or the dev team. So they get the trained models from the R&D team, and their responsibility is to deploy the model, and then so that the consumer application, right, can call that model or invoke that model to get the predictions. Now moving to the next slide. So before building the solution, we have to have some key considerations or key factors that have to consider before coming up with a solution, right? So for our case, the key factors was number one, as I already mentioned, the data platform is built on Azure. So of course, the preferred choice of technology for building this solution was using Azure PaaS services. Number two, the expectation was that all this training model training, etc., they should be fully managed and traceable, and all this whatever models the R&D teams are creating, they should be traceable. Okay, and all the code, the resulting model, the scripts, etc., should be version controlled, and there should be automated builds and automated tests for this application of the code that is being used. Okay, so these are basically as per the Microsoft MLOps maturity model 2. So and as per this, although we have automated builds, we really do not need an automated model deployment. We can start with manual model deployment to start with, but there should be low friction model deployment. But we should gradually move to higher maturity models, which are maturity model 3 and 4. So if I can quickly show you what do you mean by the maturity models or machine learning in Microsoft. See, these are the basically MLOps maturity model from Microsoft. So it starts from maturity model 0 to 4. So the expectation is to start with maturity model 2 here, which just talks about this automated training. So training should be automated, build should be automated, whereas release should be manual but low friction. In higher maturity model, we'll have automated model deployment, full MLOps, automated operation, etc. But that is what will go gradually. That is the understanding. Now coming back to my original slide. Okay. Yeah. So third factor was this transition from R&D to production and non-production environment. That should be very easy and seamless. Okay. So R&D team will develop the model and train the model, and it is handed over to it will be deployed in the production and non-production environment. That should be done in a seamless way. And both the R&D team and project team should be using an approved suite of tools, technologies, and frameworks. The other factor was the flexibility. Okay, so this ML platform that we are building, that should be flexible enough to support supervised, unsupervised machine learning, as well as deep learning models. So and it also should support CPU-based compute for training as well as GPU-based. So the solution should, whatever machine learning platform we select, that should support all of these capabilities. And it should also support batch inferencing as well as real-time inferencing. So for this current problem statement is for batch inferencing. So whatever model we deploy, the consumer application doesn't get the data in real time, but rather in the background will pass the input data in batch, and then the model generates the prediction and stores in some storage area, and later these are consumed by the application. So currently, although this problem statement for a batch scoring purpose, but in future this ML platform, whatever you select, that should be capable enough to to support any real-time inferencing use case that comes in future. Okay, that is the flexibility aspect of it. Then we have the reusability. So whatever solution we are proposing, that should promote reusability in terms of data preparation, model training, deployment, etc. And most importantly, last but not the least one, is the solution should be cost effective. So you should be able to use that pay-as-you-go model of Azure services as much as possible. And we should be able to share the compute for multiple model training for optimized cost. So this is one of the most important factor for our solution, like it should be cost optimized. Now moving to the next slide. So for a quick refresher of Azure ML. So as you might be knowing, Azure ML is the primary machine learning service, PaaS service in Azure. So it's at the heart of it. We have the Azure ML workspace, which is basically the root level of all the Azure ML services. It stores all the artifacts generated by the Azure ML solution. It has data stores. Data stores are nothing but abstraction of the data storage. So by default, the data storage for Azure ML Workspace is the Azure storage account, like ADLS or blob storage. And then it has something called compute targets. So compute targets are essentially the compute infrastructure where the models are trained or deployed. So compute targets could be managed. Managed compute targets are in the I will show in the right hand side with compute instances or compute clusters. And we have I can have unmanaged compute targets also. So unmanaged compute targets could be you can attach a Databricks cluster, or you can have attach an Azure Kubernetes service cluster. So those are the unmanaged one. And for the managed one, compute instance is essentially basically you can assume it's a single VM, right? It's a managed VM which is used for which comes with the pre-installed all the software and packages that is required for training on model. And compute clusters is a basically set of VMs which can be scaled up and scaled out or scaled down and scaled in based on your requirements. So these are the compute infrastructure. And then we have the assets here, like which environments. Environments is where the model training is done. Experiments are basically a single run of the one training script. Then we have the Azure ML pipelines, datasets, model endpoints, etc. And you can see here, so as I said, Azure storage account is the primary storage for ML Workspace. And then we have Azure Container Registry, where the model is containerized and stored. Azure Key Vault is for storing the secrets and secrets for connecting to data lake, etc. And Azure Application Insights is for monitoring the model. Okay. Now moving to the next slide. So let's just have a quick recap of the ML lifecycle, right? So as you know, as you might be knowing, so any machine learning lifecycle starts with the data preparation stage, and then after data is prepared, it goes to the training and validation. So once the model is trained and validated, the model is deployed, right? And once the model is deployed, the prediction is done. I mean, the model is consumer application calls the model to get the prediction. And then we monitor the model for its performance, and if it requires, then we can retrain the model with new data. And that is the cycle that goes on. Now, considering this life cycle in mind, so we have a very, broadly, we can have 3 solution options for solving this problem. Okay, so in Azure, the main 2 Azure machine learning services are Azure ML, and the other one is Azure Databricks. Both have their machine learning capabilities, and so we can use that Azure ML services for this entire model lifecycle. That is option 1. So except the data preparation stage, all the stages we can manage, because Azure ML has the built-in support for this machine lifecycle management for all these rest of the steps or MLOps. Okay, so you can track the data sets, experiments, models. So, and it doesn't require any third-party and open source tool for that. So everything is built in. It has built-in support for every of the stages. So that is one option. The second option is, yes, Azure Databricks. It also, Databricks is initially a data analytics platform, but it also supports creating machine learning model and training models, etc. So it uses the Spark MLib library for model building, so which you can use, and it also supports ML lifecycle management and tracking, but it uses open source tool called MLflow for that. So using MLflow, it can do that entire MLOps or end-to-end machine learning lifecycle management. And the third option is basically a hybrid of these two. It's a combination of these two. So as I showed you in the previous diagram, so Azure Machine Learning has a compute target, and it can have unmanaged compute target, right? So you can have a Databricks cluster as a compute target. Okay, so basically your core machine learning tool is Azure ML, but your training target could be Databricks. So that is the third combination. So it's basically you are using Azure Databricks for the model training purpose, and you're using Azure ML for the deployment. Okay. And in this case, there is one caveat, because you are using Databricks. You have to use MLflow for gluing between these two components, Databricks and Azure Machine Learning. So these are the 3 options that we have in broadly for this problem. And let's see what are the different technology choices we can have for these 3 options. So if I go by the machine learning lifecycle stage, right? So for training data preparation stage, if you're using Azure Machine Learning Service, then you can do it using Data Factory pipeline. You can create a pipeline using Data Factory. You can store the data in data lake store or blob storage. And then you can do model training, retraining, and validation, etc. These stages can be done using Azure Machine Learning Studio and you can deploy the an Azure machine learning and you can train it in Azure ML compute cluster or compute instance. The deployment can be done in a compute cluster if it's a batch mode, or you can deploy it in Azure Kubernetes service. And there is one more managed service is there for Azure ML, which is called managed endpoints. So you can use the managed endpoints for deploying the model. And finally, model monitoring can be done using Azure Monitor, App Insights, etc. And you can also do a data drift monitoring using the data drift feature of Azure ML. For the second approach, where you are using Azure Databricks for the ML service management, the training data preparation stage will still use a data factory pipeline for data preparation. It can optionally use Databricks for any complex transformation. And the model training will happen in Azure Databricks. And then finally, the model deployment will also happen in Databricks, and you can do the deployment in AKS, or you can also do the deployment in MLflow model serving, which is a preview feature in MLflow. Okay, and model monitoring is again done using Azure Monitor MLflow. The third option, which is the hybrid of these two, which is very similar to the other two. Only difference is that here the model training is done using Azure Databricks, which is connected to Azure ML workspace. So that is the training is different. Then the rest of the stuff is very similar to the Azure ML, the first option. Okay, so these are the technology choices we have for each of these solution options. And now let's see for each of these options what are the pros and cons and how do they compare with each other. Okay, so this is the option assessment that I did, and these are against each of the considerations that I discussed in the previously. So the first consideration was around MLOps, that you should be able to have MLOps maturity model 2 with the ability to you progress to further maturity model, right, with the support for other model in future. So with the first option is ML service, it has built-in support without any third-party software, so you can achieve that MLOps maturity model very easily. With Azure Databricks, yes, you can achieve the MLOps maturity model, but you have to use MLflow for that. And then for the option 3 hybrid approach also, you can achieve the MLOps maturity using MLflow. Okay. The second parameter was ease of transition from R&D to production. So here with Azure ML service, it is very easy because everything is done within Azure ML. So so it is very easy to transition the model from R&D team to the project team. For Azure, if you use Azure Databricks, a bit moderate because it requires MLflow integration, etc. So the ease, it's not that easy, but it has moderate effort required. And for option 3 also, it is easy to moderate, right? Now the third parameter was around flexibility. Now for the first one, the Azure ML service, it is quite flexible in the sense it supports both CPU and GPU based compute. Like CPU based compute is mainly used for machine learning workloads, whereas GPU based compute is required for when you're doing deep learning based machine learning. It supports auto ML, automated ML. So automated ML is basically the way, you can automate the various stages in your machine learning in the sense you can automate that feature extraction process, the algorithm selection, and the hyperparameter tuning. All the process can be automated, and internally it can generate the model based on these permutation and combinations of all these algorithm, hyperparameters, etc. And it can also generate the models, and it can also give you the accuracy of the models. And based on that generated model, you can actually choose one model which has the best accuracy as per your requirement. So that support is there with AutoML. Azure ML also has a support for no code, low code experience with that Azure ML designer. So where you do not have to code anything here, you can just use and drag and drop of your workflow to create your models. Azure ML supports both single node and multi-node distributed training. So you can spin up to 100 nodes for your training purpose. So if it's a very large data set and a complex model, then you can leverage all these nodes for your training purpose. And Azure ML by default supports both the batch mode as well as real-time inference. So it's very flexible, as you can see. Now moving to Databricks, it also supports CPU and GPU based compute. It also supports auto scaling. It supports both batch and real-time inference modes. but its AutoML is there, but is in preview mode. And as a best practice, typically in Azure projects, we do not use a preview feature in production. Okay, so that was the deterrent for us. We couldn't use that AutoML feature for Databricks, and it has no built-in support for data drift monitoring. Whereas for Azure ML, as I mentioned in the last, it has a data drift support, although it is in preview, so you cannot really use it, but you can use it in future. But on Databricks, I couldn't find any support for data drift monitoring as such. And for the last option, it is a combination of these two, right? So it is very similar to option 2. It supports CPU, GPU. It supports batch and real time. It has a preview of data drift monitoring, but AutoML is in preview, and so we cannot. And there is no support for no-code and low-code here. Okay. Now, in terms of reusability aspect, reusability of your all this pipeline, etc., and code, everything is possible with all the 3 options. So no problem there. Now, the biggest factor here is the cost. Okay, so with Azure ML service, what you find out, the cost is lower than the other 2 options. In Databricks or in the hybrid option where you're using Databricks for training, I found that it is costing higher, because Databricks not only Databricks cost actually is determined on not only the compute cost but also the surcharge, the Databricks unit cost. So because of these 2 components units cost, Databricks for similar configuration, Databricks cluster incurs higher cost than an Azure ML compute target. Okay. And there are a few other aspects also here. As I mentioned, Azure ML compute cluster does have support for database monitoring, but it is preview, so it cannot be used now, but may be useful in future when you move to higher maturity model. And then Databricks does not support Azure AD based managed identity. So typically, as a best practice, one Azure service to Azure service authentication is typically done or is recommended to do using managed identity, which is not supported in Databricks yet. And for the third option, here Databricks is an unmanaged training compute resource for Azure ML, right? So, and our preference is always to use managed resources, right? So in Azure managed resources. So that way it is a bit not as per the recommendation, and there are some additional steps needed for improve the model, improve or maintain the model performance. Now, based on all this, like we have chosen the solution. For our case, the chosen solution used to use Azure ML service, because Azure ML compute cluster or managed Azure ML service, and it will have deployment target will be Azure ML compute cluster or managed batch endpoint as a deployment target. Now, what are the reasons? Number one, it is very easy to transition from R&D environment to production environment, because it is a single unified platform for training, testing, and operationalizing the model. And you can achieve the MLOps maturity quite easily with the out-of-the-box support from Azure ML, as we already discussed. This is more cost efficient, as I mentioned, compared to the other options. And also it supports managed online endpoints. So for other options, we have to, for real-time inferencing, you have to use cluster like AKS cluster or something, but with Azure ML, we can deploy the model in a managed online endpoint we just require any infrastructure management. So that way it is very, very helpful. Now quickly, I'll just show a reference architecture based on the chosen solution. So as you can see, we have various data sources, right? Data sources for could be IoT sensors or on-prem systems where we are ingesting the data. The data is collected in the Azure storage account in the raw zone. And from there, we have a data pipeline in the form of data factory, which does the data cleansing and data quality check, all the data transformation, etc. And finally, creates the training data set, test data set, and it does the feature extraction also. So this training data, test data, and the feature set are stored in this curated zone of the Azure storage account. And from there, there is a machine learning workspace for the R&D team. They take this data, training data, and use this training data for training the model in the Azure ML compute. Okay, it could be compute cluster or compute instance based on the data volume and training requirement. And once the model is developed and an appropriate model we get a model with good accuracy, that model is pushed to the model registry. See, this model registry exists in the Azure workspace for the project dev team. So there are 2 workspaces here. So push the model, the accurate or the well-tested model within the model registry of the dev team workspace. And from there, this model is finally packaged. The model, its hyperparameters, and the scoring script file, and the dependencies are all packaged together in a Docker container, in Docker image, and that image is pushed to Azure Container Registry. And from the container registry, finally, this model is deployed in the compute target. So for our case, it's a batch inferencing model. So it was deployed in a Azure ML compute cluster, but we can also deploy it in a batch endpoint for batch inferencing. Okay, so this is the deployment part. Now, once the model is deployed, the final model is invoked from another pipeline. So basically, it's another ADF pipeline is there, which is the batch inference pipeline, which takes the input data in batch, it invokes the model, it generates the prediction output, and the final prediction output is stored in another zone in the storage account, is the published zone. So this published zone of the storage account contains all the prediction output. Now, any consumer application like Power BI or some web application can query this published zone to show the prediction results. Okay. You can have some database on top of it, and develop some APIs also on top of it, so that web application can consume the API and get the prediction. So this is the overall some reference architecture based on our use case. Lastly, just quickly, just not much time left. I'll just quickly go through the architectural considerations for this solution. So number one is scalability. So the advice is to use the auto scaling option for Azure ML Compute Cluster to automatically scale out and scale down the number of nodes. It supports also, if you're using managed endpoints for deployment, then it also supports auto scaling with the help of Azure Monitor auto scaling feature. You should leverage that. For performance consideration, it supports both CPU and GPU based, but the general guidance is for non-deep learning scenarios, we should be using CPU based compute target to handle the load. But for deep learning workload, where speed is a requirement, right? So where GPUs generally provide better performance. Okay, and you can also parallelize the jobs for training jobs across various VMs for good performance. Okay. In terms of security, so Azure ML is well secured with Azure AD and role-based access control. It supports private endpoints, so that any connection, any connectivity from the Azure ML workspace to a storage account, etc., doesn't go via internet. It goes via private endpoint. It is protected with VNet, and it is protected with the DDoS protection and Azure Defender, and all the data are encrypted at rest and encrypted in transit with TLS. And then we can have NSG rules to filter in inbound and outbound traffic. In terms of manageability, so it is recommended to create a dedicated workspace for both the teams, for two teams. Another team should have their own workspace, and project team should have other separate workspace. So this will actually allow the other teams to keep their work and responsibility logically separated, and it will simplify the cost management also by team. And lastly, for cost optimization, we should configure the compute cluster to a minimum of 0 nodes, so that when it is not in use, we can scale down to 0 nodes and will not incur any cost. Typically, we'll prefer to use CPU-based compute compared to GPU-based, if possible, because CPU-based compute costs lesser. And also, you should tune the VM size based on the compute utilization, and this way you can save the cost. So yeah, these are the architectural consideration for this solution, and yeah, that's all from my side. Thank you.
Thank you, Tanmoy, for that very interesting presentation. We're only 1 minute over time as well, so I don't think it's much of a big deal. Thank you very much. Again, we will have a Q&A session, of course, at the end of these following two presentations. So with that, thank you, Tanmoy, and hopefully see you a bit later.
Thank you.
For our next speaker, I'm very excited to introduce Andres Sacco. He is a technical leader at TravelX and an experienced developer with exposure to many fields and programming languages, and has most recently, I understand, published a book about the latest version of Scala, if I'm not mistaken. Today he's here to present this talk titled "Don't Remove the API," which will zoom in on something that I, and I think also many others, find interesting. We're very good at building things, but when it comes to removing or retiring things, that is also a very hard thing to do in software, with specific focus on APIs. So I will stop talking there, and Andres, over to you.
Thanks for the presentation. Let me share my screen to present. Okay. Let's start. Don't remove the API. The main problem with this kind of subject is we build a lot of things, but at some point we need to deprecate. So first, let me introduce me. My name is Sacco. I work as developers since 2007 using different languages. Most of them are connected with the JVM. I participate as technical reviewer on some editorials. I wrote some books and courses. Some of them appear at the bottom of the presentation. And I participate as a speaker on different conferences. At the left of my presentation, you see my contact information. So if you have any doubts, any question after the QA, send me an email or contact my LinkedIn. I try to help you. So let's start with the talk. The context of the problem. So we have a big old microservices, and you want to deprecate for some reason. Performance issues, is too old, use a very strange language, and you don't want to use more. I don't know, many other reasons. So, and the main problems that you discover with these all microservices is you don't have the information about which are the consumers of these microservices. You don't have a list of all the consumers. It's difficult to maintain the old one and the new microservices in the case that you want to deprecate and create a new one that replaces the same functionality, or perhaps you have a new microservices you built a lot of many weeks or months ago, and your intention is like deprecate the old one. It's difficult to measure the impact of the changes. So, okay, if I remove or deprecate these microservices, which is the impact on my entire platform? Is affect the entire platform? It's just a small piece. Anyone use these microservices because it's so popular? I don't know. And perhaps it's the first time that your team do this kind of migration or deprecation process of some of the microservices. So why a migration could fail? Because you don't have a plan. You start to do something and say, okay, I want to do these new microservices, and you start to decide in the row. It's not like I have a set of steps, and first I need to create something after I communicate. It's like, okay, our intention is deprecate the old microservices. It's like I create the new one and I send a notification that the old one will deprecate. This is not the best idea. Bad communication with your consumer. Perhaps you don't send an email or communicate with the different consumers that these microservices have. So this could fail. Perhaps you stop or turn down the microservices, and you receive a lot of emails, a lot of chats on the Slack or Teams or any messenger about there are a lot of problems on the platform. So it's so important, the communication on this migration or deprecation process. And the last one is have a bad strategy to do the migration. You don't choose the correct tools, or you don't collect all the information. You need to analyze all the possible scenarios, not the best scenario that all the consumer, you send like an email and say, please change or not use more these microservices. You have 2 weeks, and all of the consumers do quickly. No, perhaps you have some scenarios when this not happen. So you need to consider this kind of thing in a strategy. So which is the impact of not have a plan? First, you have a high risk of failure during this migration or deprecation process. So Perhaps you not have a plan, so you start to do things, and the problems could start appear during this process. You don't have a definition of the steps. So first I will define the goal, or I send an email, or I write the documentation, or I will contact with the consumer. So if you don't have the steps, you start to do it like in an ordered way, or you don't have a path or a way to follow the steps. You don't define the responsibles, the person or the people who are responsible to check if the migration or the deprecation process is on the road. Everything is okay, something is missing. You need to define some people on your team or your company that follow this process. How you measure the advance of this process? Okay, perhaps it's some simple like I will check my New Relic or my dynamic trace and check the number of requests. You need to define who and how you will measure the advance of this deprecation process. And the last one is what you will do if something bad happens. Imagine that in the worst scenario, like my big consumer or my most important consumer of my API don't do nothing, and perhaps have the possibility to do a migration or just not use my endpoint in at least, I don't know, 2 weeks or 2 months or 2 years. You need to consider this kind of a scenario. And it's not like, oh, well, if something happened, I will see in that moment, not now. No, you need to define these kind of things after start to do the deprecation process. What imply about communication? So you not communicate to your consumers about your idea of your plan, your deadlines, what is the goal, and how you will tackle this deprecation process. So you need to do a communication with your consumers. Not define the deadlines. It's like, okay, take your time, do the migration when you have time. It's relevant for us. No, because you spend a lot of time to maintain both microservices or the old microservices. And a lot of problems appear when you need to maintain an old microservices. Not follow or not track the advance. So if I don't send an email, I don't contact you on Slack or Teams or something, perhaps you discover a lot of problems during this process and not documenting the process to do this migration. And what imply about the strategy? Well, first one, set unrealistic expectation to do the migration. Perhaps is, okay, all my consumers, I have 1,000 API that consume my API. So in 1 week, all do the migration. No, this is not real. This is not possible. So you need to set this kind of thing, the deadline of the migration. Perhaps you choose a bad approach to do the migration. Choose a wrong stack of technology. So it's important that when you start to create the new microservices, in the case that you want to replace it, is check all these things and define a way to check if the new microservices, which could be the same endpoints or could be not, this is possible because imagine that you have a big microservices and you want to split into different microservices, and you need to check or define a way to check if everything continue working or not. So for that reason, could be a bad strategy. And what you do with the request after the deprecation. Perhaps you don't do nothing and the request continues and try to access to the information to a microservices that not exist too much, disappear. So how to be success in a migration? This process takes 5 steps. The first one and the most relevant is define the plan to do the migration. After that, you will create the microservices in the case that it not exist. check if the new microservices and the old one more or less have sense, and in the results, if you split one endpoint into different endpoints, and you need to check if everything continue working or not. You can check the database or the endpoints. You need to define it. After that, you need to check and notify to the consumers. Check the advance and notify the consumer about that the new microservices it's on production, on a stage, so they will start to do the migration or have the possibility to start. And the last one is the most relevant, is deprecate the old microservices. So this is the entire process. Let's go in deep in the first step, which is define a plan to do the migration. And you need to consider different aspects. First one, define the goal. You need to put the emphasis on which is the purpose of this migration or this deprecation. What is the idea behind this? After that, you need to collect the information about which are your consumers and set some deadlines depending on the type of consumer, internal, externals. And after that, you need to define the strategy, which consider many things, that what happened with the new bugs or the new features on your API. After that, you need to define the responsibles, the different people that are responsible for the entire plan. Like, okay, who is responsible to communicate with my consumer? Who is responsible to define the technical documentation? These kind of things need to have a responsible. Communicate, so you need to define a way to communicate with all the consumers about this process of migration or deprecation. And you need to define a strategy to check or track the advances. And the last part on the plan is the deprecation and how you will decide to do the deprecation process. So all these steps or all these things need to have in a plan. So let's go in the first one. Define the goal. Martin Fowler used a phrase which I recommend, because if I only do the rewrite or a deprecation of one microservices and don't explain the idea or the goal or the purpose, the other person could feel that, oh, this is not relevant for me. I don't do this migration. Or I will do, but I put at the bottom of my backlog, and if I have time, I will do it. No, you need to specify the purpose of this migration. Okay, if you use the new microservices, you increase the performance. We have more support, more features, and it's relevant for us because we spend a lot of money on these old microservices, and we don't have more than one instance. You need to specify all in one or two sentences the idea or the goal that you want to do with the migration. And you need to be clear, because you communicate your intention to do this deprecation process using this goal. After that, you need to find the consumers. Whoa, this is one of the key parts, because you need to communicate with all the people who use your API. And there is not a unique way to do it. Sorry, but you need to collect the information using different tools. The first one is using APM like New Relic or Dynatrace. Perhaps you have a service map, so you can detect, okay, this microservices is used for this and this and this other microservices. So more or less you have an information and some kind of information, but perhaps you don't have these tools, or not all the teams use these tools. And the next way to obtain information is use Logstash on OpenSearch, some tools that give you the logs and give you some information like, I don't know, the IP address or the name of the consumer or some API key or some mechanism or user or something that give you some clues to combine this information with the previous one and have a big list of the consumer. And the last one is use other tools. Perhaps you have, I don't know, an email with the information of all the external consumer, or you wrote a page on Confluence on Notion with all the external consumer that your microservices have, and the contact information, like the responsible to this integration or this consumer is this person, and this is the email and the phone number. So there is not a unique way to collect all the information. You need to mix and obtain a list. After that, you need to define the deadlines, and you need to specify different deadlines depending on the type of consumers. And here, the first one are the early adopters, are teams or people or consumers that you have some kind of good relationship, and it's simple to send an email or contact and say, okay, we need to do a migration, and these people help as soon as possible and give you a lot of feedback. So for that reason, you dedicate more time and more resources to in this part for the early adopter to detect possible problems on the documentation, on the new API, or something is not clear. Next one, for the internal consumer. So all the APIs or microservices that are inside of my company. So there is a specific deadline for that people. And the last one for the external consumers. And here is one big problem, because you need to be have a long deadline with the external consumer depending on the size, because you need to be flexible, because the other external consumer have a different backlog, different priorities, and it's not the same that your company. And for that reason, it's relevant that you communicate in a good way. So what things you need to consider on the strategy? Well, what you want to do with the new features or the bugs that you detected on the old microservices, or the microservices that you want to deprecate. The next one is how you will roll out these new microservices, or how you roll out the deprecation process. After that, how you check the results between the old microservices and the new one, or the new microservices, and how you can track the advance of this process of migration. Who are the early adopters, the people who are your friends during this process, because are the first teams or people that stop to using your all microservices. And what you want to do with the request after the deadlines. Okay, I arrived to my last deadline, and I continue receiving requests. What I want to do with this request. So all these things you need to consider in the strategy to tackle this deprecation process, and you need to specify in a piece of paper, an email, a page on Notion, whatever that you want, but try to specify all these kind of things. Who are the responsibles, and who track the advance of this process? Perhaps it's just one person, perhaps it's different people, depending of the context. Perhaps there are one person who is responsible to do the communication with the external consumer, one for my internal, one person is responsible for write the technical documentation. So these kind of things need to be defined. So who communicates with the consumers, who create the technical documentation, as I mentioned, and how many people need to be responsible of the entire process. So you need to specify and put names to this task, because they are responsible that if the migration fail or success. After that, you need to define the communication method. Need to consider that there is not one communication method for all the consumers. Each consumer have different tools. Perhaps for some consumer, it's a good idea communicate by Slack and chat. For another one, is just send an email Another one just contact by phone. So the best scenario is when you have all the consumers, is like collect the information, which is the best scenario to communicate for each consumer. After that, you need to track the advances. So define the frequency to check the advance of the migration. And I don't know, once a week, once a month, and I don't know, each day, each Friday. And you need to consider these kind of things. And you need to do it. After that, you need to define the responsible for each consumer. Imagine that you have a big microservices that is used for a lot of external consumer. And perhaps the best scenario is split the responsibility. Okay, one person for the half of the consumer and another one for the other half. And you need to define these kind of things and how track the advance. And define the tool or the strategy to verify the advance. Okay, I will use New Relic. I will check the consumer. I will use the logs. I will put in a report. I will send an email. All these kind of things you need to define when you track the advance. And the last part, the deprecation process. Okay, you need to consider different aspects before doing the deprecation process. First is, okay, I need to send a notification to the consumer about that something will happen with the microservices. Okay, you send an email, you have a lot of meetings, but perhaps the people forgot. And the best scenario is like send a final notification to your consumers to notify at, I don't know, in the next month, I will stop the entire microservices. I will deprecate. It's like a remember. After that, you can check if there is some endpoints that don't have traffic or don't receive requests, and perhaps the best alternative is start throwing exception on this and that endpoint to reduce the risk that for some reason appear new consumer. It looks like a joke, but in my experience, this happened. So try to start to throw exception on the unused endpoint. After that, you can stop the microservices on non-productive environments. And the next is like find a strategy to reject or redirect the new request or the request that continue and go directly to your microservices. Take in consideration that if you redirect the request from the old microservices to a new one and you do some kind of transformation of the request, someone needs to be responsible to maintain this transformation. So it's not the best scenario or not the best alternative. And the last one is, okay, I will stop the microservices on non-productive environment. Okay, this is all part of the plan. Now it's like I need to create and check the new microservices in the case that is not exists. So I need to check and analyze each endpoint and the request and the response and need to verify which is the best scenario. Like, okay, I will split this endpoint because it's had a lot of information which is unnecessary. I will split into different endpoints or something like that. After that, you need to validate if everything continue working or not. And the next step is document the process to do this migration process. So it's so important that after you check and build everything, you need to build the documentation and write the documentation to do the migration. Okay, this endpoint now is this one, and the request is this for the new endpoint. All these kind of things need to be appearing in the documentation. The last part is deploy on production. You need to define the strategy, follow the plan, and deploy on production. Perhaps don't receive any request, but it's relevant for us that you deploy on production. So Next is notify and check the consumer. It's one of the most relevant part of the plan. It's like track the advance. Is like communicate, as I mentioned, using different methods. Detect possible plans and problems to follow the plan. Generate meetings with the team to detect if something is not clear, we have a lot of dudes or something like that. Perhaps the best scenario is like create a meeting and we discussed everything. And if something is not clear, we will update the documentation, register the advance of each consumer, and adjust the documentation and the deadline if you detect some kind of problem during this step of the process. And the last part is, okay, after some months, weeks, or years, you need to deprecate the old microservices. As a recommendation, just modify all the response to send in the headers the information about this endpoint will be deprecated. After that, send a formal notification about, okay, I send an email and the idea is deprecate these microservices. And the next month, after that, start to do the redirect or reject the microservices. And the last one is remove it. Okay, all these things need to be the same that you are defining the plan. You need to adjust the plan if something is not the same that appear on this part, on this step. And some best practices at the end. So create a plan and define all the steps. Require confirmation when you send a notification about the plan and you have a meeting, send an email and please ask about the confirmation if everything is okay or not, and to be sure that anyone are on the track of this deprecation process. Adjust the plan if the deadline change in the case that something bad happened. Stop slow, not stop altogether. Try to stop just one endpoint or one not productive environment, and after that, stop on the productive environment. The check and the create steps could be optional because perhaps you have a new option or a new version of the API, so it's not necessary that you build a new microservices. And the last one is define the responsibility. Perhaps more than one person is responsible for the entire process. And last, some additional resources. Here are some books for different purposes, for the purposes of testing, to build something new, best practices, and some blogs with a lot of information about this kind of process. And that is the end for me. So please, if you have any question or doubts, write on the chat, and in the QA, I will try to help you.
Thank you so much. Another great thought. Thank you for joining us. And that was right on the bell as well, on time. So thank you very much, Andres. And I hope to see you in the Q&A session in about half an hour.
Thanks. Bye.
Right. Bye-bye. So for our next speaker, which is William Collins, I don't see him yet. I might have to ask for some technical assistance here from my colleagues. So while I do that, apologies for a moment. Okay, I got some clarification on that already. So we'll be starting now with a presentation by William Collins. He's a principal cloud architect at Alkira. And he is also a AWS community builder, participating in events across cloud DevOps and monitoring. And today, the presentation will be addressing another challenging question, which we often encounter, which is basically, are microservices better than monoliths? So quite an ambitious question, and I look forward to seeing William's presentation on that. I will just prepare that for a moment.
And welcome. My name is William Collins, and I have a pretty fun and polarizing topic today. So, Kubernetes, it's wreaking havoc on the software world as we know it. Monolithic applications, they're getting kicked to the curb. They're going on conveyor belts, and they're getting converted to microservices. Except, many are coming out the other end as distributed monoliths. And even when done the right way, may not make sense. So take Amazon, for instance, specifically the engineering team for Prime Video. They just released a blog about transitioning from microservice architecture back to monolithic architecture, specifically for their video quality analysis service. So the question I want to look at today is, are microservices better than monoliths? Let's explore. To start things off, I just want to give a brief overview of my background, a little about my experience, and then I want to set the stage, create a narrative, and add some context. Just go over some terminology. And from there, I want to highlight why going to extremes when it comes to technology, saying, hey, you must do everything this way. If you do it any other way, you're wrong. This tends to wreak havoc long term. And last, we're going to get to the conclusion. We're going to come up with an answer, which is better. So I've been doing this stuff for a long time, over 15 years. In the past, I started out in technology around the time VM adoption really started taking place in the early 2000s. And I've been through a lot of major shifts in the technical landscape, from automation actually becoming a first-class citizen to the explosion of cloud computing. Presently, I work for a startup called Alkira. We build multi-cloud network software. I participate in the AWS Community Builder program, and I'm also a LinkedIn learning instructor. So, a monolithic architecture, many of you probably already know all this, but I'm going to go over it anyway, usually consists of a server-side application, some database, and a client-side interface, all of which they're going to get deployed as a single unit. So you could even have a monolith, built in the cloud, constructed with cloud-native constructs, and an application running on a virtual machine, deployed with CI/CD from top to bottom. But even though it's built in the cloud, it's fully automated, it's still a monolith. Now, microservice architecture, that's going to break up this application into loosely coupled, independently deployed services. No shared database to see here, folks. Each service is going to have its own code base, its own database, and its own management model. And Kubernetes has emerged is the vehicle of choice for service orchestration here. So, some common criticisms for each of these architectures. I think this is just fair. And some of these are going to be pretty broad generalizations, but I just want to give each of them a fair shake before I inject any of my own observations or opinions into the conversation. So, diminished understanding over time of the architecture. This is a big one, and this is important. And this is when I was working in the enterprise space doing these large modernization initiatives. This is the one that really hurt the most when trying to take one architecture and refactor it to another. Because when you think about it, a lot of large companies, the applications that make them money, they've been around for a while. They've had a lot of software developers coming in the company and leaving that have left their mark on that application, and it's morphed, it's transformed, and it's coupled very tightly with the infrastructure that underpins the whole application. You have a lot of specializations, a lot of different teams involved. Maybe there's a DNS specialist. There's somebody that manages the certs. There's somebody that manages the network. And anytime the application has a problem, you have to spin up a Zoom call with 100 people on it, and everybody, it's all hands on deck. So I think this is really the biggest for me, just in my experience, as far as what ends up being problematic. Lack of modularity, thus limiting reuse, replacement of components. This is pretty big as well. Having a specific part of that application that you want to take, update in place without affecting everything else, or even repeating a lot of the stuff, like a lot of the design, take like software design patterns, repeat them into new things. This can be problematic and difficult. Scaling complexity. Yeah, you can scale the entire application, but not specific parts of that application, like specific services. This is a fair criticism. And if you think about just scaling complexity more broadly, like the big critique and criticism for monoliths are, they don't scale good horizontally. So you have these massive, think Twitter or Uber, global scale. This is a fair critique, I suppose. Slower innovation coupled with vastly competitive markets. So, hey, competition is hard right now. Your competitors, if you have an idea and you don't jump on it, who is jumping on it is your competitors, and they're going to churn it out. And, that's going to bode well for them in the market. They're going to eat away at your market share. So your ability to innovate and update this application, make it more valuable to your customers is critical. And if you can't do that very well, this is problematic for the business as a whole. So microservices, in my experience, I've had a lot of, I'd say, experiences with, in the enterprise space where microservices have been positioned as the end all be all. Like, it has to be a microservice if it's going to be good. Hey, Google does it. Google runs this Kubernetes like crazy. They're doing a great job. Twitter, massive scale, Uber. Hey, we got to do that too if we're going to be good. Not in all cases. So transitioning from monoliths requires a deep understanding and refactoring. And this is, this is huge. So some of the things that I worked on in the past, it's, to say that it's difficult is an understatement. It's like, I'm like climbing Mount Everest in like a tank top, and, there's folks at the top like rolling down boulders on me. It's an uphill battle for sure. And part of that goes back to the first bullet point with the monolithic architecture, like that diminished understanding and all the hands in the cookie jar, understanding everything and trying to do it the right way without distributing the monolith. So distributed nature adds complexity to testing, increased overhead with growth. This is, testing is often, it's talked about a ton, but it's not taken a lot of times as a first-class citizen. So if you don't have good testing practices when you were building monoliths, you're not probably going to have the good testing practices when you build microservices. And testing, which should ultimately become a habit before you're doing deployments. You should write tests almost first before going on to anything else. This is just huge, and it gets a lot more complex when you look at microservices. Visibility and traceability challenges, new tooling, new operations. So the operations teams and how you support, applications in a monolithic style. There's, I know operations is operations, but it changes a lot with the microservice architecture quite a bit. And operations has a tough time. They get, if anything goes wrong, usually it lands on them. And so thinking about their success and, that you're judged by how quickly they can fix issues, having a good operations in place to manage this new architecture is absolutely critical. And that is more, is a transitioning phase. It's harder when you're in a brownfield environment. Greenfield, you're starting out new, you're just building a new product from the ground up, not so much, but anything brownfield, definitely complicated. Increased moving parts create a larger attack surface, many new points of ingress and egress. This is, think of it like think of it like electric vehicles, EVs. So I was talking to someone at reInvent last year, actually, and they were talking to me about they got one of the first Tesla Model 3s that came out, like the first generation of the Model 3 years back. And they were telling me that all that they've had to do with this EV is get the tires changed a few times and the brakes changed. They haven't had to do anything else. They haven't had any problems. Well, guess what? This EV doesn't have a ton of moving parts in it. You know, if you look at a combustion engine vehicle, you're changing the oil, updating the fluids. You know, you have a lot of things going on, a lot of care and feeding, a lot of maintenance to do to make sure it, you know, continues operating at a healthy, healthy state. So increased moving parts just get more, you know, complex. You know, there's more things to think about. There's more friction, well, potential friction, obviously. So back to our question, are microservices better than monoliths? Now, I think, you know, words mean things, and making sure that we have the right idea of the word is important. So what does better mean in this context? So what better place to look than the dictionary? So of superior quality or excellence, morally superior, more virtuous. Coincidentally, both of these definitions, in my experience, fit perfectly because a lot of times, you know, microservices are deemed as far superior quality or excellence. It's not viewed as like a technology and a solution, you know, the right solution for the right problem. It's viewed as, okay, this is just better 100% of the time. And then, you know, a lot of the folks that I would have to go elbow to elbow with, you know, and sort of debate this with, they were standing on a morally superior high ground because they had the better thing. It didn't, you know, nothing else mattered. It became like tunnel vision. You know, microservices are better. So why aren't we doing them? Now, consider the following. Everything breaks. Technology, yeah, you're going to have outages. How fast can an operations team restore service? And if not, if they can't actually fix the problem in real time, if it's not in their power, how fast can they identify the fault and actually escalate it to the team internally or a specific vendor? You know, finding it, you know, just basically getting that service restored as quickly as possible. You know, that's, if you're running, you know, you have a business and you have, you know, applications that are, you know, the bread and butter of your business. They're driving the revenue and they're down for 6 hours, you know, and some businesses, this costs millions and millions of dollars. You know, that's not good. So getting to the point to where, you know, you have the right operations flow in place, you understand what's going on, and you can restore service is absolutely critical. So the dreaded distributed monolith, built like a monolith, deployed like a microservice. So one of the things that's great about the way that technology happens today, and one of the great things that practitioners can do is shorten the feedback loop. So when you're building something or you're migrating something or you're transitioning from one architecture to another, you have to get feedback on how it's going. You have to, you know, you've got to really dig in and you have to get this feedback loop going. So one of the things I would do in order to, you know, kind of get this feedback and just kind of start a good conversation is asking the right questions. So I had a few questions I would ask in these application modernization initiatives to kind of figure out, okay, are we really distributing the monolith? How do we even identify that? Because it's something that we don't want to do. We want this to be valuable. You know, we want to do it the right way. So the first question, you know, really usually on the money, are any of our microservices sharing a data store? A lot of times the answer was yes. And is our rockstar developer working across numerous, all the microservices? And not only that, is he also helping build the underlying infrastructure in the cloud, you know, building some infrastructure as code and, you know, working across all these areas? Because that person is going to get worn out. They're going to get burnt out, and you're going to end up losing them. That's not good. Does pushing a change to one microservice require changes to all the others? If it does, then this kind of defeats the purpose of independently deployable services. So if you get to the point where you're doing this, you may want to reevaluate just, hey, why are we doing this? Are we actually solving a problem? And are we picking the right solution for this problem? So dealing in extremes. I have a family, I have a wife and 2 young children. And with these children, honestly, I feel like I'm an Uber driver. I'm always driving, sports, school, trips, this, that, activities, always in the car. So as our 2 children got to be a little bit older, got bigger, we had a sedan, and we decided, hey, we're going to up our game. We're going to get an SUV. We need a little more room. We want to be more comfortable, and we do a lot of driving. So this was a great idea. The one we had picked out, it seats 6 total. So we can fit us 4, and then we have room for 2 more. And not only that, but in the back, there's, a good amount of cargo space. Great. And then if we need more space, it has the roof rack. Fantastic. And EPA estimated 21 city, 28 highway. Music to my ears. Great fuel economy. It fits in my driveway. This is always important. You want to have somewhere where you can park it. And my wife likes the way it looks. This is always a recipe for a winning scenario. Now, I begin to look at these numbers and I think, okay, yeah, this is good. But what happens if we decide to have more kids? I hope my wife never watches this, which she probably won't. But yeah, I hope that we future-proof enough in the event that our family grows. So I take this mindset. We could have more kids. Our family could grow. We may need more cargo space. So these wheels, they start turning in my head, and I say, hey, I got an idea. I'm going to future-proof for like a long way out. I'm going to go buy a school bus. This is such a good idea. You know why? 72 total occupants. I'm future-proofing for every possible outcome into the future. Great. Not only that, but outside underbody cargo. I don't know if you've looked in some of these bigger buses, but you look in that cargo area, you could have a slumber party in there. There's plenty of room. More room, definitely future-proofing, for the cargo space. 6 miles per gallon. Ugh. Well, that doesn't sound so good. But it has an 80-gallon tank. I still get, 480 miles per fill. We'll punt that to the future. We'll think about that later on. And it doesn't fit in my driveway. Well, maybe we could park it in front of the house. The HOA probably won't get too mad. They won't kick us out. Or maybe we could just park it in the yard. We'll just worry about that after we buy it and after we actually start doing all the work. Okay, fine. And my wife hates the way it looks. We'll just forget about that. So you can see how I jumped to an extreme. I sort of took this idea that, okay, instead of solving, really looking at it as a problem and a solution, I said, hey, I want to plan for every possible outcome as far as I can see into the future, without thinking about the cost, without really thinking about the details. So you can see this may seem like a really, kind of a trivial or like a stupid example, but when you think about it, this is exactly what happens in technology. A lot of times you'll have leaderships that come and they say, hey, Google's doing it this way, again, with the Kubernetes, or, Amazon did this. They wrote a blog about this, or I was at some conference and I saw this. We have to do everything this way now. And it's never that simple. technology always brings that it depends scenario along with it. So that begs the question, when to use what? Like, what are some sort of like a guidepost for when you should monolith and when you should microservice? So monoliths, if you got a small team and you've got limited resources, probably a good thing to look at. Predictable. Like, if you have a predictable scale, you're not going to be, you're not aiming to be the next Twitter. You don't have this gigantic global scale. You're not, serving just, billions of API requests. The complexity is like you understand it. Okay, monolith. Hey, if you don't have any microservices experience, back to that car analogy. And continuing with the car analogies, I guess, if I decided, hey, I'm going to swap out the transmission in my vehicle. Well, never done that before. I've never even changed oil, maybe. So, okay, I'll have the transmission delivered. I'll buy all the tools, and maybe I can watch the YouTubes and read enough to where I can actually get it done. I might break a few things along the way. And hey, I might actually mess up something so bad that I have to buy another transmission. Well, avoiding all that would be great. So I want to have somebody in my court that's maybe done it before that can help guide me along. So not having that microservice experience can be problematic if you're looking at this. And at the end of the day, you want to meet business requirements. Technology's there, to make the business successful. And a thriving business means, more money that gets circulated back into IT, more investment in people, more investment in tools and technologies. So, you want to be adding value to the business. Microservices, hey, if you got a large team, you've got adequate resources, and it's the right solution for the problem, run with it. Let's roll. And you have that horizontal scale, like that gigantic horizontal scale. Maybe you do have the next Twitter or the next Uber or one of these apps, but you have that scale and the growth, you're expecting just a massive amount of growth. Microservices. Hey, you have some folks in your court that have done this before. They understand the operational aspect of things. They've built these out. They've maybe lived through a few problems with microservices. They've learned, and they really have a good idea for how to do it now. Having that experience is key. And at the end of the day, if that monolith that you've built, if it can't support the growth that your business needs, and it's not meeting business goals, hey, you've got to look at something else. You have to look at a new pattern, or you've got to do something. So microservice might be your answer. Netflix published a blog, I think it was back in like 2016, about their transition to cloud and microservices. And I think it was like by 2013, the Netflix API gateway was handing out somewhere in the ballpark of 2 billion daily requests. Now that's thinking about, the context of scale, and, having a problem like that they had to solve, and why moving to microservices was the answer. That's why. Thinking about the scale of Netflix and the amount of requests, that horizontal scale. So just keeping things in perspective. So back to that question, which is better? So I'm going to pull a major party foul here and answer this with another question. Are apples better than oranges? So, sorry for that. Technology, when you think about it, so technology, value and business, they're almost symbiotic at this point. You can't get a budget and deploy technology without a thriving business. And, that business is usually delivering, direct or indirect value to customers via technology. So to execute this beautiful symphony, these three need to work in harmony. So, what really matters? Delivering the best possible product and the best possible experience to the customer with the resources available to you while delivering on your business goals. So I know it's hard not to get hung up on the new and shiny sometimes, and we forget that technology is there to offer solutions to problems and create value for business and its customers. Thank you for tuning in. I really appreciate it, and I hope this session was valuable. You can find me at William-Collins on LinkedIn and WCollins502 on the Twitters. And I also blog regularly at wcollins.io.
Big thanks to William for putting that presentation together. We're right on time as well, a couple of minutes ahead of time, actually. And what's next on the agenda is basically the last item of today, which is the Q&A session. And what we'll be doing for those who have been at the rest of the day is exactly the same as the other Q&A sessions. We will be going through the questions that you've been kind enough to post during the past few presentations. William, unfortunately, who did the last presentation there, will not be joining us, but we are joined by Tanmoy and Anders, so I will be adding those to the scene here. There is Anders and Tanmoy as well. Okay, I think we are complete. That's good. Okay, great. So I'll do my best to moderate the questions that have been posted. There were a few questions I noticed that were posted for the previous presentations that they didn't have time to go through in the Q&A session. So I'm not sure if they relate to any of your experience and so on, but we can take those last in case we have time left and see where that gets us. Okay, I think we'll just kick it off. So I'll start with the first question that was posted. Just let me get my bearings. Okay, so I'll start with the first one is for you, Tanmoy.
Okay.
And the question posted was, I will show it on the screen as well. Did you try data drift feature on that account, or was it for potential usage only? And I'll admit, I'm not entirely sure what the reference is, but I hope that you do.
Yeah, I got the reference. Yeah. So a data drift is one of the features of Azure machine learning, which allows them to, which allows the users or the team to detect if there any change in the data, in the data that is actually being used for prediction, and is there any change in the data schema from the. So there is a data which is used for training the model, right? And then there's data which is used for predicting the results. So if there is a drift in these two data sets, right? If there is change in schema, so that is called data drift. And that feature is currently in preview in Azure ML. So as per our best practice, we're not supposed to use any preview feature in any of our production solutions. That is why we didn't try out this feature yet, but we're waiting for this feature to become generally available. Once it becomes GA, then definitely we are planning to use it. Because and at this point we didn't require it because data drift is a very high, that the requirement of data drift is actually a very higher level of maturity model. Like it basically, when you go to the highest maturity model 4, right? That time basically data drift and model monitoring, these things comes into picture. For our case, since we have started with the maturity model 2, which really do not require model monitoring and data drift monitoring, so we are okay not to use it. But definitely, as we progress to higher maturity model, and when this particular feature becomes GA, then we are going to use it.
Thank you very much. I'll just move right on to the next one, which is for Anders. And the question is, any advice on how to document the migration process?
This is one of the most important part, how document the advance or the migration process. It's depend, like always, it's depend of your company. In my case, I use Confluence, Notion. Try to use some tool that is accessible for anyone inside of your company, because it's a good way to share the information. Just send a link and anyone can access. Of course, if someone is outside of your company, this information is not accessible, but it's dependent of your company. Try to put all the information, all the detail, all the meetings, all the track, all the advances, put in that tool. Not I have a sheet on Google Docs or an Excel with all the information or tracked advance of each consumer migrate or stop to using. Try to put all information need to be accessible, so anyone can track this kind of advance.
Okay, thank you for that answer. The next question is for Tanmoy. So I'll read it out as well in case someone who do not have visibility on the screen. So the question is, how did you compare cost for CPU versus GPU instances? Is it any tools to measure performance on different instance types to evaluate multiple options?
Okay, so for cost comparison, so Azure has the Azure pricing calculator. You can just Google it, and you can directly land to the pricing calculator page, where actually you can select your CPU and GPU instances and its configurations, right? Size, memory, etc., and it will give you the expected cost. So the pricing calculator is the answer for comparing the cost. And your second question, any tools to measure performance on different instance types to evaluate multiple options? So the performance, of course, depends on your configuration, right? So higher your machine or VM configuration, you'll get a better. You're expected to get a better performance. But again, like what CPU config, what VM configuration you should be using, that you should determine yourself. You should be doing a fine tuning based on your logs, right? How your model is performing based on the logs. You can either scale up or scale down, or add more memory or add more CPU depending on your performance. So yeah, it's a process that you have to go through, looking at the logs and how it is currently performing, and accordingly take a decision.
Okay. Excellent. I'm just gonna move through the queue here. The next one is again for you, Tanmoy. You're a very popular presenter today. Have you experienced performance issues like poor models response time? How did you tackle it?
Yeah, I think in this case, when you're talking about the poor response time, right? I think you're talking about an online or a real-time model, right? So only a real-time model will be called from a consumer application and expect a response in real time and very immediately, I think. But our use case was not really real time. Our is a batch inference. So basically, there is no consumer application which calls that model endpoint in real time and expects to get a data. There's a data pipeline which sends the input data to the model, and the model does a batch calculation, batch prediction, and stores in the storage. So it happens in the offline process in the background. So that is not what. So that is our problem. That is our batch scoring thing. So if you're facing some performance issue with your real-time inferencing, I believe it could be a scaling issue. So you should check, and also depends where you have actually deployed the model. If you have deployed in a, say for example, there are many options you can deploy a real-time inference model, right? You can deploy in a Azure container instance, you can deploy in an AKS, or you can deploy in a managed endpoint. Okay. So if you are deployed in an ACI container instance, that is not very scalable. So probably under high load, it will not scale well and the performance will be poor. But if you are deployed to AKS or in a managed real-time, online managed endpoint, those are auto scalable, right? So I think you should try with enabling auto scaling, or try to scale up or scale up or scale out those instances based on your load. And I hope you should be able to get good performance.
Thank you again. The next one is for you, Andres, and the question is, what do you think about all the applications should start as a modular monolith as a good way of defining bounded context that in a near future could be a good candidate to be a microservice. I'm parsing this question as I'm reading it, but maybe I'll let you interpret as you see fit.
Okay, let's start from the beginning. Okay.
Okay, sorry. There was an appendix to this one as well, so I'll read that also before we continue.
Okay.
Because sometimes microservices have hard dependency to others through API REST endpoints because they were created too soon. Transportation latency is most of the times not taken into consideration.
Yeah, let's start from the beginning. If you have a big microservices like a monolith, the first approach that you could do is split on different domains and try to identify which endpoints are part of each domain, and after that you start to create the different endpoints and draw in some tool which is the connection between the different domains. And I don't suggest that you refactor your monolith to this match with this domain. Like, okay, if I have some module that is responsible for the user or some module that is responsible for the orders in an e-commerce website, just try to create a new microservices that more or less respect the business logic about, okay, I need to create a order, I need to pay a order or something like that. And after that, start to do the migration. And the migration you can do using different strategies, like the strangler pattern, like stop to drop or remove part of the logic and put in a microservices. And perhaps you can use a feature flag for the monolith continue receiving the request, and with the feature flag you redirect this request to the new microservices. This could be the same approach that you can do if you have all microservices and a new one, and in the same context, and you have more or less the same endpoints. If you want to check if everything is okay or not, you can put a feature flag. Feature flag is a concept like an A/B testing. So when you receive the request and you do an HTTP request to the new microservices and check if everything works or not. And the person who did this question mentioned something that it's more clear or is relevant. You don't consider the latency. When you split a monolith into a lot of microservices, you don't consider the latency between the different microservices and the volume of the information that you transfer from one place for another one. So you need to find strategies to reduce this transfer between the different microservices. You can compress the traffic, JZip, the traffic. You can use different mechanisms of cache, near cache, in proxy, or external cache to reduce this kind of communication. And because depend of your cloud provider, this communication implies money and time. So if you use different mechanisms of cache or compress the size of the request, you spend less time to do or to obtain the information. So I try to explain everything in one answer.
I guess that ties back to something else you mentioned in your presentation as well, about the importance of, let's say, focusing on metrics and trying to get a clear shared understanding of what is important. In other words, maybe it also applies to this use case where what sort of latency is acceptable in a transitory period while you migrate onto some target solution.
Yeah, you need to collect metrics, and in the case that for some reason your all microservices or monolith is unperformant and have a lot of issues, you need to put like a goal. You need to communicate, okay, we need to do this migration because the old one spend a lot of resources, is waste a lot of my infrastructure. So if you do the migration, I give you a response quickly. I spend less money, have more support. I can include a lot of features that you want for my API. But all these kind of things need to be appear as part in a sentence of the goal of the migration plan or the deprecation plan. And because it's not clear, perhaps the consumers or the other teams say, and for me, it's not relevant. It's for you. You want to do the deprecation. For me, what is the idea that I go quickly to modify my entire microservices for you? What I earn or win with this migration, with this deprecation?
Yeah. Okay, thank you for expanding on that. The next question is also on the API migration, and that is basically related to something I also saw was discussed in the previous Q&A session, which is technical debt. So in this case, the question is then for you, how do you manage technical debt in a migration process?
You have two alternatives to do this. And my idea of this, or my approach, my suggestion to do this is try to reduce the gap when you start to do something new. And you have two or more alternatives, the good way and the bad way, but quickly. Perhaps if you need to solve a problem, try to do in a bad way. It's not a recommended option, but it's okay. It depends on the business. But try to create a new issue in Notion, Jira, or whatever, and try to coordinate with your team to decide more or less which are the window to tackle all of the technical debt. Try to not say, okay, I don't know, in 2 months we tackle all the technical debt. It's like, okay, spend, I don't know, 1 day or 2 days in your sprint, in the case that you use Agile, to solve some performance issues or something related with the technical debt. It's like when you pay to go to the gym. It's like not use just once in a month and do exercise. Try to do a little exercise each day, and it's simple for the team to maintain keep the process of these small improvements to reduce the technical debt. Is not delegate to at the end of the month or at the end of the year. One thing it's connected to reduce also the technical debt is try when you do something and you need to consider the trade-off between 2 or more options. Try to create an ADR, architecture decision record, in the case that you need to take a decision about the architecture of your microservices, and put the pros and the cons, and decide with your team which is the best scenario or which idea is the best for this situation. Because when we decide something, we never track which are the alternatives. It's like we will use Java. Instead, I don't know, Scala. Why? Because Scala is not very popular. And when, I don't know, 10 years before that you create your microservices, someone asks why you choose Java instead, I don't know, another language. I don't have documentation about your process. And the same happens when you decide something in your microservices. To manage the technical debt, it's like have a document that explain which is your idea and perhaps which way you choose to do for now, because I don't know, the business need something quickly, and it's not possible to have a lot of time to analyze or to do the best alternative.
So you're essentially saying that with technical debt, it's essentially like everything else. It's a matter of trade-offs, and you have to sort of try and take an incremental approach to it, as opposed to like one of the comments I think you used from Martin Fowler, a big bang approach to technical debt, and rather had it be sort of an integral part of the process.
Yeah, try to do it each day or each sprint. Try to dedicate a piece of the sprint to tackle one or two issues that reduce the technical debt. Not consolidate in one sprint that all the members of the team try to tackle the technical debt, because something happened during these 2 weeks. Something happened on production, something happened with the meetings. So it's impossible that all the team is focused on the technical debt. So if one person on the team is only have the focus on solve 2 tickets, it's more achievable that if all the teams start to tackle at the same time.
Yeah. Okay. Thanks again. I do want to try and keep the promise I made in the beginning to address those questions that were not addressed in a previous Q&A session. Hopefully, maybe someone has some commentary on those. So I'll just take the first one and we'll kind of see how it goes. Tanmoy, at least this one might be relevant for you because you spoke about machine learning, which is obviously a close relative to artificial intelligence. So the question was basically, what do you guys think of using AI for code analysis, like ChatGPT, doing reviews on Git commits for testing code quality, and so on? I know it's a bit of a tangent to the topic that you presented, but yeah, wanted to leave it out there in case you had comments on that. Or anybody else for that matter. You also, Andres.
Sorry, I was speaking on mute. Yeah, sorry. Okay, ChatGPT. Yeah. So code analysis for ChatGPT. Yeah, I did some research on this because I had the same idea of getting our code reviewed by ChatGPT because it's quite good at this task. But what I found out, if you have some proprietary code, right, which you're writing for some clients or some organization, those are confidential ones. And ChatGPT API is not a private API. You are going to internet for getting the code quality verified, right? So it's not quite advisable. Even I checked with Microsoft also on this. So they also said it's not advisable to get your confidential or proprietary code reviewed by ChatGPT. But if it's a publicly available code, right, you are writing some, publishing something on the GitHub or something, those are fine. I think those are publicly accessible. But code which are proprietary, I think the guidance from even Microsoft was not to get it reviewed by ChatGPT because of the confidentiality issues. That is my view on this.
Yeah,
I
think that's. Go ahead.
Sorry, Steve. I have recently an experience using AA with the testing. There are a tool which is Report Portal. So if you create tests using any languages like Java, Scala, PHP, Node.js, I think you can publish the results and the stack trace or the console log of your test to this tool, and this tool analyze the test and the results and the console log, and perhaps give you an overview of possible problems that your microservices or your library have. So you can categorize and you can say, okay, perhaps my test passed, but appear a lot of error, exception on the console log, and this could be a problem. And so take in consideration some things and show you like as a result, as a summary about the possible issues, and suggest, okay, perhaps you can create or track these kind of things. It's different like Sonar, because with Sonar just we know the coverage and detect the possible problem. In this case, it's like take the results of my test and the console log and analyze and produce a result. It's not, I don't know why it's not so popular, but have a lot of documentation.
Yeah, I think it's fair to say that there's a lot of chatter these days in the industry about expanding into the, for example, static analysis or more security tooling side of AI, and some tooling has already started penetrating that market. When it comes to code quality, though, I think that's also maybe a bit of an overloaded term. It could be related to security, but it's not necessarily related to security. You could also have a sort of internal proprietary definition of what code quality is. And then, of course, the tooling needs to sort of accommodate that, that flexibility. But very, very interesting space for sure. And we actually just have one question left. And I'll just put that on the screen as well, because we have 8 minutes left, and yeah, want to make good use of it. With your excellent background, what can you say to a system architect who inspires to be a good solution architect? And I know there probably might be some terminology things that need to be clarified first there, but I'll just leave it to the floor to you, Tanmoy or Andres, to jump in.
Yeah, Andres, go on.
I think you need to think that your solution is not the best. And you need to keep learning. Or in my case, I always try to learn, assist to conference, and try to figure out different alternatives. For example, I use previous to learn everything. I try to learn how communicate my decisions. So I investigate and I learn about the use of ADRs. These kind of things improve the quality, not just for you, for your team, because all the team members discuss about an idea. And with this discussion, you learn a lot. And perhaps you decide something that is not clear, or is, I don't know. In my case, I want to use this specific tool, and I put all the trade-off, the pros and the cons, and I modify, like, it's like the tendency, like, to use this. And when you discuss using this kind of methodology, and you need to show all your argument to another person. So you need to learn continuous, and for the best, read books or assist to this kind of conference, and listen to other people, and just not put your ideas or try to listen other people, and not decide just you in your company. It's like a team decision, not a. It's like, in my case, I am a team leader. I will decide for all the team. No, wait. There are other people that need to understand the context. They need to be agree with my decision. So I need to show my arguments, and all together need to decide something.
I don't know if Tanmoy, you want to jump in there. If not, I'm happy to.
Yeah, from my side, I want to quickly add that, see, I do not understand this term system architect. I understand application architect, data architect, solution architects. By system architect, if the questioner meant that he's just architect in a specific area, for example, he's an application architect, and the question is how he or she can go into to be a solution architect. Yeah, you have to expand your breadth of expertise, right? So, for example, I was an application architect before. Now I'm working as a solution architect. So my expertise was more on the application side of things, like in .NET or any other web-based applications. Now I'm working on the artificial intelligence, analytics, and data side of stuff. So I have just expanded my knowledge, and I've just actually taken up projects which are having end-to-end involvement, like not only the application side, so also on the data side. So you have to expand your horizon, like from everywhere, from application, middleware, data, analytics, everywhere. So that's breadth of knowledge is important to become a solution architect, so that you can see the whole picture, right? The end-to-end picture. So solution architect is all about giving an end-to-end solution, not a particular application, but the solution. The application needs data, right? And data comes from various sources. How do you ingest the data? So all this stuff is part of the solution architecture. So yeah, that's about it. I mean, you have to expand your breadth of your knowledge and breadth of your understanding of all aspects of a solution. So that's how you can grow to be a solution architect.
And I was hoping to just hope I don't trespass on my role as a moderator here, but it's pretty close to home, so I just want to add a couple of comments. And I've both been on the system side and now solution architecture. And I think, first of all, we're not very good very often to name things in our industry. So you can meet 5 solution architects and they have 10 different answers on what they actually do, and they don't necessarily correlate. But in my experience, there's basically a sliding scale where on one end you are quite on the detail level, on the system level. You might be an application architect or system architect, again, might have many names. And as you move closer to the customer side, you basically go through the sort of realm of solution architecture, and then at the end, something called enterprise architecture. Right. And like that is sort of that is my experience from those terms. And in the middle there sits the solution architecture. And I think it entails a lot of things when you sit in that spot, because you have, let's say, a different set of stakeholders that have different metrics that they measure you on compared to being on the system level, where you don't necessarily have to talk that much about SLAs and uptime and so on. You have to talk about business objectives and things that are very hard to sort of get to the bottom of often. So in my experience, communication skills has been really one of the sort of standout skills that I've seen with other solution architects that excel in what they do, in that they are able to ask the right questions and really have that sort of inquisitive talent, let's say, to take something that is super abstract and unclear and somehow end up with requirements that you can implement and actually use to deliver business value. And it's an extremely challenging job, but it's also of course, very, very interesting and diverse. So yeah, I know we're almost coming out of time, and I saw that Anna came online as well. So I don't know if we have time for any more questions. There are actually no more questions left either. So from my perspective, that's pretty much it.
I was just trying to add myself to the stream, and it was not letting me do. So yeah, thank you so much for your amazing presentation, for the amazing moderating of the last part of the event. Usually people are a little bit tired by then, but it was really, really, really nice, and I enjoyed, and it was really useful from my side because so many insights for my own application that we have. And it was really useful. Thank you so much for that. For everyone who is still there with us, we still have one day tomorrow, Pro Day. Please join us, and hope you will get even more excited information that we prepared for you. Thank you, everyone, and have an amazing night, day, morning, whatever you have.
Thank you. You too.
Thank you.
Thank you all.
Hope to see you at our next event as well. I know Andres especially API, and looks like he got one more proposal. So yeah, please join us, and we're always glad to have you with us.
Thank you.
Thank you.
See you.
Nice day.
Bye. Bye.
Bye.